Yeah.
Good morning. My name is Ali Munir, and I am serving as a designated federal official to the U.S. EPA Science Advisory Committee on Chemicals, or the SAC, for this meeting. And in my role, I will be opening the second day of the public meeting on EPA's 2024 draft risk evaluation for 1,3-butadiene. I would like to repeat that the SAC meetings are subject to all FACA requirements. These include open meetings, timely public notice of meetings, and document availability to the public. All documents are available to the public in the docket at regulations.gov. See the docket number in the meeting agenda. Also, this meeting is being webcasted, transcribed, and recorded. A live stream of today's meeting is available on YouTube. See the link on the meeting website. The meeting is listed in the agenda, which also has a link to yesterday's meeting. We had a successful meeting yesterday, and I would like to thank the SAC and the ad hoc peer reviewers and the EPA team for their presentations, and to the public, and also for their oral public comments, and all the discussions that we had yesterday. I would like to now hand it over to Dr. Cobb. Dr. Cobb?
Thank you, Ms. Munir. Welcome, everyone, to our second day. And I'd like to echo the thanks for the good discussion we had yesterday, and looking forward to a couple of more days of meetings. A little bit of housekeeping. We've gotten through some of these meetings a day or so early in the past. I'm looking at the schedule. That does not look like it's going to happen. So I'm pretty sure we're going to be going into Friday, and that's what's scheduled. But a lot of times we do end up going shorter, and I'm not necessarily anticipating that for this meeting. So the first order of business today is simply to take the roll. And so I'd like to start by doing that. And let's start with the SAC members. Dr. Apte.
Hi, I'm here.
Dr. Chason.
I'm here.
Dr. Ike.
Good morning, I'm here.
Dr. Fox.
Good morning.
Dr. Gentry.
Good morning.
And Dr. Graham's not here. Dr. Heiger-Bernays.
Here.
Ms. Jenkins.
Here.
Dr. Merced Nebies.
Good morning.
Sorry, my throat caught. I've got that frog in my throat today. Dr. Rubin.
Here.
Dr. Semmel.
Yes, good morning. I'm here.
Mr. Wright.
Good morning. I'm here.
All right. And for our ad hoc members, Dr. Santos Burgoa.
Hi, I'm here. Good morning.
Dr. Roby.
Good morning, I'm here.
Dr. Johnson.
Virtually present.
Dr. McKenzie.
Good morning, I'm here.
Dr. Fairbrother.
Yes, good morning.
Dr. Eastman.
Good morning. I'm here as well.
Dr. Hopkins.
Trouble with my video, but I'm here.
All right. Dr. Bean Friedman.
Hi, I'm here.
Okay. Dr. Fenner Crisp. Just
Good
saw
morning,
you.
I'm here.
Okay. And Dr. Mayer.
Good morning.
George.
Okay.
This is Mary Ann Ottinger.
Oh, Mary Ann, you're on.
Yep.
Thank you for joining.
Okay.
I think that's everyone who has not told us that they were going to be absent. So now we can move into a revisit of any questions that you might have that the committee might have relative to the presentations that we saw yesterday. Sometimes those questions come up as you're thinking through the discussion. So I'd like to open this time up for discussions. Dr. McKenzie.
Yes, thank you. I just wanted to ask for clarification on the HEM model, if that is considering aggregate exposures at the census block level.
Hi, good morning. This is Kit Lee with EPA. Yes, the presentation for general population exposure assessment yesterday, I made it a point that the HEM model does take into consideration aggregate risk estimates at the census blocks.
Thank you.
Thank you for your question.
And this is George Cobb. Kit, just to follow up on that, that's aggregate 1,3-butadiene exposures, not aggregate exposures to other potential chemicals.
Yes, it's aggregate exposures from 1,3-butadiene facilities that we modeled. So that would be the TRI facilities. Right.
Yes, but also not from other sources.
That's correct.
Okay.
Not from other sources.
And does that help, Dr. McKenzie?
Yes, yes. Just wanted to make sure I was clear as I'm writing my comments. Thank you.
Thank you, Dr. McKenzie.
This is George Cobb. I had a question, and it's probably a very mundane question, but when you were looking at the atmospheric modeling data towards the end, the units of 1,3-butadiene concentrations were reported in something to the effect of micrograms per cubic meter, and all of the toxicity data is reported in parts per million, and some of the monitoring data, actually most of the monitoring data, was reported in parts per million. So does this document, or does EPA have a conversion factor that you've used, and what were the conditions under which, or the assumptions about those conversions?
Dr. Kopp, this is Kit Lee with EPA. Could you repeat that question? Did we convert any monitoring data from parts per million to, for example, micrograms per meter cubed?
The question was, what was the convert? It had to have been done at some point to mesh those data sets. The question was, what was that conversion, and what were the assumptions that were used to make that conversion? And so do you have a conversion factor that you can provide for us, in the assumptions surrounding that conversion factor from, I believe it was micrograms per cubic meter to parts per million?
Yes, we do have that. We could provide that in writing, where we use a combination of the molecular weight and I believe we use standard temperature and pressure, but I can double check on that.
Right, and some of those temperature and pressure things are marginally important, but it's good to have it, even if it's just stated somewhere in the document. But that was a question as to whether it was already there. Okay,
sure.
I see Dr. Yeah, thank you. I see Dr. Roby.
Yeah, thank you, Catherine Roby. I have a question about the SBR cohort and some 2,000 or 20,000 plus folks in that cohort. I'm wondering if there's any reproductive based data being collected on those individuals, or fertility data.
This is Chris Kerman, if I'm allowed to speak. I do not believe that any, all the data that's being collected has been for mortality, and therefore I do not expect to see anything other than a cancer and possibly some other cancer mortalities for reproductive endpoints for that particular cohort at this time.
Thank you for the comment. We did not have those data, reproductive data.
Thank you.
Are there other questions? Okay, seeing none, we can move into our public speakers for today. And on my list, I have Veena Singla from Columbia University.
Yes, thank you very much. Good morning. I have some slides to share, or maybe, great, perfect. My slides there. Thanks so much. And I'll just say, I'll say next slide when I'm ready. So good morning, and I'm an adjunct assistant professor at Columbia University and a consultant to the University of California, San Francisco program on reproductive health and the environment. I'd like to thank all of the SAC members and ad hoc reviewers for your service to the public by being here today. Next slide, please. I have no conflicts to declare. Next slide. Today, I'd like to comment on these 6 different topics, and I also shared written comments that contain more details and citations for the comments that I will make today. Next slide, please. So on financial conflicts of interest and the evidentiary basis showing that financial conflicts of interest bias results in favor of the sponsor, the national academies highlighted the large body of evidence showing that financial conflicts of interest lead to systemic biases in research in the workshop report that's shown on the slide. And industry sponsorship can bias research through various mechanisms, including how a study is designed and conducted, selective reporting of the results, skewed or incomplete analyses of study data, misleading or selective presentation of conclusions, and signaling preferred outcomes and framing the questions to be investigated. After reviewing all of this evidence, this is why the National Academies has recommended to EPA multiple times that funding sources should be considered in the risk of bias assessment when conducting reviews. First in 2014 in their review of EPA's IRIS process, and again in 2022 in their review of the Handbook for Developing IRIS Assessments. It's important that this risk of bias doesn't mean that that industry data or data with financial conflicts of interest is excluded. It simply means that EPA assessments should account for the possible bias in the evidence base by using a study quality of evaluation domain that incorporates financial conflicts of interest as a metric that could affect the validity of a study's findings and conclusion. And the Navigation Guide systematic review methodology includes guidance and tools to assess risk of bias that considers financial conflicts of interest. And this is relevant to several studies relied on by EPA that I'm going to mention today in my comments. Next slide, please. I'd like to acknowledge that I requested extra time to present these comments to you today beyond the standard 5 minutes typically allocated to each public commenter. But we do recommend for fairness that all commenters be offered the same opportunities and time to share comments. And commenters with financial conflicts of interest in the chemical being discussed shouldn't be given more or less time than any other commenter. Next slide, please. So on charge question 2, the general population exposure assessment and analysis, EPA asked for comment on its conclusions that refined modeling of ambient air concentrations in the draft risk evaluation was necessary to inform the cancer risk evaluation. So in the draft risk evaluation, EPA first used the integrated indoor-outdoor air calculator and identified unreasonable risks related to manufacturing and processing of 1,3-butadiene. It then used the human exposure model with the TRI data to perform what it's calling the refined modeling here. EPA's determination of unreasonable cancer risks is clearly supported by both the integrated indoor-outdoor air calculator analysis and the human exposure model, which provides additional support. But EPA's analysis in the draft risk evaluation actually underestimates risks because it didn't consider some certain known exposures, increased susceptibility, and cumulative risk. Next slide, please. EPA acknowledges that communities are exposed to 1,3-butadiene from all sources, those that are related to TSCA conditions of use and those that are not related to TSCA conditions of use, like vehicle exhaust. However, it declines to consider that aggregate total exposure to 1,3-butadiene in the risk evaluation. But whether or not the exposure comes from a TSCA condition of use, it's going to contribute to overall exposure and to risk. So these exclusions will underestimate risk. Next, chemical incidents and releases also result in exposures to fence line communities. These events are known and reasonably foreseen consequences of chemical manufacturing, transportation, use, and disposal, so they must be considered under TSCA. And the example shown here is in January of 2024, a winter storm in Texas resulted in upset events at facilities, with facilities reporting multiple chemical releases, including thousands of pounds of 1,3-butadiene to the Texas Commission on Environmental Quality. And excluding these exposures will also underestimate risk. Next slide, please. Susceptibility to harm from chemical exposures is increased by external stressors, which include psychosocial stress from experiencing income inequality, violence, racism, healthcare inequity, food insecurity, extreme weather, and more. And in general, people of color in the US experience disproportionately high levels of these external stressors, collectively known as extrinsic susceptibility factors. As a result, people of color are more susceptible to negative health impacts from chemical exposures. But EPA hasn't considered this increased susceptibility and thus is underestimating risks. We recommend that EPA apply an expanded intraspecies adjustment factor of 42x, and this is consistent with the 42-fold human variability in toxicokinetic and toxicodynamic responses to chemical exposures that were observed by the World Health Organization using a probabilistic method. Fence line communities are co-exposed to 1,3-butadiene and other carcinogens at the same time, but EPA didn't conduct a cumulative assessment to account for these combined risks. The National Academies recommended that the best approach for quantifying cumulative risk posed by chemicals of the same class is to conduct a cumulative risk assessment when there's substantial evidence supporting multiple exposures and common adverse health outcomes, both of which we have here. We have significant evidence of multiple exposures to chemicals like 1,3-butadiene and formaldehyde, as well as the common adverse health outcome of cancers. And there's a significant and growing body of literature demonstrating how to do these cumulative assessments. Next slide, please. We recommend that EPA use both TRI and NEI data for the general population exposure assessment. These data sets capture different information from different sources, as shown in the table here. So you can see the source of the data in TRI, it's self-reported by companies, whereas in NEI, it comes from state, local, tribal air agencies, as well as additional EPA data. The emissions sources included are also different. For TRI, it's industrial facilities that are required to report under the Emergency Planning and Community Response Act. And NEI, it's a variety of point, non-point, and different sources of emissions. The two data sets also cover different chemicals and pollutants. TRI covers 799 individual toxic chemicals, as well as 33 chemical categories. NEI covers criteria and hazardous air pollutants listed under the Clean Air Act. So we're getting different information from these two data sets. So EPA should complete a thorough analysis using both data sets to accurately identify all risks of concern. The NEI analysis may be useful in identifying additional locations at high risk that weren't already identified by the TRI analysis that EPA completed using the human exposure model. And to ensure protection of fence line communities, we recommend that in any instance where there's a significant difference between the TRI-based or the NEI-based estimates, EPA should use the higher risk for risk characterization and unreasonable risk determination unless there is significant data to indicate an error in one of the data sets. Next slide, please. Now, separate from the draft risk evaluation, EPA also released a supplement in March 2025, just last month, that used NEI data to estimate general population cancer risk for 9 facilities. But this supplement is really limited, and you can't inform much conclusions from it because of that. The 9 facilities were chosen based on demonstrated risks using the TRI data and that human exposure model analysis, which was already completed. But there's more than 700 other 1,3-butadiene emission sources in the NEI that EPA didn't analyze, including facilities with far higher emissions. So that's what's shown in the table here. You can see the facility name, where it's located, and then the amount of 1,3-butadiene emissions and whether or not it was included in EPA supplemental analysis. And there's facilities with far higher emissions than one of the 9 that was included, yet EPA didn't analyze the risk related to those facilities. Additionally, in the supplement, EPA compared the TRI and NEI-based estimates at census block centroids, when a more appropriate comparison would be at the fence line for each facility, about 100 meters from the release point, which could have far higher risks. And the EPA supplement estimates risks based only on emissions from single facilities rather than the aggregate ambient concentrations resulting from combined emissions of multiple facilities. So of the 9 facilities that EPA did model, 2 are located in Orange, Texas, but EPA didn't consider those combined concentrations of 1,3-butadiene resulting from those 2 facilities or any others that are located in or near Orange, Texas. So we recommend that any analysis EPA conducts of cancer risk using NEI emissions should incorporate data for all facilities, model risks at the fence line, and model combined risks of 1,3-butadiene in all locations where there's facilities within 50 kilometers of each other. Next slide, please. On worker exposures in the occupational analysis, EPA's risk characterization for 1,3-butadiene clearly supports its determination of unreasonable risk to workers. But again, it underestimated the risks because it used central tendency exposure estimates only for chronic non-cancer and cancer risks. Now, the use of high-end exposure estimates to inform risk characterization is consistent with the best available science, EPA's practice and previous TSCA risk evaluations, and with the statutory requirements of TSCA. A use of central tendency only to inform unreasonable risk for workers effectively ignores the higher than average risks that occur among 50% of workers, which is shown in the graphic there. So I'll show an example of what this looked like in the draft risk evaluation. Next slide, please. So here at the top, sorry if this is a little bit hard to read, that top table is an excerpt from table 5-4 in the draft risk evaluation, which is the occupational risk summary. So I've highlighted here one specific scenario, the manufacturer and the infrastructure distribution operations task, and then you can see the exposure level, and then the intermediate non-cancer, the chronic non-cancer, and cancer risks calculated using the central tendency exposure estimate at the top and the high end at the bottom. And they're highlighted. You can see that using the high-end exposure estimates, there are unreasonable risks presented for the chronic non-cancer and the cancer endpoints. However, then looking at that bulleted list on the bottom of the slide, that's the ultimate unreasonable risk conclusions that EPA presented later in the draft risk evaluation. And you can see that exact scenario, the manufacturing infrastructure distribution operations is highlighted as presenting an unreasonable risk, but for intermediate non-cancer only. That's what the asterisk indicates. And this was the case for 21 total different conditions of use that EPA actually found chronic non-cancer or cancer unreasonable risks using the high-end exposure estimates, but ignored those in the unreasonable risk determinations. So we recommend that EPA reevaluate these conclusions and ensure that the unreasonable risks that already found using the high-end exposure estimates are accurately reflected in the unreasonable risk determinations. Next slide, please. On charge question 5, human health hazard, EPA asked for comment on its conclusion that ovarian atrophy is not appropriate for extrapolating to human risk. This conclusion is not consistent with the best available science. To dismiss ovarian atrophy, EPA relied on a hypothesized mechanism of action proposed in Kerman et al. 2012. This hypothesized MOA doesn't have experimental data to support the critical key event, follicle depletion, which is called key event 3 in this graphic that's excerpted from the draft risk evaluation. And EPA acknowledges that the mechanism for how 1,3-butadiene metabolites lead to follicle depletion is unclear. So this indicates an insufficient evidentiary basis to dismiss this endpoint. Next slide, please. And the California Office of Environmental Health Hazard Assessment found that humans are likely more toxicodynamically sensitive to ovotoxic effects because of a longer lifespan and the greater susceptibility of the human reproductive system compared to mice. Additionally, the authors of the paper relied on by EPA have financial conflicts of interest. Thus, there's a risk of bias towards results that support the sponsor, the American Chemistry Council. Ovarian atrophy is the most sensitive non-cancer endpoint, and we recommend that EPA should assess these risks. Next slide, please. EPA also asked for comment on the updated cancer hazard values. There's a significant problem here in that EPA underestimates cancer risks because of a reliance on inaccurate exposure assessments in the calculation of the inhalation unit risk, or the IUR. So in the table there, you can see the 2002 IRIS value for the occupational IUR compared to the value in the 2024 draft risk evaluation. The 2024 value is about 10-fold less potent. Why is this? EPA states the difference is primarily due to using higher exposure estimates in the 2024 risk evaluation that came from a work by Macaluso 2004. This paper has a financial conflict of interest being funded by the rubber and chemical industry associations, which would create risk of bias towards results that favor the sponsors. Next slide, please. So Macaluso 2004 modeled exposure estimates that are generally significantly higher than the NIOSH measurements that were used in the 2002 assessment. And in the table there, it's a little bit small, but hopefully you can see on the left-hand side is the job group or activity being performed. And then next is the NIOSH measurements in the light blue highlighted there. And then next is the modeled exposure estimates from Macaluso 2004, highlighted in the light pink. And what you can see overall is that the modeled exposure estimates are higher than the NIOSH measurements in general, and sometimes significantly higher. And there's no rationale given as to why these modeled levels would be more accurate than the measured levels. So EPA used these overestimated modeled exposure estimates rather than the actual measured exposures for the primary occupational health study. We recommend that EPA should recalculate the inhalation unit risk for 1,3-butadiene with the original measured exposure information that was used in the 2002 IRIS assessment, while incorporating updated information for the cohort that would include women as well as men and the longer timeline. Next slide, please. Thank you very much.
All right, thank you for your comment, and I'll open it up to the committee members. This is George Cobb speaking. Open it up to the committee members for questions, and I see Mr. Wright has a question.
Yes, first I'd like to thank Dr. Singla for an excellent presentation, and I'd like to if I can reinforce one part of it. She talked about the risk of accidents at 1,3-butadiene facilities. I'm familiar with one that happened to our union. It was a place called TPC in Port Neches, Texas, which manufactures 1,3-butadiene. In an accident in 2019, 6,000 gallons were released. A 4-mile radius was evacuated. Just through sheer dumb luck, nobody in the plant was killed. But it was a major incident. The 1,3-butadiene found a source of ignition quickly, so we don't know how much of the pure chemical was released. Anything that got far enough away that it was under the lower explosive limit would have remained 1,3-butadiene, at least for a while. If anybody wants to sort of take a deeper dive into the hazards of this chemical, that kind of accident is not uncommon and is because of the characteristics of the chemical that it can self-polymerize. That kind of accident is sometimes hard to avoid. There was a study of it done by the Chemical Safety Board, and you can find that study on the Chemical Safety Board's website, csb.gov. It's worth reading if anybody wants to know more about what this chemical's hazards are outside of acute and chronic toxicity.
Thank you, Mike. Dr. Merced Neves.
Good morning. Thank you for that presentation. I guess I want to go back to the WHO recommendation of a 42x factor for extrinsic factors that may also affect the cumulative risk. My question is, does this 42x account for the general population, or are we talking, you were speaking in the same statement, how minoritized communities have greater effects of many of these. So I'm just wondering whether the 42x accounts for everyone or just minoritized communities.
Thank you for that question. The 42x was developed based on a variety of chemical-specific data, as well as information from different populations globally. So I would say it's more representative of a general population, and that individual populations such as fence-line communities that are exposed to 1,3-butadiene should be considered for any additional adjustment factors that could be added on top of that 42x, where there's data to indicate that they may have even more susceptibility than that general range.
Thank you.
Dr. Roby.
Thank you. You commented that humans have a more sensitive reproductive system than mice. I'm just wondering if you can kind of elaborate on that and provide some more insight into that statement.
Yes, thank you for that question. That was a quote from the California Office of Environmental Health Hazards assessment of 1,3-butadiene and their assessment of the toxicodynamic sensitivity. So I would be happy to go back to that report and find their citations and support for that statement. I'm happy to provide that.
That would be helpful. Thank you.
And Dr. Santos Bourgois?
Yes, thank you very much for that presentation. I have many questions that I would like to do, but one important one, if you can expand on your concerns in relation to the Macaluso exposure assessment in comparison to the NIOSH measurements, in terms of which ones were personal monitoring data versus area monitoring data versus area modeling. Do you have any concern, any observation about that? And also in the table that you showed mean as a central tendency measurement, but the confidence interval is obviously a very skewed distribution. So the appropriateness of using mean for the estimation of exposure.
Thank you for those questions. So the NIOSH data all came from measurements. None of the NIOSH data was modeled. And as to for the NIOSH measurements, whether they were personal monitoring or area monitoring, I could find that information. I'm not sure what the breakdown was in terms of how the measurements were collected by NIOSH. The Macaluso data was all modeled. All of those were modeled. Those were not measurements. And I appreciate the question about the appropriateness of using the mean. Our recommendation in terms of the data that should be used in the occupational exposure assessment is to use the high end and not the central tendency for the various reasons that I talked about.
If I may, in the Macaluso paper, the Macaluso report, they did have, they explained how they collected a lot of the information, and they had, very detailed interviews. They went through the plants, they did walkthroughs to the plants. They measured ventilation rates and things like that. So it has some added value, in terms of the things that they collected. Obviously, it's so it's just saying yes or no. It's difficult, but certainly the difference is too big. Yeah. So yes, if you can find out about the NIOSH, it would be great.
All right, thank you. I see Dr. McKenzie has her hand raised.
Yes, so thank you for that presentation. I did have a question in reading your comments, and I went, you mentioned, I think it was 37 articles that were, I believe, found in this review, but not carried forward into the analysis. Can you speak a little bit more to that?
Yes, that was a part of our comments that I didn't speak more about today, looking at the systematic review process and methodology that EPA used to develop the evidence base that they relied on in the draft risk evaluation. And what we found reviewing the documents was in the literature search, there was articles that were identified that met the inclusion criteria and yet were still excluded, like not carried forward into the ultimate analysis that EPA did without a clear rationale or justification as to why those articles were excluded. So we recommend that there should be more transparency about if there's reasons they didn't meet the inclusion criteria or other justification. Those should be documented, or they should be moved forward into the data analysis.
Thank you.
And Dr. Hopkins?
Thank you for your presentation. I apologize again about my camera. What I would like to ask you is, I myself have been thinking a lot about the uncertainty associated with the use of the NEI and the TRI. And I have experience in understanding the upset emissions and the acute events and things like that. We're talking that we see repeatedly. But what I don't have a good understanding of is how, and perhaps you have been thinking about this, how to incorporate this other data set. So that's the first part of my question. Given the uncertainty of what we have in the NEI, the TRI, and our comparison to measured concentrations, how you think EPA should go forward. I'm interested in what you think about that. Additionally, I noted your comments. In the past few days, we've been talking about things statistically, how we're representing what goes into the risk. In certain aspects, EPA is using the 95th percentile, and many times people ask, is that actually the 95th upper confidence limit of the mean? No, it's the 95th percentile. Here we're talking about central tendency. Are you I think you reflected in your comments that you feel that central tendency isn't enough. In a traditional risk assessment, you would use the 95th upper confidence limit of the mean. What are you feeling is the correct statistic to use, and is this something that should be really brought out so it's not as confusing to the public and ourselves in what statistic is appropriate? Thank you.
Thank you so much for those questions. Yeah, on the first part, on thinking about the TRI, the NEI, and the information that we have on additional sources of 1,3-butadiene exposures and releases, and the uncertainty in all of those data sets, and the question of how can we integrate the information we have from all of that data to try to more accurately represent the risks that communities are facing. I think I have kind of a two-part answer to that. One is to do the more comprehensive analysis of the NEI data so we can get a better understanding of how the TRI and NEI data sets might identify the same risks. Maybe there'll be a big overlap between the facilities that they identify as risky, or maybe not. Maybe there's some overlap, but NEI really identifies additional sources that were not identified by TRI. So to understand what information we have about risks based on those two data sets, do that analysis and comparison, and then build out how to integrate that data from there, as well as thinking about, could there be an adjustment factor added that can account for these additional sources of exposure, like from the upset events, like from other sources of 1,3-butadiene that aren't TSCA conditions of use, that could be adequately protective for the general population and fence line communities. So that's on that part. On your second question, I will bring that back to our team at PRE that has a lot more experience with statistics than I do, and I'd be happy to come back with our recommendation on that question.
Thank you. Are there other questions? If not, I'll point out that this is really good conversation, Dr. Singler. I really appreciate your comments and some of the things you brought up about the Texas facilities. I'm sure we'll talk about later in our deliberations, and perhaps Ms. Jenkins will have some insights to offer about some of these facilities in Texas that she knows more about than probably the rest of us do. I see a question from Dr. Chason, I believe.
Thank you, Dr. Cobb. First, I have to, in full disclosure, say that I'm really not familiar with the different types of facilities. Even if named, I wouldn't know the difference in terms of representation within the databases. So this is a question to anybody on the panel who might know this, or to our presenter, which, by the way, I want to compliment a really very interesting presentation. Could the data be segregated into representative facilities or representative scenarios of exposure, such that they could, each category, if you will, could be treated statistically differently, which might reflect either the type or construction or other mechanisms within the facility, so that it is an alternative to just trying to put all the data together and find what kind of distribution expression would be most likely. Because what we might be dealing with here are bimodal distributions that you're trying to aggregate. And I know this has been done for other kinds of exposure scenarios, and I have no, as I said, no idea whether that's possible here. But if it's possible, it might reveal some of the most egregious scenarios, which contribute to the probability of these very high and spills or accidents or unusual conditions. So maybe somebody could comment on the idea of looking at this as multimodal distributions rather than a single one. Can't hear you.
Thank you, Dr. Chason. Dr. Singley, do you have a response to that? I don't know that that question was directed solely at you.
Yes, I do have some thoughts. Thank you so much for that question. That's a really interesting idea. I'm just pondering it, because the way that sources are categorized in TRI and NEI is quite different. In NEI, it's based on their classification under the Clean Air Act and what type of source they are. Like major, are they classified as a major source, for example? But under TRI, it's based on their industrial classification. Like, are they, synthetic, organic, chemical manufacturers? So they're like type of industrial facility, and as well as the company size, like number of employees, and then how much 1,3-butadiene they may release or process. So there's going to be some of the same facilities in both data sets for sure, but there may be some types of facilities that are in TRI that are the same type, like related to the same kind of function of manufacturing or processing 1,3-butadiene, but wouldn't be in NEI because they're not classified as a major source, for example, and maybe vice versa. So it potentially could be done to try to categorize like the sources between TR and NEI into like these similar categories, and then look at the patterns or trends. It would take some doing though to figure out exactly how to disentangle like the different ways that the facilities are required to report in TRI and analyzed in NEI.
Can I just make a response to that a little bit, Dr. Cobb?
Sure.
Now, once again, this is not necessarily applicable, but just to continue with that, we've encountered situations like this, both for exposure and also for activity patterns that contribute to exposure. And one of the benefits of looking for this kind of thing in terms of the characteristics of the plant is to be able to assign, if you will, probabilities, or not assign, to look for probabilities of the exposure scenario happening. And so sometimes, rather than just looking at the report of the concentrations or things like that, other factors, trying to assign at least categories of probability is another way to deal with the data, to look for natural categories of common incidents. And when, that may reveal, if you will, some very interesting statistics about the types of facilities by some factor, and I'm sure somebody like Mr. Wright can bring some enlightenment on that if it's doable at all. But it to keep having discussions from the statisticians over the least offensive way to aggregate these distributions almost confounds, if you will, some of the risk mitigators. I mean, where do you want to regulate? You want to regulate at the lower end mean, which might cover a lot of places, or do you want to regulate at a rare event? And that is a classical dilemma that I think is worthy of a scientific explanation to people who have to use these conclusions. Thank you.
Thank you. Dr. Eastman.
Thank you very much. I was quite interested on the reference you made to the International Program on Chemical Safety's intra-species sort of recommendation for the 42X. And as I fiddled around trying to look this up, actually looks fairly complicated. So we're looking at log normal distribution, looking at the tails. And I think you said you were looking at a 1%, which would be the 99th percentile on that, right? So do you have any advice or recommendation if one was to choose a different percentile, such as like 95th percentile rather than 99th percentile? And I know this is too complicated, but if you could send that forward, it'd be very helpful, because I'm looking at the document itself and it's actually fairly complicated. it appears those distributions are going to vary depending on whatever you're measuring, because it's a distribution. And anyway, so I'm just curious if you have any additional information on that, it would be helpful. Thanks.
Thank you so much for that question. Yes, that WHO IPCS method is this probabilistic method, and our recommendation is you can look at the different percentiles, right? 99, 95th, and see what the risks look like at the different percentiles, and then decide like what meets in your view the criteria for being reasonable or unreasonable in terms of the risks presented at the different percentiles. So to be clear that by choosing 95th versus 99th, we're accepting X potential amount of increased risk, which we feel is reasonable or unreasonable. So to be transparent to say there's different risks at these different percentiles that we're choosing, and we're going to choose this one because we believe that meets the criteria for being a reasonable risk, or beyond this, it's unreasonable risks.
Well, thanks. Of course, you know that there are all sorts of distributions we're putting together that go into a risk assessment. And if you pick the 99th percentile on every one of these, you could get some really pretty extreme values when you put them all together. So that's why being able to sort of look and see, I mean, it's much more common. You oftentimes use 95th percentile or 90th percentile. Not that you're trying to say that we don't worry about these other people in the tail, but just because you start compounding all these adjustment factors and uncertainty factors, and it accentuates, the outcome. You get sort of unreasonable outcomes, it seems, when you start adding them together, in my mind. But anyway, thank you very much. That was very interesting.
All right. Any other questions? If not, Ms. Munir has a clarifying comment I think she would like to make.
Yes, so hello. So yes, there was earlier a question about the styrene butadiene rubber cohort data and if it included reproductive and fertility data. And there was some confusion about who's supposed to answer the question. There was a public commenter, Chris Kerman from Sci Pinion, who made a comment and answered the question. And this question was really for the agency to answer. The agency did respond to the question about the styrene butadiene rubber cohort data and if it included the reproductive and fertility data. And so for the record, if the SAC could please disregard Chris Kerman from Sci Pinion's comment in response to the SAC's clarifying question for EPA about the styrene butadiene rubber cohort data as it relates to reproductive fertility data, and adhere to the agency's response to that question, that would be great. Thank you.
Thank you for clarifying that for all of us. And perhaps at some point EPA can remind us specifically of what that answer was. When we get to that part, I think they're going to have some responses to other questions here in a bit. So with that, I think we can move on to our next public speaker, and it would be Mackenzie Bach.
Hi, thank you. My name is Mackenzie Bach, and I'm an epidemiologist with ExxonMobil Biomedical Sciences Incorporated. I'm also a member of the ACC's 1,3-butadiene consortium. Thank you for the opportunity to speak to the SAC today. My comments are regarding the life table analysis in the human health hazard section of the draft 1,3-butadiene risk evaluation. Life table calculations can seem like a black box for many risk assessors, and we hope that our comments and the materials we submitted in the docket will help illuminate these calculations a bit more. So first, we agree with the correction the EPA made to exclude child years from the life table calculations for determining an IUR for occupational exposures. This makes sense as occupational exposures to 1,3-butadiene are only expected to occur for adults, and the correction actually reconciles a previous inconsistency between the life table analysis and the exposure assessment section, where children were not evaluated for occupational exposures. However, we identified several other inconsistencies in parameter values used between the life table analysis and exposure assessment sections. For example, the life table analysis considers a lifetime of 85 years compared to 78 years in the exposure assessment. Since the risk evaluation is attempting to estimate risks for a 78-year lifetime, the background risks for leukemia ages 79 to 85 in the draft life table calculations are not applicable. Additionally, the life table calculations assume there are occupational 1,3-butadiene exposures between the ages of 16 and 85 years, which amounts to around a period of 70 working years, whereas the exposure assessment considers an upper bound of 40 working years. We believe it's unreasonable to assume an employment duration of 70 years or that cumulative occupational exposures would continue to increase after retirement. And we urge the SAC and the EPA to consider a more realistic estimate of working years. We also identified discrepancies in values for exposure frequency and breathing rate that are described here on the slide, as well as detailed in our written comments submitted in the docket. These discrepancies may just be the result of multiple groups working on different sections of the risk evaluation at the same time, but we recommend the EPA adopts consistent parameter values throughout the entire risk assessment. Next slide, please. Thank you. In addition to our detailed written comments, we've also submitted to the docket a revised spreadsheet workbook that incorporates all of the recommendations and the changes to the life table calculations. This spreadsheet is color-coded for ease of reference, and it includes a summary table like the one shown here on the slide that describes each change, its rationale, where exactly in the spreadsheet the change should be made, and the impact that each change ultimately has on the final results. This information is also summarized on the next slide. If we could advance, please. Okay, so this table summarizes the recommendations that I've mentioned today, as well as recommendations that Chris Kerman gave yesterday. The corresponding comment that provides further context and rationale in our written comments is shown in parentheses. As you can see, taken in isolation, each of our recommended changes has a relatively small effect on the IUR. For example, making the definition of lifetime consistent at 78 years results in about a 30% decrease in the IUR. Similarly, making the working years consistent at 40 years also results in about a 30% decrease. Yesterday, Chris made some recommendations regarding model selection, namely that EPA should be relying on the full SBR cohort rather than the trim data, which excludes around 40% of the cohort data. And the EPA should also reconsider the inclusion of butadiene high-intensity tasks as a covariate. If these recommendations are incorporated, the resulting IUR is around 4 to 6 times lower. However, when all of our recommendations are taken in combination with each other, they do result in a meaningful shift in the bottom line number for the IUR and the resulting OEV. And that concludes my comment. Thank you.
All right, thank you for that comment. Are there questions from the committee? Seeing no additional comments, we can move on to our next.
George, can I make a quick question?
Davidson has a comment.
Thanks. I'm assuming the EPA is going to be looking into all these comments from both this speaker and the previous speakers as well. Is that correct? So we don't, I mean, a lot of these seem to be reasonable things to look into and hope that the EPA would look into them. I guess that's.
That is correct. And we can also include them in our responses, but maybe EPA wants to respond to your question.
Hi, yes, this is Karen Eisenreich from the EPA. We do consider all comments that are in the docket that have been submitted to the docket, as well as anything that's in the peer review report. So we will take all of that into consideration between draft and final.
Well, thank you.
Dr. Gentry.
Yes, you sort of answered this, George, but I just wanted to clarify. I mean, even though it's in the public comment and in the docket, I mean, if we, as the SAC, agree that these should be considered, you know, especially if it's things that suggest inconsistency in EPA's analysis, that we should have those in our comments as well.
You are certainly allowed to do that, and quite often the narrative from our responses include reference to certain things that were made in public comment.
Okay, thank you.
Okay, if there are no questions, then we can move to our next speaker, who is James Cooper.
Good morning, everybody. The American Fuel and Petrochemical Manufacturers supports the efforts of this committee and its ad hoc members and appreciates the opportunity to comment on the 1,3-butadiene draft risk evaluation. AFPM member companies are among the most highly regulated facilities in all manufacturing, and their products have been and will continue to be subject to TSCA. AFPM members manufacture butadiene, a base petrochemical used in the production of synthetic rubber and engineered plastics. Butadiene is not an ingredient in liquid products and is not a material component of solid products. It is an intermediate used in closed-loop systems and consumed in those chemical reactions. Residual butadiene in polybutadiene or butadiene copolymers is insignificant, measuring in the range of micrograms per gram or nanograms per milliliter, and bound in the polymer matrices. In general, diffusion rates of trace monomers from polymer matrices is very slow, so AFPM supports the agency's qualitative approach and not wasting its time tracking molecules that will not have an appreciable effect on overall risk. Furthermore, AFPM urges the agency to adopt a de minimis concentration so that the agency can focus its resources on conditions of use with the greatest potential for exposure and not try to track every molecule in commerce. AFPM also supports EPA's decision to use a qualitative approach for environmental risks. The agency acknowledges that butadiene will not partition to soil or water in any appreciable amount because it is a gas. Attempting to quantify environmental risk will waste the agency's time and resources. AFPM does, however, have some concerns about the draft risk evaluation disregarding monitoring samples below the limit of detection or assigning an estimated value. In addition, the exposure assessment assumes that task-based monitoring data are representative of full shift exposures. AFPM believes these approaches may distort the analysis of the worker exposures, arbitrarily increasing them and adding unnecessary uncertainty. Another concern is the inclusion of accidental release and emergency shutdown scenarios as part of butadiene's conditions of use. Accidental releases and shutdowns are covered under other more appropriate regulatory programs, such as OSHA's Process Safety Management Standards, EPA's Risk Management Program, and Emergency Planning and Community Right to Know Act, Department of Transportation hazmat regulations, and other federal programs. The word accident does not even appear in Section 6, nor do the words emergency or shutdown. None of these words are included in the definition of conditions of use found in Section 3. The methods to assess the risk of an accidental release or spill under RMP and PSM are different from the way risks are assessed under TSCA. Just because there is a possibility that something could happen doesn't mean it's probable or likely or foreseeable. Lastly, the tables listing the conditions of use and the supporting documents can be confusing and sometimes seem to conflate butadiene monomer with butadiene copolymers. Butadiene is not an ingredient in adhesives, coatings, or any other liquid formulations, nor is it in plastic or rubber in any appreciable amounts. It is an intermediate used to make those products. It's consumed in those chemical reactions. In conclusion, butadiene is the first base petrochemical. It's a building block, and it's going to undergo risk evaluation under TSCA. This is the first one. It is essential for this committee to ensure that the scientific principles outlined in TSCA Section 26 are met in this risk evaluation, and that EPA not waste its limited resources and time on scenarios that really don't affect the overall risk picture. I'd like to thank the committee and the agency for this opportunity to express our views. And I'm happy to entertain any questions.
Yes, thank you for your comment. And we can have questions now. I see Dr. Chason has a question.
Thank you for your presentation. Perhaps you can answer a question that I asked previously. And it's an important one because you're recommending and people are considering whether or not the agency's qualitative risk assessment should be dismissing certain kinds of exposure potential. So you said that the 1,3-butadiene is consumed in the polymerization and that it is tightly bound and that it's anything that's in there's release would be very slow. How do you know this, and can you explain that work to us so that it's not just derived assumption, but are there actually studies have looked at this?
There are a lot of studies that look at what the amounts are. In fact, I did cite that. Let me, if you don't mind, I'll bring up the
that would be great. Thank you.
Citation. This was for the measurement of the residual. It's from an article called Volatile Substances in Polymer Toys Made from Butadiene and Styrene. It appeared in the American Journal of Analytical Chemistry. This is also found in our written comments, but if you would prefer, I can send the citation via text or whatever. I'm not even sure how you do this under Zoom, but I can figure out a way to get it to the committee. But that was a source that really does talk about this. And it talks about basically the risks. It was born from wanting to assess the risks to children playing with certain toys like Legos or ABS, and there are other types of children's toys that are made out of polymers and copolymers, starting with butadiene, and so that's where it stemmed from. And basically. I mean, physical forces are what bind the monomers in the polymer matrices, things like van der Waals forces and other types of, molecular and submolecular forces. And so, a lot of times it's not even measurable, the rate of release of something like a diffusion rate is very tough to measure because it's that slow. And so there's not going to be a whole lot of work published on it because, EPA understood all this, which is why they really, in the past, historically, have not included a lot of different types of things and only approached, as far as quantitative analysis, and only approach them qualitative. Things like, especially when it comes to background stuff like with butadiene in particular, wood fires, combustion products, things of that nature, they generally haven't included them because they haven't really moved the needle much when they do a sensitivity analysis. Now, this is the first time they're doing it for butadiene, but in other risk analyses, they've tended not to try to include what are considered de minimis concentrations. They do that in under the new chemicals program. They've done it under the Section 6 risk evaluations, and they also do it under risk management actions under Section 6. A lot of times they do exempt impurities and trace amounts because they're really not meaningful in terms of risk.
I understand the concept. I'm looking for the information that, in fact, shows, because we've seen that intermediaries and other kinds of reaction elements, if you will, do with time released from the plastics and things like that. So
They do, yes, over
all right,
time.
so well, over
You're looking
time.
for rate studies, correct? You're
Well,
talking
I'm
about,
also looking at different kinds of studies under different kinds of conditions. So I just haven't been able to see any of these to support, if you will, the probability that if it's in there, how much is in there, and under what conditions would the rates suddenly reach a point where it's coming out. And it's a real simple. It's not a matter of policy. It's not a matter of. It's just a matter of what are the data for this, please?
yeah, I'll forward the study that I found in the Journal of Analytical Chemistry. I'm happy to forward that citation.
That would be helpful, and I think maybe that would help answer Dr. Chason's question.
Is there a central point of contact to whom I should send that? Should I send that to Ms. Munir, or where should I send that?
I think it's the same way you did the docket, but Ms. Munir, do you have a suggestion there?
Yes, please send it over to me, and any information that needs to be passed over to the program office, I will make sure that that's done.
Great, thank you.
Thank you, everybody, for that discussion. And I see Mr. Wright has a question.
Yeah, this will be very quick. First, thank you for your presentation. The question is whether you have any data about the number or the volume of accidental spills or unintended spills. In the past, you mentioned that those are often not foreseeable, but they're certainly, once they've occurred, you can certainly record them. Does that data exist, or?
Sure. Yeah, OSHA has that OSHA reportable incidents, which you're familiar with. Usually there are thresholds that have to be met. But yes, there are data out there on those types of releases and on emergency shutdowns. Regarding the emergency shutdowns, as you know, butadiene is very reactive and flammable. Those are flared. They're not just released as a flammable gas into the environment. It's actually flared, so it does combust and resulting in CO2, maybe a little bit of carbon monoxide. But that's a standard procedure during a shutdown, let's say for a weather event or any other type of emergency. And so it's not like it's butadiene being released under those situations. Now, there have been accidental releases like the one you pointed out from 2019. And unfortunately, those do occur. They are minimized and they are infrequent, though. And those are easy to find through OSHA and our EPA under the Clean Air Act. These things have to be reported. And then the normal releases, I guess, or permitted releases, obviously are under things like TRI. But those are the sources that our organization uses. And if you'd like, I can find the sources for 1,3-butadiene as far as I can see what releases have occurred over any time frame just through the OSHA statistics.
Yeah, thank you. I'm not aware that OSHA requires companies to report releases, even under the PSM standard, but I'll go back and look at it. You may be correct. Thank you.
Okay, Dr. Mayer has a question.
Oh, I'm sorry. Mr. Wright. It's not OSHA. It's the National Response Center. My apologies.
Okay.
Those are reported through the National Response Center, and that's part of Department of Transportation. My apologies. That's where the reporting for accidents goes to.
Thank you.
Dr. Mayer.
Yeah, thank you for the presentation. I also have questions about just data. So I think a comment related to the issue of using task-based sampling for full shift assumptions about they would represent full shift. And when I was reading the EPA document, I had a similar question about that approach. But my understanding was there weren't data on those OESs or conditions of use that would enlighten what the likely actual workflow and work scenarios and number of hours per shift for which that kind of handling occurs. I think that was repackaging was one of those. So are there specific data about average handling times per shift for those kind of operations that you're aware of?
I'll be honest, that would be better answered by the consortium that represents the 1,3-butadiene manufacturers. Although AFPM does, all those companies are AFPM members as well, but the specific detailed work like this, that's done under the consortium and not through our organization. So that would probably be better answered through them.
Okay. And another point that I think was raised, and it gets to Dr. Chasen's point too. Just wanted to verify, are there specific data related to emissions from polymerized, and so it's already reacted, so basically extruded or melted polymers and release, because that'd be a different step than just handling 1,3-butadiene. So you've already got it polymerized and now you're extruding it as one scenario, and then the second one would be off-gassing of formed product.
When it's heated for extrusion, correct?
Right. So basically, if you think of the plant, okay, I've got my polymer, and now now it's made. Now I'm extruding it, so it's getting heated. Specific data to emissions during that, and then I make a product, an article, a fiber or an article, and I put it in a warehouse. So off-gassing during that phase. Do you know of data specific to those two steps?
That would probably be done through individual industrial hygiene company, their monitoring, where they do the sampling at, whatever basis to meet the OSHA standards. And a lot of times that's not really published data. And unless there's a data call-in by EPA under Section 8, it's not necessarily going to be supplied. But from what I understand, and I don't know the exact details, again, the Butadiene Consortium did supply a lot of workplace data to the agency. A lot of it was manufactured, under the manufacturing scenarios. I'm not sure how much of the data would be representative of downstream scenarios. And I'm not sure how the extent to which the downstream, plastics processors and folks like that, participate in the consortium and its information gathering. Again, they should be able to shed better light on that than I could.
Well, thank you so much.
Great, thank you. And I think EPA had something that they would like to say at this point. So thank you for your presentation.
Thank you. This is Sheila Healy of EPA. I just wanted to clarify for the panel, and also in agreement with Mr. Cooper, we do acknowledge this qualitative assessment of exposure to synthetic rubber, plastics, and resins in section 5.1.2.1 of our draft risk evaluation. And a key study for that is the synthetic turf field recycled tire crumb research study sponsored by EPA and ASTDR. So that is the basis of our qualitative assessment, that that these synthetic rubber, plastic, and resins is not a significant source of exposure, is supported by that study, and we look forward to any additional information at 5.1.2.1 in the RE. Thank you.
Yes, thank you for that clarification. Dr. Mayer raised his hand again.
So I just wanted to verify, is that the 6.6 ppm number that I saw in the report? Just clarifying. Because I think that was measured, the residual in the product, not in the air. But I just wanted to verify.
In the tire crumb study?
Yeah, I think in the report I kept reading the maximum level of 6.6 ppm, but I was taking that as residual in the product, not the air concentration.
I think that's from another product, but yes, I think that comes from our systematic review as one of the highest outliers, or maybe not an outlier, but the highest. But the tire crumb has it's a very big source of surveyed empirical data of looking at off-gassing from tire and rubber.
Thank you.
Dr. Chason?
Yeah, would EPA mind posting in writing on the chat or whatever is public, the exact reference, please, so we don't have to. I'm just not very facile, evidently, at finding some of these pieces, but I just don't see it. Would you mind actually posting the information about where that study is, please? And the name of the study? Thank you.
Dr. Hager Bernays?
Thank you. And thank you, Mr. Cooper, for presenting and sharing some of this information. And with regard, and Dr. Mayer, for raising this question of the empirical evidence with regard to the tire crumb resource and the release of 1,3-butadiene. And this, I just want clarification. This is not the same reference that was made yesterday to tire crumb. That was burning of tire crumb as opposed to volatilization of or release of 1,3-butadiene from the tire crumb from the turf. Is that correct?
Were they talking about pyrolysis?
They were talking about a fire, an acute, I'll call it an acute event, right? And I just want to make sure, and maybe it was to EPA, that those are two different physical chemical responses, both of which release 1,3-butadiene into the ambient environment.
That's to EPA, correct? Not to me.
I think so.
I mean, because
so.
I'm familiar with the, thermal decomposition,
yeah,
and things of that nature, and with tires in particular, they can burn at a very high intensity and high heat, which could decompose. And you probably would, just like other combustion sources do result in 1,3-butadiene. This probably would too, considering the fact that you're dealing with the polymer that's made from those monomeric units, and so it is very conceivable that under a fire condition you get 1,3-butadiene as a incomplete combustion product.
Okay, thank you. I see Dr. Healy is on.
Pardon me, can you please, this is Sheila Healy, EPA, can you please clarify or repeat your question to EPA?
Yes, my question is, you just referred to a reference that in which empirical evidence is provided, an EPA study that measured 1,3-butadiene from off-gassing or volatilization from turf itself. Yesterday, we heard about data that were generated, reported following a fire in which similar turf, right? We're talking about the crumb rubber infill, resulted in release emissions of 1,3-butadiene following a fire in which the crumb rubber infill turf was burning, I guess. And I want to make sure those are two different studies, and you're referring only to the 1,3-butadiene from the EPA study, which is referenced in our text somewhere, but you'll make sure we can find it. And I just wanted clarification that that's the way you're examining the release to air from sources other than the manufacturing facilities.
That is correct, and that would be a consumer exposure source. And yes, we do not address any sort of combustion.
Okay, thank you.
Right. So now we can proceed to our next speaker, and I need to apologize to everyone. I skipped Dan Baker in our speaker queue, and that was totally my fault. And maybe give our technical team a minute to pull that presentation up, and then turn the floor over to Dan Baker.
Thank you, Dr. Cobb.
Actually, I don't have a presentation. I just have comments to make. My name is Dan Baker. I'm consulting with the ACC Consortium of Stakeholder Companies. My focus will be on charge question 2. The agency's modeling approach until recently did not constitute a tiered approach, but rather consisted of 2 screening options, both options relying upon AirMod and both utilizing identical TRI emission inputs. The recent EPA memorandum on March 3rd presents the results from an additional and necessary refined modeling tier applied to the highest risk facilities using NEI data. By refined modeling, I mean the generally accepted usage that meets EPA's own regulatory modeling guidelines. And by tiered modeling, I mean tiered based on risk. This additional and necessary refined modeling is consistent with the case study conducted by the consortium. Both of these modeling exercises demonstrate how including a refined modeling tier can significantly reduce the estimated risk from 1,3-butadiene. We encourage the agency to update their documentation and incorporate the recent refined modeling results into the EPA risk documents. Regarding Roman number 1, the IIOAC is a suitable first screening tier for fence line communities, with many of the inputs being based on simplified assumptions, like aggregating and co-locating all facility emissions into 2 hypothetical sources. Regarding Roman 2, HEM is a suitable modeling platform. However, when the same aggregated and co-located emissions are used, HEM becomes simply another screening option, and topology making a slight difference. By contrast, when EPA in their more recent modeling uses HEM with detailed NEI data, then this updated modeling does satisfy the generally accepted definition of refined modeling. Including a refined modeling tier in the evaluation can significantly reduce the estimated risk. Here I simply refer you to my written comments addressing the sub-items 1, 2, and 3. Moving on to Roman 3, the TRA data lacks necessary detail for refined modeling, especially for flaring operations. Many facilities have a large percentage of 1,3-BD emissions coming from flaring operations. Flares achieve excellent dispersion through their elevated release heights and their thermal buoyancy. As demonstrated in the case study in EPA's modeling, using NEI data leads to a more accurate risk evaluation. Regarding Roman 4, modeling and monitoring data should be used in tandem. While EPA broadly compares the national monitoring to national modeling, more localized and geographically paired comparisons would provide better insight. Furthermore, model predictions and monitoring data must be compared on a consistent temporal scale. Unfortunately, the current assessment compares the multi-year modeling with individual 24-hour measurements. Individual 24-hour measurements are not credible indicators of lifetime exposure. Finally, the agency needs to provide a broader context of all the EPA programs that are part of the risk management for chemicals like 1,3-butadiene, including requirements for fence line monitoring and the out-of-scope accidental release modeling, like those covered by James Cooper, all of which rely on different types of models that are more source-focused to represent the actual accidental release conditions. Thank you for your time and consideration of these comments. And do we have questions from the committee? Dr. Hopkins.
Thank you. Thank you for the for your comments. I just wanted to ask your opinion or to clarify how you feel that the measured monitoring data should be compared with the modeling data. The measured, the modeling data that we often check the monitoring data against is, using air talks at maybe the census block level, or the air mod measurements there compared to a point. And so I wanted to know what you thought about that. And in addition, you're talking about comparisons, and I wondered if you're thinking about the details on the level of, upwind, downwind, taking wind direction into account when you're calculating the comparison differences.
Yeah, that's the point versus the census blocks, centroid or whatever. That's considered an incommensurable issue that EPA acknowledges. To try and represent an area, to put a monitor somewhere to represent an area is an incommensurability. You just have difficulty with any model predicting time and spatial granularity like that. And there are a number of EPA publications that address that within their modeling community. So, I don't have any particular opinion. The increased number of monitors would be one idea, but that's expensive. And these are based on, my comments are based on actual field studies that are highly instrumented. Many monitors set out at arcs of various distances, and it's extremely difficult to get point and spatial comparisons to be representative. So there's usually some statistical analysis applied to this data. And the second part of your question then was how to use the HAM. I would actually go back to the AirMod output and check the AirMod output at various locations, starting with a hierarchy of comparing, does the peak concentration anywhere in the downwind field or anywhere in the modeled field compare to the peak monitor? Then you could go on to compare other metrics, maybe 95th or 90th percentile, something like that. And again, there are a number of studies on that. I forget the EPA gentleman, long since retired, who did a lot of this work. But he worked with also Dr. Steve Hanna has a number of publications where they compare highly instrumented field studies with various modelings, including AirMod.
Yeah, just a quick follow-up. This is George Kopp on that. I have a colleague who tries to measure point sources in refined grid modeling, and they have a semi-truck, literally tractor trailer full of instrumentation that they deploy, and they put 140 monitoring individual sampling stations, and they get no more than a kilometer away at the furthest point away to try to get refined modeling. And that's just impractical to do on a large scale. You can do that for a single facility for a specific kind of activity, but I agree with the public commenter that that's really a tall order and almost an impossibility. So Ms. Jenkins.
Thank you for your presentation. I have a question about the TRI data and flaring that you talked about, how it's I guess, captured in TRI or if it's not, and then also compare that with NEI.
Right. I think TRI does allow, but maybe it's optional to mark whether or not there's flaring at the facility, but it doesn't provide enough detail. So in the original risk evaluation, excluding the March 3rd memo, all the emissions from stacks, which would include flares, of course, and elevated vents, were put at an elevated vent into a centrally located elevated vent of, I think, 10 meters in height, with a fixed height and a fixed exit velocity and a fixed temperature, which are all much lower and provide less dispersion than actual flaring operations would.
And then compare that with the NEI.
The NEI, okay. The NEI contains the actual details, which would be the flare heights, up to 100 meters perhaps, elevated temperatures, in the 1,000+ degrees, and higher exit velocities as well. And so the model does incorporate thermal buoyancy as well as momentum buoyancy. So the emissions are released significantly higher in the air than the assumption you would use if you're just relying on TRI data at 10 meters, and not much different than ambient conditions for release conditions. Yep.
Thank you.
Dr. Hopkins.
Thank you. Just one more follow-up question. In the, I wanted the commenter's opinion about when EPA is grappling with the comparison of the monitored data versus the modeling data. Their conclusion is that it's reasonable because it's within an order of magnitude difference, and an order of magnitude, it propagated through a risk assessment changes a picture. And I wanted to know I can understand that there was an order of magnitude difference, but I'm wondering if you have any thoughts about the reasonableness of that, or perhaps some kind of refinement of the uncertainty through some kind of stochastic modeling, or probability distribution of the uncertainty, just so that we have a better handle of what we're going to be using going into a risk assessment.
Right. So that statement, as far as I know, was based on comparing the range of the individual 24-hour measurements with the multi-year modeling based on the TRI data. I don't know if any additional statements were made in the supplemental material of March 3rd. My concern was that the range of the individual 24-hour measurements really isn't an appropriate surrogate. I took Texas data and looked at each monitor and averaged over the year where the data were available. I think it was 2017 was provided through 2021. And the range becomes significantly lower by, I think, a factor of 20 or 25. So, more than an order of magnitude, just by accounting for what I think is a better indicator of lifetime exposure. That would be my starting point, is to look at the monitors and do a statistical analysis on key monitors near facilities that have a peak 24-hour concentration or several peak 24-hour concentrations. I'm not sure what else to do after, if that's done, if any more statistical or probabilistic type of analysis is needed. I'd have to see that work first.
Okay, thanks, Dr. Hopkins.
Thank you. I promise to have this be my last question. What struck me about that data range was when I evaluate air pollution data against health effects, I'm very cautious about using COVID years. And I don't know that 1,3-butadiene would have any differences in this case. But, of course, we saw it with ozone and other things. So I wondered what your opinion was about having the COVID years involved with the interval that's used in this assessment.
Yeah. I don't have a strong opinion. There were a number of non-detects. I think more than 50% of the data in that window, 2017 to 2021, were non-detects. Yeah, I don't know how that compares. I haven't looked at earlier data to compare or the more recent data. Yeah.
All right. Thank you for the comment, the question and answer period. And now I think we can move forward to our next presenter, and I believe that will be Craig Davis.
Thank you, Dr. Cobb. And I wanted to take the opportunity to thank quickly the committee, the SAC, and EPA for allowing the opportunity for public comment. So we're going to switch gears a little bit, and this is focused entirely on the qualitative ecological assessment, charge question 1. And I should just note, I've prepared these comments on behalf of ACC's 1,3-butadiene TSCA risk evaluation consortia, just for transparency. Next slide, please. So there were a lot of comments and discussion on the public comment meeting on the 25th around the adequacy or the completeness of a qualitative versus a quantitative risk assessment. I would just like to comment that I think EPA's approach of first doing a qualitative assessment to determine the need or the improvement in the reduction in uncertainty of the outcome is a sensible way to start. I think one of the challenges or the deficiencies in the draft risk assessment is that there's no discussion of actual ecotoxicity data that would help support that adequacy of a quantitative assessment. So modeled acute and chronic toxicity values for aquatic, benthic, and terrestrial organisms are available, as well as actual experimental data for several analog substances. And those are presented in this plot here. So these are modeled values from EPA's EcoSAR version 2.0, as well as the target lipid model, acute and chronic estimates from McGrath et al. 2018, both of which are accepted methodologies and have been used extensively in PMN, as well as in product registrations in Europe. The computed threshold levels in purple represent both HC5, so statistical values based on species sensitivity distributions, as well as PNEC values using assessment factor approaches, sort of the EU analog. And what I've done here in this plot is plotted acute, chronic, and threshold level effects calculated conservatively against the maximum reported surface water values from EPA's report. And I should note that those surface water values are represented as the MDL, or the minimum detection limit. In reality, those values are lower. And if you did a quantitative assessment, you would typically take half the MDL as the value. You typically wouldn't take the full MDL. And so what I just want to point out here is that even using conservative assumptions, you have factors of about 600 to 7,500 between the observed environmental concentration and computed threshold levels for aquatic organisms. So this really supports EPA's decision to use a qualitative assessment. And it is my opinion that additional quantitative assessment won't refine or won't change that answer. And I should point out that this approach is equally valid for soil and sediment organisms using the equilibrium partitioning approach, which is also well established by EPA and other regulatory agencies. Next slide, please. So I just want to mention here, there were two comments yesterday, one on spills and one on deep well injection. I should just mention that deep well injection, those are permitted wells, and part of that permitting process is that they are not hydraulically connected to drinking water sources, and there is regulation and monitoring around that. And there are no ecological receptors contained within deep groundwater wells, so exposure to ecological organisms is limited and negligible. On the spill side, because of the way 1,3-butadiene has to be transported under pressure and at low temperature, it's unlikely that a traditional liquid spill should occur. If there is a release, accidental or otherwise, it's likely going to be in the form of a gaseous release. And so I think EPA has adequately addressed those qualitatively in their assessment. Next slide, please. So just in summary, I think EPA's conclusion to qualitatively assess environmental risk is well-founded based on their totality of evidence. I think the low potential for surface water exposure and subsequent ecological risks is further supported by their review of environmental media concentrations for butadiene, that there's low potential for bioaccumulation and a lack of toxicity results in low concern for air-breathing terrestrial organisms. And the last point I'd like to bring up is someone mentioned human exposure, man via the environment. It is unlikely, given the low concentrations in drinking water and the low potential for bioaccumulation, that that's a significant exposure source. And that's aligned with previous conclusions from regulatory assessments by Health Canada, WHO, EPA, IRIS, ASTDR, and ECA that non-inhalation sources provide negligible exposure to the general population. And I think that's it. Thank you.
All right, thank you for your comment, and turn it over to the committee for any questions. Dr. Fairbrother.
Yeah, thanks for that. That was a good compilation of the existing data that we have. I did have a question about your statement of low toxicity for air-breathing organisms. Since we know that mammals do have toxicity from air breathing, that's the studies that have been done for human health hazard. So seems to me that that kind of relates directly to terrestrial organisms, and I'd like you to comment a little bit on that.
Yeah, that's a great point. So I should clarify sort of mammalian-based organisms, so typically mice, rats, rabbits, the organisms that are typically used in laboratory studies for assessing mammalian endpoints, and then ecological wildlife receptors, so birds, things like voles, other types of terrestrial organisms. So there is not a lot of data. There are some toxicity reference values, TRVs, for other volatile organic compounds. So that might be a starting point for assessing potentially butadiene. If you wanted to do it kind of semi-quantitatively or from a screening perspective, you could use that data and pick, some central tendency or percentile value for that. That might be challenging. There are, so that might be challenging. So I think generally, though, the toxicity values for air-breathing organisms are less certain, but I think the general population and sort of, I guess, regional exposure of butadiene should be low, and I would expect limited risk to ecological receptors. But it would be challenging to do that assessment without what I would call reliable wildlife values or TRVs. So that may be something to consider in the future, but maybe EPA may have limited ability to do that in the scope given the current amount of data.
Okay, I think that's something that we might want to discuss a little in more detail during the conversation about question 1.
Yeah, we can certainly discuss that. I think that's a good idea. Dr. Santos Burgoa.
Yeah, thank you very much for the information. I would like you to expand on the deep well injection factor. ATSDR use that consider deep well injections in its assessment. Why? how sure can we be about what you are saying, that there is no possibility of any human exposure or environmental ecological exposure from deep wells injection?
Thank you for your question. And I just want to clarify, I believe I said negligible, and if I didn't, negligible exposure. So the wells are sufficiently deep that groundwater recharge, as you might expect from shallow sources of groundwater to streams or rivers, is highly unlikely. So direct exposure to organisms is highly ecological receptors in those environments is highly unlikely. You of course always have the potential for wells to interact with other wells as hydrology changes, as pumping scenarios change. So of course, on a local level, there's always the remote possibility that you have infiltration into drinking water. I think the quantity of drinking water data that EPA has collected, I think it's something like 36,000 drinking water well samples, provides a pretty strong line of evidence that broadly that doesn't occur. They did cite, I think, 3 exceedances or 3 scenarios where it was measured above the reference limit. And I think that they did caveat those 3 exceedances with the fact that a MDL, or a limit of quantitation, wasn't reported for those 3 laboratory analyses. So there's a bit of a sort of asterisk on that data. But I think the availability of a fairly large drinking water data set would generally support that conclusion that there's a limited pathway for direct human exposure via drinking water from deep well injection. But of course, like that would have to be validated at the sort of site or the local level where those deep well injections occur.
Because basically what you are injecting is discarded butadiene that is contaminated, or it's didn't react well or whatever. So you inject it there, and physical chemically it will stay and remain there for a long time, and differently to what happens in the air that is it's transformed. That would not happen in those deep wells, and they will remain there for a long time, correct?
Yeah, I can't comment. I'm certainly not an expert on the application of that deep well injection, but more just from the environmental fate and transport side. That would seem to be sensible, that if you have wells under pressure, that it would behave slightly differently. So it could be that it remains longer, that the half-life is longer. But I think the primary point is that there's a physical disconnect between where the ecological receptors and the drinking water sources exist. And I think that physical disconnection and the mass transfer limitation is the more critical piece, rather than the fate and transport or phys chem properties.
One last question. This especially the SBR plants, all of them were Second World War established plants in 1943, things like that. How these brines that went into these deep wells, how will these deep wells manage in those years? We're talking about 70 years ago, and the standards and the engineering for all that was quite different.
That is a good question, and that's, I would say, outside of my area of expertise. So I couldn't comment on that.
Thank you.
All right, Dr. Ottinger.
Good morning. This is Marianne Ottinger, and I enjoyed and appreciated your and other presentations today. I just wanted to go further a bit on Dr. Fairbrother's comments, and wondered if there had been any consideration of the photometabolized products, such as acrolein, and formaldehyde, in terms of eco considerations.
That's a great question, and I'm glad I ran out of time. I did want to actually address that comment from yesterday. So I would point out that on formaldehyde, EPA has done a risk assessment on formaldehyde, and so I think EPA could leverage that risk assessment in a discussion of potential transformation products within the 1,3-butadiene risk assessment, and that may be a consideration for EPA to potentially just reference back to that and have a qualitative discussion of that. From a purely ecotoxicology, like data availability perspective, both of those, I haven't searched for experimental ecotoxicity values, though I'm sure they exist. I did a quick scan of the EPA EcoSAR results from the EpiSuite web-based application. The acute and chronic values are slightly lower for acrolein and for formaldehyde. They're not significantly lower. I would say they're maybe an order of magnitude. So you still have a pretty significant margin of exposure there. But I will say a key point is that their further photo transformation and volatility is similar to butadiene. So I wouldn't, and given the similar rates of degradation in the atmosphere, I wouldn't expect an accumulation from the transformation of butadiene through the transformation product.
But
so
there may be more persistence.
there could be. I'd have to take a look.
I'm asking, I don't
Both
know.
both of the substances had predictions of rapid primary biodegradation from EcoSAR or from EpiSuite. I believe they were on the orders of days to weeks, I think. So I wouldn't expect them to be persistent.
Right, unless they bind to the soil and other media.
The KOWs are quite low. I think for acrolein, I think it's 0, and for formaldehyde, I think it's -0.2, the log KOW.
Right.
So they're similarly low sorptive capacity for those two substances. Yep.
That's really helpful. Thank you.
Yep.
Dr. Fairbrother.
Yeah, two comments. One is following up from what Marianne was just talking about is you can find more information about acrolein because it is a registered pesticide. So if you go to the pesticide registration information, you can find a fair amount of information about aquatic toxicity of that product. Although obviously when it's used in aquatic systems as primarily an herbicide and molluscicide, it's not. It's in a aquatic form. You know, you don't actually apply it as the gas, so that may create some differences in terms of the amount that would be in the water. But in terms of toxicity information, those data are there for the aquatic system. I did want to follow up a little bit on your question about looking at the drinking water studies, and you seem to imply that those were primarily, if not entirely, from groundwater sources. And I'm wondering, when I looked at that data set, I didn't see any information about whether the drinking water information was from groundwater or surface water, or what kind of surface water. So were you able to find that in the data set?
Yeah, that's a great clarification, and thank you for that. No, I don't believe it was easy to delineate which were drinking water sources that were surface or groundwater. It's that 36,000 is likely a mix. EPA actually would be in much better position to answer that question, I think, because it comes directly from there. I think it's the STORAT.
Yeah, it is from STORAT, and I think that's a conversation that we need to also follow up on a little bit more, is sort of the relationship of where these samples are to where exposure might actually occur, particularly when we're looking at the surface water samples, which are much more limited than the drinking water samples.
Okay. That seems to be all of the questions. I'd like to thank you for your comment and for the dialogue that we've had. And at this point, I think we're going to break for lunch. And we're a little bit behind schedule, but we tend to make that up when we get to the response to the charge a bit. So I think we'll break for lunch now. I'll turn it back over to Ms. Munir to close us out for the morning with any details that we need to know from the EPA.
Thank you, Dr. Cobb. I have no further comments or questions, and I guess we can go ahead and adjourn for this portion of the meeting and break for 1 hour for lunch, 60 minutes. And the timer will be on the screen. Thank you.
Wait.
Sorry, just to confirm, this is John Kalmuskatz. The public comment will continue right after lunch?
Yes, it will.
Thank you.
All right. Enjoy your lunch, everybody. Thank you. And please just mute yourself and turn your video off.
All right. Welcome back, everyone, from lunch. It's George Cobb. I'll double check with Ms. Munir, see if there are anything housekeeping issues we need to work through before we get started back.
No, I think we can go ahead and get started with the roll call.
All right. So let's do our roll call first. And Dr. Opti.
I'm here.
And Dr. Chasen.
I'm here. Can you hear me? I had to change computers.
We can hear you.
Thank you.
Dr. Ike, are you there? Yes, I see
Yes,
you.
I'm here.
Dr. Fox.
Here.
Dr. Gentry.
Here.
Dr. Heiger Bernays.
Here.
Made it back.
I did.
Ms. Jenkins.
I'm here, thank you.
Dr. Merced Nieves.
Here.
Dr. Rubin.
Here.
Dr. Semmel. I see you.
Yes, I'm here. And I just want to let you know, I'm having, unfortunately, some ongoing connectivity issue.
Okay, we can try to work
If I
with
drop
that.
off, I'm going to switch to my phone. So I will.
Yeah, you're dropping a bit now. So, Mr. Wright.
I'm here.
And now to our our ad hoc members. Dr. Roby.
I'm here.
Dr. Johnson.
I'm here.
Dr. McKenzie.
I'm here.
Dr. Fairbrother.
I'm here.
Dr. Eastman.
I am here as well.
Dr. Hopkins.
Here.
Dr. Bean Friedman. Okay. Dr. Fenner Crisp.
Here.
Dr. Mayer.
I'm here.
Okay, let's go back to Dr. Bean Friedman. Okay, did I miss anybody?
You missed me.
Santos,
yeah.
Yeah, sorry, I had a note that you're not going to be available, so I didn't call you. Yeah,
Oh,
thanks for speaking up.
Yeah.
Good deal.
Okay, thank you.
Glad you're here. Okay, so now we can proceed. The first thing I'd like to do is see if there are any clarifications that EPA would like to make of any of our things that we did yesterday. Were there any clarifications on those questions? If you'd like to save it for later in the day, we can.
Yes, we do have some follow-up for the questions that were asked yesterday. And I'll go ahead and read them into the record.
Okay, that would be great.
In response to a request to comment on the use of releases potentially affected by COVID pandemic in the risk evaluation analysis, releases of 1,3-butadiene from the toxic release inventory, release years 2016 to 2021, were used as an input for a modeling of ambient air concentrations for the general population exposure assessment. Annual TRI releases are available in the supplemental file. Document number 23, draft air releases for 1,3-butadiene in the tab named Overall Release Summary. The total stack releases for the year 2020 were the lowest out of the 6 years assessed, and the fugitive emissions for 2020 were the third lowest out of the years assessed. Each release year was modeled individually, 2016 all through to 2021, with annual average hourly ambient air concentrations available for each year. Annual average hourly ambient air concentrations are available in the supplemental file, document number 33, draft human exposure model, TRI 2016 to 2021, exposure and risk analysis for 1,3-butadiene. And the tab is named Memo Tables. The 50th and 95th percentile concentrations presented are based on the multi-year distribution across all 6 years. This information is available in the supplemental file, document number 33, the draft human exposure model, TRI 2016 to 2021, exposure and risk analysis for 1,3-butadiene. And the tab is named multi-year memo tables. In response to a request to verify the Port Neches, Texas data point from the AMTIC dataset, the 122.8 microgram per meter cube concentration, which is the highest 24-hour monitoring value from the AMTIC dataset, is available in the supplemental file posted in the 1,3-butadiene SAC docket, specifically document 19, the draft ambient monitoring technology information center monitoring data from 2016 to 2021 for 1,3-butadiene. 1,3-butadiene 2021 tab within the Excel file, row 175,279, column S, named sample value STD final microgram per meter cube. The AMA site is Texas 482450017 and it was measured and collected on February 21st, 2021. And the concentration is 122.88, 83390045166 microgram per meter cube. In response to question about conversion from ppm to microgram per meter cube, the conversion for 1,3-butadiene from parts per million to microgram per cubic meter was calculated using the following formula. Concentration in microgram per meter cube is equal to concentration in ppm times molecular weight all over a molar volume, where the molar volume is 54.0916 gram per mole. The molar weight, pardon me, is 54.0916 gram per mole, and the molar volume is 24.45 liter per mole based on temperature of 25 degrees centigrade and pressure of 1 atmosphere, resulting in 1 ppm is equal to 2.2 milligrams per meter cube, or 2,200 microgram per meter cube, or 1 milligram per meter cube, also equal to 0.45 ppm. In response to
Continue, sorry.
Okay. In response to a question about which type of occupational data was used for each occupational exposure scenario, 1,3-butadiene has a total of 15 OESs, occupational exposure scenarios, 11 of which were quantitatively assessed. Of these 11 OESs, 7 used the data set from ACC. 3 OESs use directly applicable data. 4 OESs use analogous data. The remaining 4 OESs used inhalation monitoring data from other sources. Please refer to table 5.1 on page 45 of the draft risk evaluation for 1,3-butadiene, in which the last column illustrates the data source of each OES. Note the 2 OESs, application of paints and coatings, and application of adhesives and sealants, are different OESs, but are assessed using the same data in the occupational exposure assessment. In response to question regarding the use of analogous data, specifically with respect to laboratory technician, in the case of OES used as a laboratory chemical, there is one paper in systematic review directly applicable to a commercial lab setting. Zhou et al. 2011, here ID 1255292. This paper was rated medium by the systematic review process. However, EPA determined that the lab technician data set from the ACC study was more appropriate for use in the occupational exposure assessment. While there were other monitoring data found in systematic review that could serve as analogous data, such as sampling of laboratory waste or waste handling tasks at 1,3-butadiene manufacturing and processing sites. Other cases of directly applicable data for these OSs were not found. Please advise if there are studies that should be brought to our attention. In response to question regarding how exposures are evaluated for a truck driver who may also be loading or unloading 1,3-butadiene. EPA assessed task-based activities regardless of employee status. Therefore, exposures due to the activities of loading and unloading are evaluated for the singular task, regardless of the employment status and other job responsibilities of the individual worker. In response to question regarding the IUR scaling factor, the adult exposure only unit risk estimates were multiplied by 78 divided by 62 to rescale the 62-year adult period to 78 years and to yield the adult-based lifetime unit risk. See Appendix F on page 165 of the draft Human Health Hazard Assessment for 1,3-butadiene and slide 71 of the OPPT technical presentation. In response to question regarding leukemia subtypes over time, the proposed 1,3-butadiene IUR for leukemia includes all leukemia cancer types. EPA did not differentiate between cancer subtypes. In EPA's systematic review, however, we identified and reviewed studies that included chronic myelogenous leukemia. The studies reviewed for the chronic myelogenous leukemia included Silkin 2007, Silkin and Valdez Flores 2011, and Silkin and Valdez Flores 2013, which are listed and summarized in table 5.3 on pages 62 to 63 of the draft Human Health Hazard Assessment for 1,3-butadiene. Since EPA did not differentiate between cancer subtypes, we did not analyze the trend of CML over time. That's all of the responses we have.
Thank you for those responses. And they will help us in crafting our further discussions.
They'll be transmitted to the committee in writing as well.
Thank you. I appreciate that. And now we can move into our continuing public comment. And I believe our next speaker, if I have not lost track, is Paul DeLeo.
Oh, okay. There we go. Thanks, George. Can you hear me?
Yes. Yes,
Great.
we can. And we can see you as well.
Thank you. Good day. I'm Dr. Paul DeLeo. I'm a Senior Director of Chemical Management in the Regulatory and Scientific Affairs Department at the American Chemistry Council. I'd like to take this opportunity to thank the members of the SAC for giving their valuable time to support the risk evaluation process under the Toxic Substances Control Act. And I'd also like to thank the Environmental Protection Agency for the opportunity to provide comments, provide these oral comments on the draft risk evaluation for 1,3-butadiene. ACC's Regulatory and Scientific Affairs Department has been reviewing the TSCA risk evaluation documents released by EPA going back more than 8 years now. Our focus, compared to our colleagues that represent specific chemistries, has been on the application of risk science during the risk evaluation process, regardless of the chemistry being assessed. As such, we have watched the risk evaluation process as it has evolved and become more consistent and aligned with EPA guidance and best practices for risk assessment. We have repeatedly commented on foundational elements of the EPA risk evaluations. Among the most basic issues on which we have commented is that of the application of tiered risk assessment. There are numerous reports and guidances from the likes of the National Academy of Sciences, International Program on Chemical Safety, or other authoritative bodies speaking to the utility of a tiered approach to risk assessment. EPA's 1998 guidelines for ecological risk assessment speak to tiers and iteration and identifying when the risk assessment is complete, stating that these are pre-planned and prescribed sets of risk assessments of progressive data and resource intensity. The outcome of a given tier is either to make a management decision, often based on decision criteria, or continue to the next level of effort. With that background, I speak to EPA's request for comment from the SAC regarding its conclusions to develop a qualitative assessment of risk to human and ecological receptors from potential exposures to 1,3-butadiene in environmental media, including soil, water, and sediment, in charge question 1, consumer exposure to 1,3-butadiene in charge question 3, and dermal exposure to 1,3-butadiene for occupational workers in charge question 4. Implied within these charge questions is whether it is appropriate for EPA to make qualitative risk decisions in its risk evaluation. ACC believes that it's not only appropriate that EPA make qualitative decisions where the data allows, but that it's imperative they do so. The broad spectrum of potential exposure scenarios for human and ecological receptors under what might be dozens of conditions of use for a chemical necessitates initial screening so that circumstances where the available information indicate minimal or even excessive exposure and risk can be quickly and easily determined and a decision rendered so that the agency's limited analytical resources can be devoted to those cases with greater uncertainty and variability in the available information. Application of qualitative methods for assessing risk can be found among sources from the Department of Energy and the National Research Council in its framework to guide selection of chemical alternatives. ACC is heartened to see progress from EPA over recent months in applying sound and pragmatic risk assessment principles to its risk evaluations, and we hope the trend continues under the current administration. We encourage the SAC to support EPA in its right-sizing the risk evaluations through more effective use of current risk assessment techniques so that the agency can meet its statutory requirements regarding scientific standards and deadlines to complete a risk evaluation within the budget it has been allotted by Congress. Thank you. That concludes my remarks.
All right, thank you. Are there questions from the committee? Okay, if not, we can move to our next speaker. Thank you. And our next speaker is Niraja Aragantula, and I'm sorry if I mispronounced that.
Good afternoon, everybody. No, you got it sort of right. It's Neera or Neeraja, so either one is okay. My name is Neeraja.
Yes, hello. This is Ali Munir. We're seeing part of your head cut off. Can you? Okay, there we go. We can see you better now. Thank you.
Yeah. Good afternoon, everybody. My name is Neeraja Aragantla. You can call me Neera. I am a board-certified toxicologist and a director at the American Chemistry Council. I also managed ACC's 1,3-butadiene TSCA Risk Evaluation Consortium. Next slide, please. 1,3-butadiene is an essential building block chemical. 1,3-butadiene derived polymers are very common in our everyday products. The reason for this is 1,3-butadiene is reacted and polymerized and consumed in the process. In many cases, when they make intermediate products, further processing happens to create a wide range of everyday products. Some examples of these are the synthetic rubbers, the nylon and plastics that we see, the tires and many parts of the car, rubber hoses and gaskets. Because of it being consumed, our understanding is that the potential for consumer exposure to 1,3-butadiene is very low. Next slide. In addition to everyday products, 1,3-butadiene is a very important chemical building block chemical and has many critical uses in many sectors that are also including national security and critical infrastructure. We developed a series of infographics that you're seeing on the screen showing the various applications. I'm just going to highlight a few for the time, because of the time. 1,3-butadiene in the defense sector has many applications. If you see that the military gear that the soldiers are wearing and all the different products that are there. 1,3-butadiene is commonly, as you know, is in tires. And for having electric vehicles, you need high performance tires. And for high performance tires, you need butadiene. 1,3-butadiene is also present, derived polymer. Nylon is very important in the life-saving airbags in our cars. Other examples are in the other sectors include the health sector, where you see 1,3-butadiene derived polymers in the masks and in the gloves, and also in the tubing that we see in many of the healthcare sector devices. 1,3-butadiene has critical uses in electronic applications. All of us use consumer electronics, and 1,3-butadiene polymers are there in also electric and electronic equipment. 1,3-butadiene is also there in critical uses in infrastructure, building and construction. And the ACC Butadiene Consortium website has a lot of information on this and in agricultural applications and sporting goods. Next slide. So I will not go into detail right now. I'm just giving you an overview of written comments, and we request the SAC and the agency to look at both the dockets. EPA has an OPPT docket that they opened earlier when the risk evaluation got started, and more recently, the SAC docket. There's a wealth of information in those dockets. So as we heard yesterday, there's improved understanding and ability to quantify species differences in metabolism. Updates are available on the key occupational cohort study, and we're very, very thankful to all our collaborators, the International Synthetic Rubber Producers, the Styrene Research Institute, University of Alabama, University of Minnesota, for helping us develop, and Dr. Ciriaco Valdez Flores for helping us develop these detailed and high-quality documents. All of these have been provided in written form and as presentations in the EPA dockets. The consortium has also developed detailed written comments on the draft risk evaluation, and it is my understanding that the 1,3-butadiene value chain, including the international synthetic rubber and the US tire manufacturers, have also provided detailed information, and we request the SAC and the agency to look at that. The purpose of these comments are just to help EPA make sure that its risk evaluation meets the TSCA statutory requirements and is based on the best available science, and the weight of evidence has been discussed in a clear and transparent manner. Next slide. You've seen this slide from Mr. Kerman yesterday, and my purpose of bringing it here is to just reiterate the importance of source characterization of 1,3-BD emissions in ambient air. As you know, as seen from this slide, 73% of the emissions are coming from forest fire, and the next highest contributor is mobile exhaust, with industrial processes only a small portion of 2%. Next slide. So we have a few recommendations that I have listed here. Again, more details in the written comments. As most of our subject matter experts have already explained or will explain soon, we are requesting and recommending EPA should refine the general population exposure modeling, that there should be a de minimis concentration level. The consortium should recommend more representative data. Next slide. And it should refine the inhalation unit risk factor, and that the ONU data, if it's not available, the occupational non-exposure data should be lower than the worker exposure data. If the next 3 slides, I know I'm out of time, but it's just a list of publications that would be useful for the stakeholders at large and the SAC. Could you please go to the next slide? So these are all the white papers that we developed. They're open for access and for download. I would recommend you to look at the residual 13BD paper that I sent to Ms. Ali Munir. It's a PDF on a website that goes into more details about the residual 13BD and the migration of 13BD in derived polymers. And the next 3 slides, if you just...
Okay, so we're going to have to cut it off here now. So
Sure.
thank you very much, Dr. Erin Gulta. And so we'll make sure we'll upload that onto the docket for everybody to see the remaining slides as well. So I'll turn it over to Dr. Cobb.
Yeah, thank you, Ali. And I'm sorry, I couldn't see the clock, so I couldn't know what the time was. So thank you for the comment, and thank you, Ali, for keeping us on time. Are there questions from the committee? If there are none, we can proceed to the next speaker, which is Silvia Malberti. I think that's a former ad hoc member for our committee.
Yes, thank you. It's great seeing you again. As you guys know, thank you everyone for your attention. I am an exposure scientist with ExxonMobil Biomedical Sciences, Inc., and today I am presenting on behalf of the ACC 1,3-butadiene Consortium. This presentation focuses more on the occupational exposure assessments, particularly questions 4A. Next slide, please. This slide shows a very generic distributions. The one to the left shows a very severely censored distribution where over 80% of the samples are below the detection limit. And you can see that there are very few detected values, but they are significantly impacting the mean and the 95th percentile of that distribution. This can lead to an overestimation of the statistical metrics. The one to the right, on the other hand, has just 30% of the samples below detection limit. Now you can see how many more samples contribute to the estimation of the mean and the 95th percentile. The industrial hygiene data has, for the majority of the OESs reported, is considerably high or severely censored, and therefore the actual air concentrations might have ranged from 0 to the detection limit for the vast majority of the samples in this data set. So the central tendency and the 95th percentile can be highly biased towards the right. Therefore, determining the risk of an entire occupational exposure scenario from the 95th percentile is a highly censored data set is not scientifically defensible. Next slide, please. EPA found unreasonable risk for many of the OESs only at the high-end exposure level, but not at the central tendency metric, even for those distributions that are highly or severely censored. It is important to note that EPA since 1992 has stated that the LADC should be estimated using the average concentration because it's more representative of the concentrations that an individual would become in contact with over time. As such, for routine occupational exposures, the best estimate for long-term exposure is the mean. Next slide, please. EPA estimated an intermediate average daily concentration, assuming an exposure over 30 days. As it can be seen in the example tables of the ACC data set, workers in the manufacturing and processing as chemical reactants conditions of use carry out frequent tasks repeated daily or weekly on an average of about 2 hours per day, and infrequent tasks are repeated less than 12 hours, 12 times a year. Their exposure pattern is more consistent over time. Therefore, an intermediate average daily exposure is unlikely to represent any real exposure for these conditions of use. Next slide, please. Assuming a high-end estimate equal to the 95th percentile of the concentration for 22 of those days for an intermediate exposure is beyond conservative. For example, for a group that had 455 samples, only 23 of them were above the detection limit. Since this metric is slightly biased high, it is unreasonable to assume that a worker would experience the 95th percentile of the TWA for those 22 days. Finally, EPA has stated that an intermediate exposure duration was selected based on available health data. However, this data was based on an exposure window that is corresponding to fetal body weight endpoint, and that is based on a study that had an exposure 10 over 21 days, which is 50% gestation period. to ensure the duration and window of susceptibility correspondence, we need to have the exposure duration of this endpoint corresponding to 50 to 100% of the human gestation period, which would be 20 to 40 weeks. Sorry. Next slide. Last slide. Promise. An important outcome of the risk evaluation is to help inform risk management, especially in the workplace. Traditional occupational programs aim to mitigate exposure at the task level. In the graph to the right, you see a hypothetical daily exposure pattern for a worker. Under current OSHA standards, PPE would be used with the input at 0.5 ppm. However, if you see in the table to the right, you'll see that respirators are required even before that. It's just because the task could present a potential for exposure. So regardless of the exposure being there or not, you already have tasks that are protected. So in the case of intermediate exposures, it is not really clear how occupational health programs could control such exposures, especially when the workers have routine tasks over the day. And that is my timer. Thank you for your time.
Thank you.
Happy to answer any questions.
Are there questions from the committee? If not, I actually have one, and I'm not sure if it's a question or comment. Well, let's go to Dr. Santos Bourgois first.
You're on mute.
All right.
Again.
I expect you to start, George. Thank you very much for this presentation. On the distribution of your measurements, I would like to have better understanding. These measurements that you reported in the document that you submitted, are these personal measurements? Are these area measurements? Are these modeled measurements? How representative each one of those measurements are of the actual practices, the actual posts, position posts? I would like to have a sense, because you can have just how did you actually select it to have that sampled? So
thank you for that
go in
question. No, thank you for that question, because this is actually ties into some of the questions that Dr. Wright mentioned yesterday as well. And this is relative to the ACC compilation of exposure assessments that have been done over the last 10 years or so. It was 2010 to 2019, if I recall correctly. And as Mr. Wright mentioned yesterday, yes, OSHA has a butadiene standard, and under that standard, you must characterize exposures and implement certain controls in the workplace, right? So because of that, we had a wealth, the various companies have a wealth of exposures that they have to characterize. And so to his point, and Dr. Wright is coming out, so great. To his point, right? So yes, we are looking, it's mostly probably biased high in the sense that we would be monitoring first the workers who we think could be exposed, and then you implement controls, but you need to characterize the exposure. And I am going to stop looking because everybody's raising their hands. So with that, that's why we have, we compiled all of the data that the various members of the ACC consortium, 1,3-butadiene consortium, had available, and that's the data that we've been mentioning and some of the tables that we shared. So those samples are all personal measurements. They could be and they're stratified by full shift or task. We have it for normal operations and turnarounds or emergency responses. So yeah. I can keep going if you want me to. I don't know if that addresses your question.
Okay, no, yeah, sort of. I think I have to go deeper into the report that you submitted.
Happy to continue. So there is Julie Panko is gonna be a speaker as well, and she's the author of that paper. So what we did, we all of us submitted the sample to, again, I think there was an allusion to industry-funded data being biased. And so one of the things that we did to help that is that we provided our data to a third party, and she was the one who blindly compiled all of that information and carried out as an objective third party. She carried out all of the assessments and reported all of that. So we provided that data to her. Mr. Wright, you came out on camera, so.
Well, thank you for that, and I agree with your characterization of the OSHA standard and the sampling requirements. Just to be explicit, a company has to do initial sampling when they first expose workers to 1,3-butadiene, and they have to after that, if those are above either of the exposure limits, they have to repeat the sampling every 3 months. If they're not above the exposure limits, then they repeat it every year.
Yeah, and so we did not differentiate between one and the other. We just compile all of the information. So I can speak to the data that we provided. My company provided. I cannot speak to everybody else's data, and that's why we blinded it and submitted it to a third party to do that. But we didn't differentiate between like every 3 months or every year. We compiled all of the data that we have on 1,3-butadiene, if that is of any help. That's why you have like almost 6,000 data points.
Okay, nice. Thank you. Dr. Mayer.
Oh, trying to get the video going here. But thanks for the presentation. I just had a couple of data clarifications at this stage. I just wanted the first question is, with regard to the data submitted, I'm sure it just provided the actual sampling time. But
yes.
Was the data provided also adjusted for standard shift lengths, or is that something EPA did separately?
We submitted it already as a TWA as well. Yeah, so we submitted the for tasks, they were submitted with the sampling time, right? But it was also submitted as the TWA already adjusted.
Okay, and at least in your practice, for the unsampled portion of a shift, what do you do with that time? Is it the same as average or 0?
So I cannot speak for all of the data. I can only speak for our piece of the data. Our industrial hygienists are instructed to provide the information and determine if the unsampled, we have sampled. The question is unsampled time is equal to sampled, right? And so if it's equal, you don't assume 0. And if it's not equal, because you like, it's the end of the shift, right? And they came back to control room and they're not going back, that's a 0. And so we use that. But I can speak specifically for our data. I would expect that it's a common practice for everyone else, but I cannot state that as a fact.
Okay, it's just something we'll just want to check, because that's the way I do it as well in my own practice, but I'm not sure. It sounds like EPA did or is thinking that it would be 0 for the unsampled period, and we just need to check to make sure. Maybe Julie will know.
That's a question for EPA.
Oh, for EPA. Okay, so that'd be a question for EPA of how they handled that. But I just want that the question for Sylvia was how it was presented to EPA.
Right.
Exactly.
Okay. Second quick question is, I believe you indicated the data set does include sampling during turnarounds.
Correct.
Okay,
yeah, but it's separated, right?
A separate. Okay. Noted as separate. Okay. And then we'll
so then that is something that, again, so I'm biased. I was part of the an ad hoc member in a different chemistry where we are not manufacturers, and that was one of the questions, and actually one of the recommendations that we had, to separate like continuous or like ordinary exposures versus unique times, or like emergency response or turnarounds and things like that. So we did that.
Okay, and that'll be a separate question for EPA, as Dr. Cobb indicated. Let's see. Thought I had one more, but I guess I'll stop for now. Thank you.
Right.
You can ask. It's okay.
Dr. Johnson.
Yeah, I'd just like to say thank you for your presentation. And it didn't go past a lot of us that there were a lot of non-detects and how to deal with that. And it sounds like you have some data. My question is, was your detection limit similar? And can you comment on the QA/QC of those data?
So detection limit. I think EPA yesterday also mentioned one of the challenges that we have with occupational exposure data that is different from environmental data is the fact that the detection limit really changes with the duration, the sample duration, right? So that's one of the challenges. Typically, for full shift samples, the detection limit tends to be on the lower end, and it tends to be very consistent, tends. For the short-term samples, that's a different story. So that's one of the challenges that we have one on the other. So I can speak for the QA/QC of the samples that were done. Again, I can speak for our own practice in my company. The industrial hygienists have to verify the samples. If you have something odd, you have to go back and verify that that was an issue in the plant or what happened, and you resample or something like that. Are you asking about that QA/QC? So we turned in those samples to I don't know, Julie, I don't know if you're a doctor or Miss, I think it's Dr. Panko. And so she collated that if there are questions, they were clarifying questions, she would ask those specifically for the individual companies.
Now, I was really,
Does that address
I guess,
the question?
speaking to the laboratory methods that were used, chain of custody, that sort of thing.
Laboratory. Yeah. So we have to use standardized methods under OSHA. And there is a full protocol that you have to follow, right? So there's a chain of custody. You have to use accredited labs. We typically use again, I can speak fully for ExxonMobil, but I think it's the common practice as well from our sister companies that you follow the AIHA standard, you follow the AIHA recommendations, and we use AIHA certified labs, accredited labs. So I would expect everybody follow that. And in fact, that is part of what we said in the paper as well, that everybody, I will not speak for Julie if she had that question directly to each one of us. I think that was the case, but we'll have to verify with her.
Okay, I'm good, thanks.
Yeah, thank you. Dr. Samuel.
Hi, Sylvia. Thank you very much for that presentation. And I just have a couple of clarifying questions. Actually, Dr. Johnson asked one of my questions, but this relates to just a few more of the nuances of the limits of detection relative to the different tasks. So what do you know if, and this again, maybe a question too for somebody else, but if there was a difference in duration such that you think that there's maybe perhaps differences in limits of detection for non-routine tasks that are just simply not performed as frequently, that would influence or sort of unnecessarily influence the data, given the need at this point to use some kind of a sensor data analytical method that would then unnecessarily influence the risk outcomes just because of the duration of the sample.
I don't know that I quite understood the question.
Okay.
So
just in terms of, so for example, for non-routine tasks, so you have typical operations, we would expect maybe those are more commonly full shift, and would maybe then have a more common limit of detection for the sampling method if it's a standard method. However, if we're looking at non-routine operations, would you just by nature of the operation or that activity or task, which is not full shift, therefore have a higher, of course, limit of detection because you've got a shorter that could have influenced the results?
Oh, that's a great point. So I think there's like a difference that we have to highlight, right? So you might have, so a lot of the samples that were used, in fact, were full shift, and because of random sampling and everything else, right? You would expect that you have most likely routine samples already captured there. And in some cases, you might have non-routine samples already captured, like, right? That's part of the idea of having a random sampling. So with that, if you're doing full shift, you would have captured that activity, and your detection limit would be relatively lower just because it's a full day. Now, so like, let's flip that to a task, right? Some tasks are relatively short, and therefore, depending on the method that you used, right, you would have a higher detection limit or not. And that's what you see in some of the samples that you have like higher detection limit, which would have not been ideal. That's what we have. That's the nature. This is 20 years old data or 10 years old data. We had some of those issues, right? And so those tasks, I think we have to pick a little bit apart and have a better characterization of those in and of themselves. There are some tasks, though, particularly turnaround, that we're going to call them tasks, but they're like all day. So those are going to be full shift, and they would have been already captured in there. Does that answer your question?
Yes, I think so. I just wanted to be aware of, potential concerns by OES or occupational exposure scenario. Of course, if there is some concern for an inadvertent, potentially inadvertent adjustment of the exposure assessment based merely on the duration of the task, which then influence directly the LOD, which is directly then influencing the central tendencies.
Right. Well, and
Yeah,
I think that's part of our discussion for later in the day.
Okay.
I don't think that's
Okay, thank you. No, I appreciate that. And I do think Dr. Maverti answered my question.
Okay, Mr. Wright.
Yeah, just a quick point about my experience with the way time during a shift, which is not sampled, is handled by OSHA and at least most of the employers that we're familiar with. OSHA cannot assume that that's anything other than zero for essentially legal purposes. They can't sustain a citation if they're estimating exposures for the unsampled portion of a shift. Most employers do it that way as well because they do not, and I don't mean to say that this is an example of malfeasance or anything. It's just the way it's done. But they don't want to have an exposure that's recorded for regulatory purposes that is higher than the permissible exposure limit, because that obviously comes with some obligations. So standard practice, at least as we have seen it, is that unsampled time is considered zero. Oh, and one more thing. I believe, or I'm speculating, that most of the data in the ACC's data set was taken for those purposes. So I'm assuming that it was not that the unsampled time was considered zero. Some very responsible companies may do it differently, but I think that's standard practice.
I respectfully disagree, and I can speak directly for the practice that we have in our operations, that the industrial hygienist has to qualify if unsampled is equal or not to zero. Kind of like, and again, so like if you have a 12-hour shift, if you've been in manufacturing operation, right? The workers come in at whatever, shift change, they spend some time in the control room, right? They go out, they do their tasks, they come back and so forth. And then at the end of the shift, we have the same thing, we have shift change. And so they're typically there the last half hour, depending, at least the last half hour, at least, right? So particularly for a full shift, right? So it's an easy assumption to say that the last part, if you did 440 minutes and it was 480 minutes, it's a safe assumption to have, right? And so I can speak for typical industrial hygiene practices. That's what we do. I would expect, again, my colleagues would have done the same. Now, for task samples, that's a different thing. And that's why we separated the tasks separately. Yes, we do assume we do the estimation for the TWA. However, again, I think for the purposes of this risk evaluation, right, we're doing lifetime exposures and things like that. And EPA used mostly the full shift samples. And again, those samples would have captured some of those activities. Again, typical industrial hygienist, right? You do full shift, but if you have a specific task that you need to characterize, you would do an additional, again, some people would do just the task. So many of us would have done both the task and the full shift. It depends on the resources that you have. It depends on a lot of other things, of course, but like I wouldn't overgeneralize and say that people do not want to share, that is a potential high exposure, because one of the things that you want to do is characterize the exposure correctly so that you can implement the correct controls. You don't want to have a worker without PPE in the middle of the summer in Texas if it's not needed. But if it's needed, you want it there and you need to characterize it.
Yeah, I think you're doing it right, and I think that's laudable. One of the biases I have is during most of my career, the time I got called into a situation, it was when people were doing it wrong. Our members didn't tend to call us when they thought everything was fine. So we tended to see the bad actors more than the good actors.
And that's why my last call for action and informing the risk management, right? So one thing that you want is a risk management that is easy to implement, that is logical to implement, and that people can follow. Yeah, so for sure. We need to protect our workers. It's in nobody's benefit not to have a healthy workforce.
Okay, thank you for that presentation and for the discussion.
Thank you for your time.
Yeah, nice to see you again. And now we can move to Julie Panko.
Hi, everyone. My name is Julie Panko. I'm a principal scientist and industrial hygienist with Tox Strategies. But today I'm here on behalf of the ACC 1,3-butadiene TSCA Consortium, and I appreciate the opportunity to share some comments regarding the occupational exposure assessment part of the risk evaluation. Next slide. My first comment is on the use of the consortium's data as analogous for other COUs. While we agree with EPA that the consortium's industrial hygiene data set is of high quality and appropriate for use in the agency's occupational risk assessment, when using the data set as analogous to other COU, however, there are places where the data have been applied inappropriately. The first is with respect to the laboratory technician job group. The application of the consortium data to the commercial laboratory OES is not appropriate because there are significant differences between industrial and commercial laboratories, and I've listed some of those here on the slide. Additionally, for the non-routine data, there was only a single data point, and it is not appropriate to characterize an entire OES with one data point. Furthermore, the non-routine data point was originally mischaracterized as full shift when, in fact, it became known to us that it is actually a short-term 15-minute sample. So a revised industrial hygiene report was submitted to the SAC docket with this correction made. Secondly, the use of the consortium data to characterize recycling and waste handling, as well as the repackaging OES, is not appropriate because the agency has used the consortium's short-term task level data and applied it as full shift 8-hour or 12-hour TWA concentrations. The consortium's revised IH data report contains metadata related to the exposure time and frequency for various tasks. Additionally, the activities associated with the consortium data for these OESs or these activities are not the same as those in the OES groups that EPA has applied them to. Next slide. The second area for comment is regarding the evaluation of ONU exposures. EPA's assumption that where data are lacking for ONU exposures, that they are actually equal to worker exposures is flawed. And that's because it's based on the very definition of an ONU, which is a worker that does not have direct contact with the chemical. We ask EPA to reconsider this assumption. It's also possible that the consortium data for ONUs could be leveraged to determine an ONU factor or a ratio that could be applied in cases where the data are lacking. Next slide. My third area for comment is on the characterization of occupational tenure. For the lifetime and average daily concentration calculation, EPA selected 36 years as the central tendency value for occupational tenure. This value was based on tenure data specifically for workers aged 50 and older. This value appears to be biased high for several reasons. One, the median age for workers in the chemical manufacturing industry is only 44.5 years. Therefore, the data associated with workers 50 and older is not representative of central tendency. Additionally, when looking at the median tenure for the SBR cohort from which the butadiene cancer slope factor was derived, the median was only 8 years. And lastly, the EPA Exposure Factors Handbook provides a median tenure for workers of 7.9 years for men and 5.4 years for women. Last slide. My last comment is that there is a discrepancy between how EPA assigns synthetic rubber manufacturing condition of use in various parts of the risk evaluation, which may impact the exposure assessment. So in the scoping document and in the draft risk evaluation itself, it is assigned to the processing as a reactant condition of use. However, in the technical support document for environmental and occupational exposure, it is defined and assigned to the plastic and rubber compounding. So as we've heard, synthetic rubber production involves the polymerization of butadiene monomer into a polymer, and it should be evaluated in OES for processing as a reactant. And that concludes my comments. Thank you for your time and your work on this evaluation.
Thank you. Are there questions from the committee? Dr. Mayer.
Thank you for the presentation. Just one quick question is, with regard to using data as analogous from the consortium's data set, if the indication is it's not analogous, it kind of makes the assumption that you have some knowledge about what those other uses that they're applying it to are, that they're different from each other. And I wasn't sure. EPA seemed like they didn't have a lot of data on the other uses, so I didn't know if there was information that could be available or that that would help EPA as far as understanding how the other uses might look as compared to the ACC's uses.
Yeah, I elaborated a bit on this in the written comments. So when you think about the laboratory technician, the data assigned to laboratory technician job group in the consortium data set, is, I think, very different. The job tasks of those lab techs can be very different than what you might see at a commercial lab. So in the consortium data set, the lab technicians often also collect process samples. And so they might go collect the process sample from an actual process stream, take the sample to the lab and analyze it. A commercial lab technician is not going to do that. There's also a big variety, I think, in terms of the concentration in the butadiene streams that would be different than how a commercial lab technician might handle like an analytical standard for analysis. I think there was also, it was not really certain in terms of the repackaging OES. So, I guess repackaging in the manufacturing or processing as reactant condition of use is really more like bulk transfer from a process unit to a tanker or some sort of very large storage unit. And I think it was brought up yesterday, I can't remember who brought it up, but like when you think of repackaging EPA describes in the risk evaluation that it is from a large container to a small container. And that is not the repackaging that you would see at the manufacturing level, for example. And then even in the waste, EPA describes that as disposal or recycling, and the waste handling that is described in the industrial hygiene report that's associated with those samples is really about handling like laboratory waste, taking it from the lab to wherever the waste disposal happens at a facility, or something happening at the wastewater treatment plant. So the ICE report is clear and describes those things, and it just doesn't seem like that those are not consistent with the activities that EPA described in the risk evaluation.
Thank you.
Right. Are there other questions? If not, thank you. And we can move to our next presenter, Snar Rizvi.
I'm not sure if that person will attend today.
Okay. So what about Alan Rovira?
I'm here. I have some slides. All right. My name is Alan Rivera. I'm an exposure scientist with Shell Global Solutions, and I'm presenting on behalf of the ACC. If we can go to slide number 2. This is just a disclaimer, a cautionary note from my company. Slide number 3, please. I appreciate the dedication of this committee and the opportunity to provide comments on the EPA's draft risk evaluation of 1,3-butadiene. My comments are focused on the general population exposure assessment and analysis charge question with a specific emphasis on point number 4. As a representative of the 1,3-butadiene manufacturing industry, there is a concern over the EPA's use of modeling to determine fence line community exposures. The EPA should, when applicable, validate the model assumptions against real-world monitoring data. It is the concern of the manufacturing industry that the predictive power presented in modeling is not as robust as quantitative monitoring to effectively assess the risks associated with the inhalation of 1,3-butadiene. As recently as March 24, 2025, various scientists and academics submitted online comments on the draft risk evaluation, noting that the EPA, quote, did not consider all relevant available chemical release data in its fence line exposure assessment, end quote. The concept presented by the scientists is that fence line communities are subjected to chemical incidents and releases for which modeling does not account. The idea that the EPA has not considered real-world exposures to 1,3-butadiene was similarly noted by the American Chemistry Council in their report, Evaluation of EPA TSCA Screening Level Approach, as they remarked that the EPA pre-screening approach is, quote, not predictive of real ambient concentrations. Next slide, please. In the ACC's publication previously submitted to the EPA, publicly available air monitoring data surrounding various manufacturing sites in both Houston and Louisiana was compared to TSCA pre-screening modeling results. Modeling stations from private industry and the EPA's air quality system website information were used to generate site-to-site trends of 1,3-butadiene during the time period of 2017 to 2021. In the Houston area, the Houston Regional Monitoring Corporation, or HRM, has 10 ambient air networks that have been monitoring air quality for over 35 years, while the Texas Commission on Environmental Quality has several stations in the Houston area. Next slide. Similarly, in Louisiana, public available air quality information from manufacturers of 1,3-butadiene was used to generate site-to-site trends in the industrial corridor, demonstrating annual ambient air average concentrations were below the Louisiana toxic air pollution standard of 0.42 ppb during this time period. Next slide. While the EPA has available data accessible for searching, some manufacturing sites, such as mine, which is the Shell Energy Chemicals Park, Norco, provides continuously updated air quality information. Shell Norco maintains a community ambient air monitoring website and searchable data tables containing information on chemicals released to air. 3 ambient air monitoring stations near the city of Norco, Louisiana, are designed to be operated continuously 24 hours a day, 7 days a week. The air monitoring sites are all within 1.5 miles of the facility and in a densely populated location. The network continuously measures total non-methane hydrocarbons at each site 24/7. Each site also collects one 24-hour duration canister sample every 12th day and is analyzed by EPA method TO Total Organics 15, which also includes 1,3-butadiene. The canister VOC sampler at each location is also configured to automatically collect up to 1-hour sample events when elevated concentrations of hydrocarbons exceed a predetermined concentration threshold. The purpose of the event sample is to measure the compounds frequently associated with emissions from refinery and chemical processes. Canister VOC's measurements can be used to help determine the composition of compounds collected during an emission event. Next slide, please. All of the information regarding the air sampling is maintained on the website. Additional community engagement is conducted through a quarterly community actuary advisory meeting. During the meeting, local concerns regarding the Shell Norco site are brought before the panel and discussed. Information about the ambient air issues is also discussed during these meetings. Next slide. In conclusion, the use of ambient air monitoring is a better indicator of manufacturing facilities' fugitive emissions and emergency releases for several reasons, one of which is the non-dilution effect from stack height releases. In addition, localized air monitors can account for cumulative air emissions from other sources based on location of the monitor, wind speed, and direction. It is therefore suggested that the EPA validate their model assumptions based on quantitative monitoring for these reasons. That's the end.
Thank you for your comment. Now, are there questions from the committee? Dr. Fairbrother.
Yes, thank you. This is an ancillary question. I was wondering if you have any wastewater discharge, and if so, if you have any data for chemicals in your discharge.
So for our wastewater, we have a wastewater treatment facility that is a separate entity away from our Shell Norco chemical complex. And actually, I'm glad you said that because previously yesterday, we'd like to provide some clarification to a previously submitted comment. One of the other presenters early on talked about my facility, the Shell Norco facility, and how that the EPA, when they evaluated their NEI and TRI releases, that they omitted some data from the facility. But the chemical facility, which makes 1,3-butadiene, is separate from the facility does the wastewater treatment. But yes, we do have emissions sources from the wastewater treatment, if that answers your question. And it is, and it's in the NEI data.
Thank you. Yeah, and thank you for that presentation. I think some of what you said echoes what Ms. Jenkins said from TCEQ here today. And some of the things I've been encouraging EPA to ground truth modeling data with monitor data. So I appreciate your comment.
Thank you.
Okay, we're nearing the end of our public comments. Our last public commenter is Jonathan Katz, excuse me.
No problem. Thank you. Can everybody hear me?
Yes.
Okay, great. Thanks so much, and good afternoon. I'm John Katz from Earth Justice. I want to begin by thanking the members of the SAC for their time and EPA staff for all of its work on this risk evaluation. I'm a lawyer, not a scientist, so my comments will focus mostly on the requirements of the Toxic Substances Control Act and how they shape the 1,3-butadiene risk evaluation. I know you received a brief overview of TSCA from EPA yesterday and that your charge is focused on the science underlying the risk evaluation. To assess that evaluation and advise EPA on how it can be improved, I think it is important to understand what TSCA requires of EPA. So at its core, TSCA directs EPA to evaluate and determine whether 1,3-butadiene presents unreasonable risk. including unreasonable risk to any potentially exposed or susceptible subpopulation. And a potentially exposed or susceptible subpopulation is a group, any group, that experiences greater risk than the general public because of its increased exposure to a chemical substance or increased susceptibility to harm from that exposure. Potentially exposed or susceptible subpopulations include groups who experience greater exposures to 1,3-butadiene because they are exposed for multiple pathways, routes, or conditions of use. For instance, the SAC has previously recognized that people who work at facilities that use and release a chemical often live nearby and are thus exposed on and off the job. EPA does not consider those aggregate exposures in the 1,3-butadiene risk evaluation. Instead, it evaluates each exposure pathway, the general population exposures and the occupational exposures in isolation. In response to charge questions 2 and 4 on EPA's general population and occupational exposure assessments, I would urge the SAC to advise EPA whether its failure to consider those aggregate exposures underestimate 1,3-butadiene's risks. I know earlier today there was some discussion about EPA's reliance on central tendency versus high-end exposure estimates. This provision of TSCA directly bears upon that issue. When you are required to evaluate and address the risks to the most exposed subpopulations, you cannot do so using central tendency exposures. The guidance that Dr. Maberti referenced in her comments, which recommended the use of median exposures, that was issued in 1992 under EPA's Superfund program, not TSCA. That matters because unlike TSCA, the Superfund law does not contain an express requirement to evaluate and address unreasonable risks to potentially exposed or susceptible subpopulations. So if most workers are exposed to lower levels of 1,3-butadiene, even below the limit of detection, and some workplaces or workers are exposed to much higher levels, TSCA requires EPA to determine and eliminate the risks to the group with the greater exposures. Potentially exposed or susceptible subpopulations also include groups who are more susceptible to harm because of their cumulative exposures to multiple chemicals and stressors. Earthjustice submitted written comments which explain that 1,3-butadiene is often released in the same neighborhoods, many times from the same facilities, as formaldehyde. 1,3-butadiene and formaldehyde are both associated with hematological cancer. Someone who's exposed to both of those chemicals is more likely to develop leukemia than someone who is exposed to 1,3-butadiene in isolation. Yet EPA did not consider those known cumulative exposures in the draft risk evaluation. In response to charge question 5 on EPA's cancer risk analysis, I'd urge the SAC to advise EPA whether co-exposures to formaldehyde and other carcinogens can increase susceptibility to 1,3-butadiene, and whether the failure to consider those cumulative exposures understates 1,3-butadiene's risks. Now, during yesterday's session, Dr. Johnson asked whether EPA had evaluated 1,3-butadiene's degradation into formaldehyde and other toxic chemicals. EPA said that it had not. That's a problem because, as the permanent members of the SAC know, EPA did not look at those risks in its formaldehyde risk evaluation either. So you have industrial facilities, which are undeniably regulated under TSCA, that are directly responsible for the formation of formaldehyde in the air, causing severe risks in communities like Houston and Port Arthur, Texas. But EPA isn't looking at that in either the formaldehyde or the 1,3-butadiene risk evaluation. That's not legally or scientifically defensible. Earlier today, Mr. Davis from the ACC seemed to acknowledge that EPA should account for those degradation products of 1,3-butadiene. I think it's really important for the SAC to recommend that analysis on both the human health and the ecological side, and that EPA do so quantitatively. EPA has the ability to calculate those exposures. Earlier today, Mr. Cooper from AFPM suggested that the consideration of unintended releases, such as facility malfunctions, spills, and startup and shutdown events, was inconsistent with TSCA because the words accident and spill don't appear in the statute. The statute does contain the word foreseen. TSCA requires EPA to look not only at known and intended exposures, but also at exposures that are unintended but reasonably foreseen. Now, some of the facilities that use and release 1,3-butadiene have hundreds of reported chemical incidents in Texas alone. This is according to TCEQ data, and many of those involve 1,3-butadiene. As you heard from Dr. Varner yesterday, releases from extreme weather events in the Gulf are also recurring, intensifying, and reasonably foreseeable. So I think the SAC should advise EPA to evaluate the risks from these recurring and foreseeable chemical incidents. I'd like to close with one final point. As you heard yesterday, EPA hasn't quantified human exposures to 1,3-butadiene from the water or soil in a draft risk evaluation because it claims that 1,3-butadiene will rapidly volatilize in the environment. Now, assuming that EPA is correct, and I'm not taking any position on that, such volatilization would result in more 1,3-butadiene in the outdoor air where it will be inhaled. EPA doesn't consider the inhalation of that volatilized 1,3-butadiene either. I don't think the agency can have it both ways, claiming that 1,3-butadiene is too volatile to justify an analysis of water and soil exposures, while at the same time ignoring the air exposures created by that volatilization. That's all that I have. I want to thank you again for your time and service, and I'm happy to respond to any questions.
Thank you for your comment. Are there questions from the committee? I don't have any questions either, but I can assure you that we'll be discussing the formaldehyde topic as we go forward. Thank you again for your comment, and thanks to all the public commenters today. Okay. We are perhaps ready to move into our charge questions. So if we can get the first charge question into the record, please.
All right. So the environmental exposure charge question 1A. This is Adi Adigule with EPA. As described in the draft environmental release and occupational exposure assessment for 1,3-butadiene, 1,3-butadiene is primarily released to air. The vapor pressure, Henry's law coefficient, and partitioning coefficient of 1,3-butadiene indicate that the chemical does not partition to, deposit, or persist in water or soil, and would be expected to volatilize quickly from water and land surfaces, as recorded in the draft physical chemistry and fate assessment for 1,3-butadiene. The majority of monitoring data indicate that 1,3-butadiene is not detected in water. This is documented in the draft environmental media concentrations for 1,3-butadiene. The EPA has concluded that contributions to exposure from the land and water pathways are expected to be small, and there is not expected to be exposure to aquatic and terrestrial species. Exposure of terrestrial organisms via ambient air is expected to be brief due to the reactive nature of 1,3-butadiene. Next slide, please. So 1A1. Please comment on EPA's conclusion to develop a qualitative assessment of 1,3-butadiene contributions to the land exposure, including groundwater and soil, for both human and environmental risk. It's documented in section 6.1 of the draft risk evaluation for 1,3-butadiene. 1A2. Please comment on the conclusion to develop a qualitative.
Okay, let's start with the just I, and then we'll open it up to the committee.
Thank you. I was just getting ready to say that. So thank you for getting that into the record. And our lead discussant for this is Dr. Rubin.
Okay, Dr. Rubin here. Shall I go ahead?
Please.
Okay. Given 1,3-butadiene's relatively high vapor pressure, quick atmospheric reaction rate in air, low water solubility, and low Henry's law coefficient, and that all environmental water samples were well below the MDL, one committee member agreed that there's limited potential for exposures from contaminated soil, sediment, or water, and that predominant environmental exposure should be considered from air. All committee members agreed that EPA's qualitative approach to the aquatic ecosystem risk assessment is valid and well supported. However, most committee members agreed that EPA should conduct a more in-depth analysis for terrestrial systems including a quantitative assessment for mammals. EPA did not address the breakdown products of 1,3-butadiene in the environment, nor did EPA discuss the potential for ecological risks from spills during transport of 1,3-butadiene. Because of the relatively low documented release of 1,3-butadiene into the environment from industrial sources, the decision was made to do a qualitative assessment for environmental sites, including land defined as groundwater and soil, and water defined as surface water, sediments, and drinking water. These defined environmental sites should be further defined as terrestrial, land and groundwater, and aquatic, surface water, sediments, drinking water, rivers, and other bodies of water. Similar to human health assessments, ecological risk assessments evaluate potential risk by comparing estimated exposures to established toxicological effect thresholds. However, ecological assessments are inherently more complex, as exposure can occur through multiple environmental media, for example, water, sediment, soil, and air, and affect diverse receptors, plants, fish, birds, herpetofauna, and mammals. 1,3-butadiene is released into the environment from industrial facility stocks and fugitive emissions, predominantly in gaseous form. Consequently, as described in Section 6 of the draft risk evaluation for 1,3-butadiene, EPA's ecological risk analysis focuses on air as the primary exposure medium. While EPA's conclusion of no risk to aquatic ecosystems is supported by the chemical's physical and chemical properties, their approach to terrestrial risk assessment is overly simplistic. A quantitative analysis comparing estimated terrestrial exposures to mammalian toxicity thresholds and knowledge of effects of other air pollutants to birds and plants can provide a more comprehensive evaluation of potential ecological risks. The presence of 1,3-butadiene is highest in industrial settings with release into the air. Further metabolism occurs in living organisms primarily exposed via inhalation. Both the parent compounds and secondary metabolites have been associated with adverse health effects covered in subsequent charge questions. Most of the data are in humans that are workers in industrial facilities that experience a higher concentration of the airborne form of 1,3-butadiene. Therefore, the compelling data that are quantifiable are in facilities and/or environments that are close to sources of 1,3-butadiene. Human populations, primarily PESS, may also have greater risk of exposure due to potential proximity to industrial sources using 1,3-butadiene. An area of concern involves the production of bioactive metabolites by a photochemical process, including formaldehyde, acrolein, and other compounds, citation included. There are additional uncertainties associated with exposure from other sources, vehicle exhaust, tobacco smoke, wildfire smoke. It is important to assess even if a qualitative assessment due to lack of data is conducted. However, several questions remain. First is the lack of quantitative data due to the sparsity or selectivity of sampling. The gaseous nature of 1,3-butadiene is problematic in assessing the quantity of the chemical in the environment, and it's more likely that products of this parent compound are more likely detectable in the environment. A recent study shows that 1,3-butadiene, acrolein, and formaldehyde are all co-exposures in ambient air that are significantly associated with an increased risk for breast cancer. This was despite low measured concentrations in the 0.05 to 0.06 micrograms per cubic meter range for both 1,3-butadiene and acrolein, relative to the other volatile organic compounds in the study. It's recommended to conduct quantitative cumulative assessments that account for such chemical combinations and co-exposures, even at low levels, considering carcinogens, mutagens, and reproductive toxins as a group. A discussion of bioactive metabolites also brings up the question of proximity to manufacturing sites, using 1,3-butadiene in production processes, and if the bioactive metabolites pose risk, especially in areas surrounding industrial sources. Additionally, is there a potential for high concentration and perhaps more transient exposures with other sources of 1,3-butadiene, with forest fires, car exhaust, wood burning smoke, that could have adverse effects on wildlife and human populations. This may be particularly relevant for PESS living in areas that juxtapose potential environmental releases due to multiple sources. Environmental exposure, sources, environmental transport, and fate. EPA documents sources of 1,3-butadiene releases to the environment in the draft risk assessment for 1,3-butadiene, differentiating among types of production, packaging, and transport facilities. While each facility will be located within a specific and different ecosystem, it is appropriate to generalize when conducting an initial screening level risk assessment similar to EPA's approach for general population exposures for assessing human health risks. For the purposes of this assessment, EPA should assume both aquatic and terrestrial ecosystems are present around each type of facility. EPA's summary in the draft physical chemistry and fate assessment for 1,3-butadiene of the transport and fate of 1,3-butadiene is as applicable to ecological risk assessment as it is to the human assessments. Line 167 on page 5 of the document says that furthermore, bioconcentration of 1,3-butadiene is expected to be low. End quote. Bioconcentration refers to the relative amount of chemical in air versus water. So this statement supports the conclusion that 1,3-butadiene will not be found in water. However, EPA also notes that the chemical will not bioaccumulate in aquatic or terrestrial food chains due to its low N-octanol water partition coefficient, log KOW 1.99. While this does indicate a lack of biomagnification, that is, each step in the food chain having a higher concentration than the previous one, it does not preclude the accumulation of some 1,3-butadiene in fatty tissues, and therefore the potential for dietary exposure exists. In the draft human health hazard assessment for 1,3-butadiene, EPA notes that quote, that the distribution of 1,3-butadiene following inhalation exposure has been studied in various species. Due to its lipophilic nature, 1,3-butadiene is absorbed through the lungs into the bloodstream and rapidly distributed through the body, with notable accumulation in adipose tissue, end quote. Citation included. Exposure concentrations, aquatic. The EPA's draft physical chemistry, fate, and transport assessment for 1,3-butadiene provides a well-supported characterization of 1,3-butadiene as a gas under environmental conditions. This determination is reinforced by extensive monitoring data from the Water Quality Portal, which indicates that 1,3-butadiene has not been detected in surface waters above the minimum detection limit. Additionally, fugacity modeling corroborates the assumption that this chemical would not persist in sediment. Consequently, the conclusion in the draft risk assessment for 1,3-butadiene, lines 853 through 854, that 1,3-butadiene would not be present in surface waters or sediments, and that there is no unacceptable risk to fully aquatic organisms is justified. Terrestrial. EPA's conclusion that there is no expected risk to terrestrial organisms from 1,3-butadiene via soil exposure is correct, as the chemical is primarily present as a gas, does not bind to soil, and would not be likely to bioaccumulate in the food chain, similar to aquatic systems. However, EPA's decision in the draft risk assessment for 1,3-butadiene to dismiss potential risks to terrestrial organisms from air exposures is not justified. EPA asserts on line 1685 that the sources of 1,3-butadiene in ambient air are, quote, a combination of TSCA and other sources, forest fires, mobile exhaust, etc., end quote, suggesting that assessing risk from this exposure pathway is inappropriate. Nevertheless, in the draft general population exposure for 1,3-butadiene, EPA relies on these same data to evaluate potential risks to human populations residing near industrial facilities, demonstrating that a similar approach could be applied to terrestrial organisms. To strengthen its evaluation, EPA should incorporate either the maximum measured concentration, 122.8 micrograms per cubic meter, or the highest modeled concentrations from the integrated indoor-outdoor air calculator, or the human exposure model, 3 3.4 micrograms per cubic meter, while clearly stating the associated uncertainties. There will, of course, be other sources of uncertainty when applying the measured or modeled air concentrations for wildlife exposure assessments. Notably, human exposure estimates are based on air concentrations measured 3 to 6 feet above ground level, whereas small mammals would experience exposures closer to the soil surface, and birds would be exposed at higher elevations. Given that 1,3-butadiene is heavier than air, relative density 1.867, it may be more concentrated at lower levels, potentially increasing exposure for small animals, including those inhabiting burrows, though data on this phenomenon are currently lacking. Similarly, exposure estimates for birds may be overestimated using the human exposure data. Ecotoxicity data, missing from the document. EPA's draft risk evaluation for 1,3-butadiene states that, quote, there are no relevant hazard data available to assess potential risk to terrestrial organisms, end quote, line 1796. While this is true for several classes of organisms, it's not the case for mammals, and inferences for other classes can be made based on literature information for other volatile organic chemicals. Mammals. The draft human health hazard assessment for 1,3-butadiene includes relative hazard data for mammals, compiling laboratory studies on non-cancer toxicity thresholds for mice, rats, and rabbits. Note that cancer as an endpoint is not used in ecological risk assessments. The data plots on pages 32 through 35 of ATSDR are very useful in showing the range of species sensitivity for various measured endpoints during acute and chronic inhalation exposure experiments. EPA should consider providing these graphs in the environmental risk assessment document. EPA acknowledges that the metabolism of 1,3-butadiene is generally conserved across species, with some exceptions making these test species appropriate surrogates for wild animals. In a screening level ecological risk assessment, the most sensitive endpoint for the most sensitive species is used to quantify hazard without the application of additional quantitative uncertainty factors. In this case, decreased fetal weight in mice was the most sensitive acute endpoint, with an unbounded Lowell of 40 ppm, or 88,000 micrograms per cubic meter, citation provided. Ovarian atrophy in mice represents the most conservative or health protective chronic endpoint, providing a toxicity threshold of 6.21 ppm, or 13,662 micrograms per cubic meter, based on a Lowell from a 2-year exposure study. Unfortunately, due to limitations in available exposure concentration, a benchmark dose at the 5th percentile BMD5 could not be developed, nor is there sufficient data across species to generate a species sensitivity distribution. Therefore, the Lowell values for acute and chronic hazard should be used in this risk assessment. Although the ovarian atrophy endpoint was not utilized in the human health assessment due to uncertainties in interspecies extrapolation to humans, it's appropriate for ecological assessment purposes. The mouse serves as a representative species for wild mice, and the other tested species, rats, rabbits, exhibited higher hazard thresholds, most likely due to differences in rates of metabolism of 1,3-butadiene. Consequently, the use of mouse data as a screening threshold is reasonably conservative for protection of other mammalian species, albeit with moderate uncertainty. Birds. The potential risks of 1,3-butadiene exposure to avian species cannot be quantified due to the absence of inhalation toxicity data for birds. However, given their rapid metabolic rate, small body size, highly efficient respiratory system, and low body fat content, birds may be more susceptible to 1,3-butadiene exposure and have a lower toxicity threshold than mammals, citation provided. Birds have been shown to be significantly affected by urban and industrial air pollution, citation provided, air pollution impacts on avian species via inhalation exposure, and associated outcomes, supporting the conclusion that they could be susceptible to 1,3-butadiene releases. Reptiles and amphibians. Similarly, no toxicity data are available regarding the effects of 1,3-butadiene on reptiles and amphibians. Adult amphibians such as frogs, toads, and salamanders could exhibit greater sensitivity to airborne pollutants than mammals due to their capacity for gas exchange across the skin. Conversely, the slower metabolic rates of reptiles and amphibians in colder temperatures may reduce the rate of metabolism of 1,3-butadiene, potentially raising the exposure levels at which adverse effects occur. Plants. Plants are known to be susceptible to soil contamination from petroleum hydrocarbons, citation included. However, they appear to be significantly less affected by exposure to gaseous forms of these compounds. While specific data on the effects of 1,3-butadiene to plants are unavailable, a literature review of the effects of airborne volatile organic compounds on plants suggests that effects at environmental concentrations are unlikely, citation provided. For example, field studies indicate that vegetation damage observed near roadways is primarily attributed to nitrogen oxides in exhaust gas rather than VOC exposure. Given this evidence, the hazard of 1,3-butadiene to plant life is likely low. Ecological risks. Aquatic. EPA's conclusion of no unacceptable risk to aquatic organisms with high certainty is correct. The lack of exposure due to the gaseous nature of 1,3-butadiene precludes the possibility of risk. Terrestrial, wildlife. EPA argues that risks to wildlife from inhalation cannot be assessed due to the transient nature of most terrestrial organisms and the absence of specific activity pattern data of such organisms in or around a particular TSCA COU, and that there are no relevant hazard data available to assess potential risk to terrestrial organisms, line 1791. Neither of these arguments are correct. As discussed above, hazard data are available for mammals and inferences can be made for other organisms. Furthermore, many small mammals have home ranges that fall well within the 1,000-meter radius of facilities where EPA has measured and modeled existing concentrations of 1,3-butadiene. For example, white-footed mouse found throughout the U.S. can have home ranges as small as 0.2 hectares. Other small mammals such as gophers, ground squirrels, and voles are also likely to reside in the vicinity of discharge facilities. Larger mammals such as deer may browse in the area for several hours before moving on, while various bird species could experience prolonged exposure, particularly during the nesting season when individuals remain stationary for extended periods. Birds of prey frequently perch on trees and power lines for hours, while species such as owls roost in trees. Ground-dwelling birds, including quail and grouse, may inhabit a small area for an entire season if food sources are abundant. Reptiles, such as snakes and lizards, are present in most ecosystems and have relatively small home ranges. Adult amphibians will be found near wetlands and water bodies that potentially could be within an impacted area. For the purposes of a screening level ecological risk assessment, EPA should assume continuous lifetime exposure for wildlife species. If risks are identified at maximum estimated exposure levels, adjustments can be made in subsequent assessments to account for more realistic exposure durations. EPA should also consider the possibility of acute effects for animals that may be moving through a contaminated area. Comparison of the mammalian hazard thresholds of 40 ppm or 88,000 micrograms per cubic meter for acute exposure and 6.21 ppm for chronic exposure to maximum measured or the highest modeled concentrations from the IIOAC or the human exposure model results in a very small hazard quotient. The acute HQ is in the range of 0.001 to 0.004, while the chronic HQ is 0.008 to 0.028. Therefore, EPA can conclude that there is no unacceptable risk to mammals with robust certainty. The draft risk evaluation for 1,3-butadiene in line 1741 asserts that dietary exposure does not pose a risk to terrestrial organisms, as 1,3-butadiene does not bioaccumulate. While it is accurate that 1,3-butadiene does not biomagnify through the food chain, evidence suggests that it does bioaccumulate in tissues. The draft human health hazard assessment for 1,3-butadiene on page 15, section 3.2, acknowledges that 1,3-butadiene is rapidly absorbed through the lungs into the bloodstream, distributed through the body with notable accumulation in adipose tissue due to its lipophilic nature. Given the distribution pattern, the potential for dietary exposure cannot be entirely dismissed. However, the absence of oral exposure studies for 1,3-butadiene precludes an assessment of risks associated with this pathway. A qualitative assessment using information provided above about relative sensitivity and exposure of other wildlife species to airborne pollutants leads to the conclusion of low to no risks with moderate uncertainty. Birds may be more sensitive to inhaled pollutants than mammals, but likely are less exposed. Reptiles and amphibians may be equally exposed, but probably are less sensitive due to lower metabolic rates. Plants. EPA should conduct a qualitative assessment of potential risk to plants, given that they will be present around all discharge facilities. Based on the literature about effects of VOCs on plants, it's possible to conclude with moderate uncertainty that there is low probability of unacceptable risk to plants. Risk assessment uncertainty, section 6.2.4. On line 1767 of the draft risk evaluation for 1,3-butadiene, EPA states that they have robust confidence in this environmental risk assessment. This is true for aquatic systems, as it is indisputable that 1,3-butadiene will be in gaseous form and therefore not in water or bound to sediments. Similarly, the conclusion of lack of unacceptable mammalian risk can also be considered robust, as exposure concentrations are nearly 3 orders of magnitude lower than known toxicity thresholds. However, risks to other wildlife classes and to plants can be assessed only with moderate confidence, based on professional judgment about relative sensitivities and extrapolation from information about other pollutants. The very low exposure measured or modeled air concentrations for 1,3-butadiene reduced some of the uncertainty, allowing the conclusion of moderate rather than high uncertainty in the risk conclusions for these organisms. General comments. Phytochemical breakdown products include acrolein, acetaldehyde, and formaldehyde. The breakdown products from 1,3-butadiene, notably formaldehyde, has documented adverse health effects and should be accounted for. The lack of data for the breakdown products presents an additional uncertainty when evaluating the potential risks to aquatic and terrestrial life. Quantitative assessment is difficult because of the high volatility and rapid breakdown in the air. Therefore, the EPA conclusion to develop a qualitative assessment at least provides some insight into the potential for risk from exposure. However, the lack of detection does not eliminate the potential for risk to wildlife and humans that are not in the industrial setting in which 1,3-butadiene is actively used. There are other sources of 1,3-butadiene, including vehicle exhaust, tobacco smoke, burning wood, forest fires, petroleum refining, manufacturing of rubbers, latexes, and burning of fossil fuels. Quantitative estimates will be highly variable for potential exposure and specific environments, such as proximity to industrial emissions, wood stove use, traffic, and forest fires. Groundwater hazard potential risk from injection wells is deemed extremely unlikely, but could be a source of exposure. The EPA's draft environmental media concentrations for 1,3-butadiene addresses the potential for drinking water contamination through groundwater affected by injection wells. The EPA suggests that such contamination is unlikely due to regulatory requirements for injection wells, such as multiple casing layers and other protective measures. Furthermore, the EPA's review of groundwater monitoring data from the Water Quality Portal indicates that all reported concentrations of 1,3-butadiene, over 9,000 of them, are below the method detection limit, which ranges from 0.81 to 40 micrograms per liter. This is a robust data set, but uncertainty is introduced due to lack of information about the geospatial relationship of the monitored wells to potential 1,3-butadiene injection wells or industrial facilities. Conclusion. EPA's qualitative approach to the aquatic ecosystem risk assessment is valid and well supported. However, EPA should conduct a more in-depth analysis for terrestrial systems, including a quantitative assessment for mammals. EPA did not discuss the potential for ecological risks from spills during transport of 1,3-butadiene. According to draft risk evaluation for 1,3-butadiene lines 2256 through 2260, the chemical is transported in liquid form. If there is a spill, the chemical could be discharged to either surface water or soil. EPA should discuss the rate at which the liquid would volatilize and the lack of binding to sediment or soil particles. It's likely that this would result in low risk to these systems, but it would be helpful to have this addressed directly. EPA also did not address the breakdown products of 1,3-butadiene in the environment, formaldehyde and acrolein. EPA has ambient water quality criteria for acrolein and formaldehyde. Formaldehyde's effects on plants are well documented. However, its toxicity is complex due to its role as a naturally occurring metabolic byproduct in plants. However, formaldehyde's toxicity threshold for plants is several orders of magnitude higher than the estimated environmental concentrations of 1,3-butadiene, suggesting that any formaldehyde produced as a degradation product would have a negligible impact. Acrolein, by contrast, is highly toxic to plants and is even used as an herbicide in aquatic systems such as irrigation channels. Long-term and high-dose studies in animals indicate that acrolein can cause systemic effects across multiple biological systems, including respiratory, reproductive, neurological, and hematological systems. However, acrolein degrades rapidly in air with a half-life of approximately 1 day due to chemical reactions and photodegradation. It also dissipates quickly from soil and water through degradation and volatilization. Given its short environmental persistence and the small quantities expected to form as a breakdown product of 1,3-butadiene, the risk posed by acrolein to aquatic or terrestrial organisms is likely minimal. Recommendations. Consider bioactive breakdown products. The conclusion of no risk to aquatic and terrestrial organisms is based on lack of detection and persistence of 1,3-butadiene in the environment is too definitive and does not consider breakdown products that are bioactive. It is recommended to conduct cumulative assessments that account for chemical combinations and co-exposures that result from chemical breakdown and environmental degradation. Exposure to terrestrial organisms can occur from multiple sources, which are likely to be transient. However, that does not mean that there are no adverse effects that could persist, especially associated with car exhaust, industrial emissions, wood burning, and other sources in addition to proximity to industrial sites. Consider noting which chemical physical properties are calculated, for example, from relationships KOW, estimated from models such as QSAR, or experimentally derived, see lines 850 through 851, relative affinity to organic carbon, KOC. Section 6.1.3 points out the bias of samples collected from a subset of states. Does this mean that there is greater risk for human and wildlife populations in these states? For example, industrial areas such as mentioned, Texas and Louisiana have documented higher incidence of cancer in PESS. Since the risk is not consistent, maps reflecting this potential risk could be helpful. And I have a few editorial notes as well. Shall I also read them into the record?
If you can just summarize those as best you can without actually reading the whole amount in.
Okay, figure 2.2-1 suggests 1,3-butadiene production and use to be a closed system, and it should include arrows to account for environmental releases and fate. Number 2, EPA uses the word land when describing non-aquatic systems. The term terrestrial is more commonly used for these ecosystems. Number 3, EPA should include a subsection in section 6 to discuss hazard of 1,3-butadiene to terrestrial organisms. And finally, the summary paragraph in the charge question could be written with greater clarity. Here's a suggestion.
Thank you.
My comments.
Yeah, thank you, Dr. Rubin. And that was a summary of your comments and the other discussants. Is that correct?
That's correct.
Okay, so first of all, those last few comments, perhaps if you can keep those where you have them, but also provide them to, who is it? Dr. Fox and Dr. Heiger Bernays, who are writing about the, is that right? Yeah, the clarity. If you could just port those comments over just so that we could get them maybe just in that section instead of in your section.
Gotcha. Will do.
And that kind of comment goes to all of the leads. If you can get that kind of thing to Dr. Fox and Dr. Heiger Bernays, they're going to be discussing the overall clarity. So let's open this up now to the other discussants and then the rest of the committee for clarifications or further comments. Dr. Fairbrother?
Yeah, thank you. Couple of quick kind of updates, I think, to what I had submitted earlier. In response to a question that I had yesterday, the air modeling data from both of the different kinds of models actually model air concentration at the ground level. So I thought that they were directed towards, like human exposure, so they would have modeled it higher, but it's modeled at the ground level. And of course, the measured data is measured higher at the 4 to 6 feet above ground level. So I think that's kind of an important revision to those comments. And then the other comment that I had about the line of evidence that EPA is using by going to the water quality portal to get data on surface water and groundwater and public water systems for drinking water. I actually think that that particular line of evidence should have a much lower weight than what EPA has been giving to it, particularly for the surface water. If you look at the surface water data that they end up using, again, this is primarily from STORAT, and one needs to kind of remember that there really isn't any screening or additional QA/QC that goes into the data that are uploaded to STORAT, so you really don't know a lot about the quality of the data that are there. But nonetheless, when you look at the data that are available for 1,3-butadiene in surface water, it turns out there's only 231 samples across the US. And those were from the years 2013 to 2015. So those are old data. 75% of those data came from 2014. And if you look at part of the problem, as I mentioned in my comments, is we don't know where these samples are in relation to where we suspect that there would be butadiene exposure, such as the Gulf Coast of Texas or Louisiana, and then wherever there are other manufacturing plants, that utilize the product. And just kind of looking quickly through the data set, I think there are some samples that are from states that I am pretty sure don't have any plants that manufacture products that utilize 1,3-butadiene. So my recommendation is that EPA should at least remove from the data set any samples from states that don't have plants that are in the TRI that have releases of 1,3-butadiene. That will, again, significantly reduce the number of samples in the surface water data set. There are no samples from Louisiana, surprisingly enough, and there's like 4 samples from Texas. And again, when you're looking at those data, some of the samples are from storm events. So then you could have a dilution of what is normally in the water, or it could actually be an increased amount if you have runoff from some kind of contaminated surface. So, regular monitoring versus storm events, flood events, those kinds of things are also mixed up in that data set. So I don't think we should put a lot of weight on that particular data set to say that the use of 1,3-butadiene doesn't pose any surface water exposure. It may help answer the question about general ambient butadienes from other sources that we keep talking about, forest fires and automobiles and that sort of thing, because again, those are distributed more widely across the continent. But specifically asking questions about potential exposure from industrial use of 1,3-butadiene. I don't think the water quality portal data for surface water are very useful. And for the public water systems, as I mentioned earlier, we don't know if those data are from groundwater or from surface water, what types of surface water. We're talking about streams, lakes, large rivers, whatever. We don't know where these waters come from. So again, it gives kind of a general kind of good feeling that things are okay, but it's not a really strong line of evidence to look in terms of actual surface water exposures from industrial uses. And then the last comment that I'd like to add is there's a number of times we keep talking about the fact that these chemicals are highly volatile and they photodegrade and they dissipate very rapidly and therefore won't be around to cause problems. And I would agree that's true if you have a single release. But when we're looking at these areas around facilities that utilize or produce the product, we're talking about more continuous releases. And indeed, when EPA is asking questions about, general population that are around the facilities, they're assuming continuous release. And if you take measurements over time, you can see that there is measurable amounts, albeit very small, of 1,3-butadiene in the air. So I'd be very careful about using that as an argument for why it's not important to consider the exposure of the environment. Again, we need to, kind of keep consistency amongst the document, but also with the reality that these are continuous releases and not individual releases. So I think I'll stop there and let others chime in.
Excellent points, Dr. Fairbrother. And I'll just mention that on the surface water data, it may be even worse than you think, because if you go into the data sets and you go into the hydrologic units and say, okay, there's a water sample in this hydrologic unit where the facility is, it might be upstream. And actually, most likely it is upstream. And so that is something we've run into on multiple occasions with this committee. So much more diligence in selecting the data out of that data set is always needed. And
it kind of brings up, you might want to think about the MPDS data set instead if you're looking at discharges, which is why I asked the question earlier today about the Shell facility.
Exactly. Okay, Dr. Johnson.
Yeah, just one quick comment. Just a clarification Dr. Rubin brought up about some of the chemical physical properties that were provided in the document as potential rationales for discounting some pathways. The EPA does this. They do provide some of the clarifications on these physical chemical criteria, whether they're calculated, whether they're estimated based on models, or they're actually experimental. But it makes a difference, right, to know where those values came from, because some are more reliable than others, right? And so I would encourage, this is more of a clarification comment, that the EPA actually produce a table with these chemical physical properties, and also if they're estimated, calculated, or modeled, and the source of that. And they could also do that with acrolein, formaldehyde, and acetaldehyde, because I think a logical argument can be made to potentially discount those in some of these pathways of exposure based on a semi-quantitative mass balance, right? I mean, for every mole of butadiene, you're gonna get half a mole of the other two. And that's a gross simplification, but you know what I mean. So I just wanted to add that clarification. That's all I have. Thanks.
Thank you, Dr. Johnson. Are there comments from any of the other committee members? Dr. Fenner-Chris.
Most of our attention's been focused on the Texas and Louisiana coast, because that's where the big guys are. But if you want to to address Dr. Fairbrother's concern about the water sampling not being representative of, it's not quite known where they were all taken, but scattered more over the country than that. Well, there are hundreds of plastic manufacturing facilities across the whole United States. They're not just concentrated down on the coast. And so some of the samplings that are in Storette and other places may actually be in vicinities of manufacturing facilities that may have 1,3-butadiene as an emission. So if I can find it, I have a slide that has a map of the existing plastics manufacturing facilities in the country now, and if I can dig it up and borrow it from somebody, I'll share it with everybody. I'll try to get it tonight.
Excellent. Thank you for that comment. And some of those facilities could also be on smaller reaches of rivers or streams than some of these big manufacturing facilities.
Well, when you see the map, you'll see, yes.
Okay, Ms. Jenkins.
Yes, I also had a minor comment. I think just adding on to Dr. Fairbrother's comment, when I looked at just the groundwater data, it appeared that most of it comes from the state of Arizona, which I think is mentioned in the report, but it is measured using EPA method 8260B, which I think it does not look for 1,3-butadiene. I think it's probably really measuring hexachlorobutadiene. We're not measuring it because it wasn't detected. But then there were other couple of samples that were iffy in the groundwater data set. So I think just some short discussion or caveat in there about these groundwater samples from the WQP database would be helpful. Just adding on to that. Thank you.
Thank you. Dr. Santos.
Yeah, thank you very much. I learned a lot from this comment. I'm curious about the comment on the fat deposition. It's an interesting observation, and I wonder how strong the evidence is on that path. And there is a first step in depositing into the fat of a mammal, and then the possibility of bioconcentration if another mammal eats that mammal. I don't think there is any data on absorption of butadiene through the intestine. So I wonder, whoever submitted that observation, how much we know about that.
Any comments from the discussants?
This is Ann Fairbrother. There's two things to keep in mind. First of all, I am just relying on the information that was provided by EPA in the document about the distribution into fat tissue. And so we might need to drill down into that reference that they used for that. I also, as I think I mentioned, that we really don't have any information about oral toxicity of this chemical, so that would be difficult. But again, I think we need to keep in mind the difference in terms between bioconcentration and biomagnification. Mm-hmm. So I don't believe that this chemical would biomagnify in the food chain, so you're not going to get particular problems of higher order predators, for example, from this. But if you do have some accumulation in tissue, a predator that eats a mouse, for example, might get some exposure that way. But exactly what the pharmacokinetics of ingesting from the tissue would be, it's an unknown. I think it needs to be mentioned, though, as something that's a possibility, but creates just another uncertainty in that part of the risk assessment.
Okay, thank you.
Dr. Johnson.
Yes, just one other really quick point. I'd be careful about using fat solubility as the only criteria to determine bioaccumulation, right? There's some chemicals that aren't very fat soluble that accumulate fairly well, like some PFAS. It really has to do more about the physiological differences within animals, right? And sometimes the kidneys will recirculate things, sometimes they won't. So be careful. That's all I suggest, and note that as an uncertainty.
Yeah, I agree. Any other comments from the committee? Okay, seeing no comments from the committee, I'm going to suggest that we take a break. I'm not sure if it should be 10 or 15 minutes and come back and start with a part 2 of this charge question. Ms. Munir, do you have a suggestion for us of a 10 or a 15-minute break?
For those of us on the West Coast, it's now lunchtime, so a 15-minute break would be appreciated.
Well, let us do a 15-minute break.
Agreed. All right. Okay. That sounds good. Please put up the timer for the 15-minute break. Thank you.
Thanks, everybody. We'll come back and get with the next charge question.
George, I just wrote an email to the person I want to get the slide from, so hopefully I'll get it today.
Okay, thank you.
I'm
All right,
actually,
well, yeah, welcome back, everyone. I can't see the clock. I think it ran down. We're back from our break, the EPA Science Advisory Committee on Chemicals. I think I should take the roll, if I can find it, just to make sure we've got quorum. So, Dr. Apti?
Here.
And Dr. Chasen?
Here.
Is Dr. Ike back? No. Dr. Fox?
Here.
Dr. Gentry?
Here.
Dr. Heiger Bernays?
Here.
Dr. Jenkins? Ms. Jenkins, are you there? Not there. Dr. Merced Nieves?
Here.
Thank you. Dr. Rubin? Dr. Semmel?
I'm here.
Mr. Wright? I see you, Mike. Are you there?
Yeah, I am. Can you hear me?
Yeah, I can hear you now.
There we go. Okay.
Dr. Santos Bourgeois?
Here I am.
Great. Dr. Roby?
Yes, I'm here.
Dr. Johnson?
I'm here. Sorry about that.
No worries. Dr. McKenzie?
Here.
Dr. Fairbrother?
Yes, thank you for the lunch break. It's appreciated.
Well, tiny lunch break. Dr. Eastman?
I'm here. Thank you for the lunch break.
Dr. Hopkins?
I'm here.
Okay. Dr. Bean Freeman, are you here?
Yep, I'm here. Thank you.
Great. And then Dr. Fenner Crisp, I heard just a second ago. Dr. Mayer?
Yes, I'm here.
All right. And then Ms. Jenkins? Okay.
We see Dr. Rubin.
Okay.
She's here.
That was the next name
Oh,
call.
I'm sorry I interrupted you like that. Sorry.
Do not worry one bit.
Okay.
We're all trying to do the best we can here. And half of my screen's covered up while I'm calling the roll, so I can't see very well. Okay, so a couple of things to try to get through real quick. And if we could get a poll of hands raised from the committee, if we need to go overtime half an hour or so today, is that going to be acceptable? And a raised hand is acceptable and a non-raised hand is not acceptable. So just let me know.
if it's only half an hour, my class starts at 7.
So we'll be done by 5:30 Eastern.
That's fine.
It would be 6 Eastern.
Okay.
Yes, so today's agenda, the end time said 5:30. We're wondering if we can extend it by a half hour, ending it by 6 p.m. today, Eastern time.
It looks like we probably have quorum there, Allie.
Okay, yeah, all right, good.
Okay, so let's continue on. And I'm imagining we will get only through question 1 today. Is that right? Yeah, question 1 and 2. We will get maybe through all of question 2 today. We will see. So let's Dr. Rubin has a question. Or is that a remaining
Sorry,
hand
I
raised?
just didn't lower my hand yet.
Okay. So let's move to this second part of the first charge question. And if we can get that read into the record by the agency, that will be great.
Well, before we start, it looks like Dr. Fairbrother, she had her hand up. Oh, she has it down now. Dr. Fairbrother, did you have a question?
No, I just wanted to respond to something that Dr. Johnson had brought up, and he was wondering about where all of the different chemical properties for 1,3-butadiene came from. And Mark, it is in the chemical fate and transport document. If you look on page 8, there's a table that puts all that information out there and tells you what your reliability is of the different aspects of it. So I don't know if that might help in their thinking as we move on this conversation.
Oh, that's great. Thank you so much. I must have missed that one.
Thanks.
And could I clarify really quickly, Dr. Fairbrother, that doesn't include the degradation products, though, is that correct?
That's correct. Yeah.
All right. So now if we can get the second part read into the record, that would be great.
Okay. This is Addie Adebule with the EPA, and I'll be reading charge question 182. Please comment on EPA's conclusion to develop a qualitative assessment for water, including surface water, sediments, drinking water, exposure for both human and environmental risk, as documented in section 6.1 of the draft risk evaluation for 1,3-butadiene.
Thank you. So our lead discussant for this particular question is Dr. Johnson. So the floor is yours.
Thank you, sir. I think this question is specific to water exposures. And basically, I'm just going to, this question before, a lot of that was already spoke to, so I won't repeat that. But generally, based on the comments I've received, that we agree that the EPA has done a fairly good job of describing that water exposures should not be, should be addressed qualitatively, I guess, since the chemical physical properties suggest that it should not be in water very long, and that all environmental data have never detected 1,3-butadiene in the water. However, we still believe that there is a possibility for the environmental breakdown products to be, and that should be evaluated. There was also some language regarding no risk, and that was a conclusion. And we just want to note that risk by definition is a probability for an adverse event to occur. Therefore, there's always some risk. The question is whether risk is acceptable or unacceptable. And that's basically all I have, unless there's anybody else who would like to add more to it, in addition to what was already said for the first question. So let me just stop there. Thank you.
Thank you, Dr. Johnson. And thanks to the whole group for getting comments around the eco part summarized. So Dr. Fairbrother, any additional comments?
No, I think it all kind of got amalgamated together in one comment, really. It was hard to separate out parts 1 and 2, so they sort of all came together.
Yeah, understood. Let's see, Dr. Fox.
An undetermined absence today.
Nothing to add.
First period. To excuse this absence, press 1. Please select a reason for your student's absence.
Somebody's got an absent student. I'm not sure who, but not me. Thanks for confirming no comments. Are there comments from any others on the committee? This is George. Well, did I see Dr. Fenner-Crisp have her hand up?
I do.
Yes, please proceed.
On the comment that Dr. Johnson just made about saying no risk, unreasonable, yes or no to unreasonable risk is a term of art used in this program. So we might suggest they put unreasonable in that sentence.
That makes total sense to me. And I think that's what probably Dr. Johnson was getting to.
Yeah.
Mark, your hand's up again. You're muted. Mark, you're muted.
Oh, sorry about that. If it's okay, could I please comment on the previous question quickly? Something I didn't provide for Dr. Rubin is that I agree with all the comments that she read, and that risk to birds could still be an issue. We know there's some sensitive habitats, particularly around the Gulf Coast, where some high environmental concentrations of 1,3-butadiene have been modeled, or I guess environmentally measured. And so even though we know there's no inhalation tox data for 1,3-butadiene for birds, I couldn't find any. And that's not uncommon because it's very hard to find inhalation studies done in birds. That there are some other data that the EPA could use to infer on unacceptable risk for birds in those areas where high environmental concentrations have been detected. You could use breeding bird survey data in areas where concentrations have been high, and you can look at it compared to reference areas. Usually birds have a high degree of site fidelity. If they're not successful breeding, they don't return. And so that relative abundance information might be useful to shake a stick at this question of unacceptable risk. You could also use Audubon Christmas count data, which is just presence, absence, relative abundance data that could be used as well. So I just want to throw those two out there, and I'll put those references in my comments back to Dr. Rubin. Thank you.
Yeah, thank you for those comments. I was going to actually add that something similar about the bird counts and even threatened and endangered species perhaps being considered in this type of assessment. My overarching comment about this whole process is that in conservation of EPA's resources, if the decision is made that the true risk is to the human population, and that risk is going to supersede all of the other risks, there could be a case made to forego the ecological side because the human health is such a significant potential risk. The only problem with that is if you do that and you find that there is acceptable risk in the human population, you have to go back and do the ecological assessment if you haven't at least given it some consideration at this point. And that's kind of my point, is you can't really not do the ecological unless you're just going to de facto say, we're seeing so much human health risk here, it's just not worth our effort because it's going to accomplish basically the same thing. So, and that almost violates all the principles of risk assessment, but in a practical sense, that's about the only way you can proceed not doing an ecological assessment. Dr. Fairbrother.
Yeah, I think that that's a reasonable argument, and particularly because the human health risk is going to be primarily driven by the cancer risk. And we don't consider that when we're looking at ecological receptors. So we know that the hazard threshold is going to be much, much lower for the humans than it is for the eco risk. And the only thing that might create some unwanted uncertainty, though, is the interspecies differences in terms of reaction to the chemical.
Exactly. Dr. Johnson.
Yeah, I agree with that. Also, you may want to do a double check on breeding rates as well. I mean, if we're using the same laboratory rodent data, right, for human health as we are for small mammals as an ecological risk assessment, it's probably it's too close to, we should consider those to be equivalent. And so I know there's a adjustment that's made for human health. I just don't know how that comes out mathematically, but it may be something you want to check.
Yeah, and I was also thinking that the rodent data are already available, basically, the inhalational tox part. So, okay, Dr. Chasen.
Thank you. You know, the presentation of not doing a formal assessment, I'm sure can be, it might be rational at certain points. However, when that course is taken, I think it would be very helpful to also make statements about what information that they have that is very reliable and what kinds of information in terms of confirmation things along the line Dr. Johnson mentioned that is not in the record, or where there are data that could, let's just say, people could take pause when they're looking at it. So I think they need to be very, very transparent when, no matter what the situation, when someone does not do an assessment.
Thank you. Other comments from the committee? All right, so I think we finished question 1, and now we can move into charge question 2. And if the EPA representative can read that into the record for us.
Excuse me, I have one more comment. Can I make one more comment?
Oh, yes, I'm sorry. I thought that was a thumbs up.
I just pushed the wrong button. So there's one other point. We're going to bring this up again later on, but it's relevant here too. There's the words assessment and a review and words like this are used very loosely throughout all these documents. And in my mind, those words do not mean the same thing. So if there's a statistical assessment or some kind of review with very strict order to it, I think people could call that an assessment. But I think it'd be very prudent to go through these documents, remove the word assessment, and choose other kinds of words like they considered or they review, say what they really did. But the idea of just no matter what you do, you can call it an assessment, I think is causing problems. Thank you.
Yes, I agree. And we've run into that with the terminology of risk assessment, risk determination, all of those as well. So I agree with you 100%. All right. So now if we can move to charge question 2 and have that read into the record by the EPA representative.
Hi, good afternoon, everyone. This is Kit Lee with EPA. Charge question number 2. General population exposure to 1,3-butadiene by inhalation of 1,3-butadiene in ambient air was modeled using a tiered approach as described in the draft general population exposures for 1,3-butadiene. The concentrations of 1,3-butadiene in ambient air from facilities that use, manufacture, or process 1,3-butadiene under industrial and/or commercial conditions of uses subject to TSCA were modeled with releases reported to the Toxic Release Inventory for the years 2016 to 2021 as the input. Screening level modeling of ambient air concentrations was completed using the Integrated Indoor-Outdoor Air Calculator. Modeled results from the IIOAC supported the need for refined modeling of ambient air concentrations to evaluate cancer risk. The human exposure model was used to model geographically refined ambient air concentrations, accounting for localized meteorological and site-specific parameters when available. The human exposure model allows for estimations of ambient air concentrations at discrete distance rings and at census block centroids surrounding each releasing facility. EPA acknowledges that the National Emissions Inventory, or NEI, 2017 and 2020 data may provide refinement to exposure estimates and is evaluating this data for inclusion in the final risk evaluation. Charge question 2I. Please comment on EPA's approach and methodology with IIOAC modeling of ambient air concentrations to inform the non-cancer risk evaluation as described in section 2.22 of the draft general population exposures for 1,3-butadiene.
All right, thank you. And now we'll get our comments from our discussants. And our lead discussant, perhaps for the rest of the day, is Ms. Jenkins with several associates, but we'll start with Ms. Jenkins.
Thank you. I apologize because I have not practiced this, so I hope I can read this well enough, and I encourage the other co-discussants to weigh in after I read through this. First, as one of the other public commenters stated, I think it would be helpful to have a discussion by EPA at the front end of these meetings to discuss the regulatory programs, both state and federal, that apply to these chemicals and facilities that produce them. As a state regulator, I've mentioned the comprehensive air monitoring network and data and evaluation of that air data that has been in place for decades in Texas. The state of Texas monitors 1,3-butadiene, both as it is an air toxic and its role in ozone production. All of these data are publicly available. Some of these facilities are also regulated by National Emission Standards for Hazardous Air Pollutants, or NESHAPs. States may also have NPDES information, groundwater data from remediation sites, etc. It seems like many of these programs are in silos, and so some overarching way to gather the data and talk with local regulators for the TSCA program would be beneficial. I think most or all of the committee members supported the use of the IOAC modeling to inform the non-cancer risk assessment. It was based on TRI data, and although there are known potential issues with TRI data, that data combined with IOAC modeling produces results that are conservative, although that can be described as unrealistic in some cases in the real world scenario. EPA used releases of 1,3-butadiene reported to the TRI to estimate 1,3-butadiene concentrations in ambient air through application of their IOAC model. These estimates were then applied in the evaluation of non-cancer risks. The strength of the IOAC model is its ability to identify where chemicals are released and include both stack and fugitive emissions. However, the model as applied has several limitations, including the inability to consider aggregate emissions from clustered facilities and other sources of 1,3-butadiene, doesn't identify potentially exposed or susceptible populations or pests, and assess risk for pests, and does not consider co-chemical exposures. It has 3 caveats for the purpose of the exposure assessment. The first is that the modeling is based on pre-run scenarios within AirMod, so default input parameters for IOAC are limited to those input parameters utilized for those pre-run AirMod scenarios and cannot be changed, including things like stack height, land use, buildings, etc. Similarly, the random variations on atmospheric conditions are not clearly considered. Section 3.1 of the population exposure document discusses its limitations. It also seems as if multiple facilities are not aggregated, this could be a concern given that if one facility exposure is not considered important, it might be screened out, but its exposure jointly with the second facility might be important for the population in surrounding those facilities. The second is that the modeling assumes that the dispersion is a direct estimate of the person's exposure within a scenario of 100 and 1,000 meters. We should consider that the person's variability is not considered in the model. This is more of a concern when near surface concentrations modeling is not the main capacity of AirMod used within IOAC. Additionally, all the data is daily and yearly average using the 6 years of TRI data. The averaging eliminates excursions from the average, including potential peaks. This might be good for a first approach estimate. The reviewer agrees that the assumptions of continuous emissions and meteorology are conservative, and being conservative could be beneficial for this screening approach. It is using fence line, community, and outer boundary ring estimations with the 100 to 1,000 meter range, more detailed with a Cartesian grid. Differential distribution beyond the 1,000 meters is not considered. There's also a developing update of IOAC, and the commenter wonders or asks if that will address some of its limitations. Because of the limitations, the IOAC model underestimated risk to pests, did not provide an assessment of non-cancer risk based on the available practices as required by TSCA, amended in the Lautenberg Act. Therefore, one of the reviewers does not agree that it's an appropriate tool for assessing general population risks associated with 1,3-butadiene exposure. As for the cancer evaluation, refined modeling is necessary. Refined modeling of the ambient air concentrations is necessary to inform the non-cancer risk evaluation. Specifically, under TSCA, EPA is required to evaluate risks posed by aggregate exposures. Aggregate exposure means the combined exposures and individual experiences for multiple sources and conditions of use. The general population experiences 1,3-butadiene exposure as a total of contributions from all sources. Exclusion of non-industrial sources, such as vehicle emissions, led underestimation of actual 1,3-butadiene exposures and health risks and pests, as well as the general population. The model did not account for aggregated exposure of 1,3-butadiene emissions from multiple facilities in the same general geographic area. Public comments from the Beaver County Marcellus Awareness Community Center for Environmental Health and Earth Justice provides a real-world example of a geographically cluster of facilities reporting butadiene emissions on page 8 to 9 of their comments. And this is an area in Baytown, Texas, where several separate facilities report 1,3-butadiene emissions to the TRI, and they are located within about a mile of each other in a large industrial complex. The nearest homes are less than 0.3 miles from the complex fence line. This community exemplifies a pest because 1,3-butadiene emissions from all the facilities within the complex are not aggregated. The exposures to the fence line community are underestimated. A recommendation would be to update the general population risk assessment to include aggregated 1,3-butadiene exposures from geographically clustered facilities and other 1,3-butadiene exposures. See Part 5 of the September 2024 draft proposed approach for consideration of chemical co-exposure in TSCA risk evaluations. And in addition, it's recommended to work with states and other monitoring network sponsors to ensure the monitoring data and monitor locations are correctly reflected in this document. Under Section 6B of the Lautenberg Act, EPA OPPT is required to perform risk evaluations to determine whether a given chemical presents unreasonable risk to potentially exposed or susceptible populations or pests. Examples of pests include children, elders, pregnant people, workers, and tribal communities, as well as overburdened communities. Overburdened communities may experience disproportionate risks from chemical exposure due to their greater exposure or susceptibility to environmental and health harms. Full consideration of chemical exposure and risks to pests must include an evaluation where chemicals are released, who's exposed, to what media, pathway, and route of exposures do releases occur, release frequency and magnitude, and the degree to which releases of chemicals may co-occur. The IOAC modeling approach did not identify who's exposed, in other words, pests, the frequency and magnitude of releases, or the degree which releases of chemicals may co-occur. Thus, relevant pests such as overburdened communities, unborn children, etc., living in the fence line communities were not identified. A recommendation would be to update the general population risk assessment to include an analysis to identify overburdened communities and other pests. Workers as pests were not considered. Workers that live in fence line communities are pests because they experience potential for workplace and residential exposure. A recommendation would be to update the general population risk assessment to conduct non-cancer risk evaluations for the worker pests. Under TSCA, EPA is required to use the best available science and assess risks to pests, which include overburdened fence line communities, as well as workers that might be exposed to multiple chemicals. Pests exposed to 1,3-butadiene are also exposed to formaldehyde and acrolein, which are the main transformation products resulting from reaction of 1,3-butadiene with atmospheric hydroxyl molecules. Both of these transformation products are hazardous air pollutants and with no non-cancer health effects. Facilities emitting 1,3-butadiene may also emit formaldehyde. The health risks from co-exposure to formaldehyde and 1,3-butadiene is a particular concern because they share several non-cancer effects, including respiratory, reproductive, and developmental effects. A recommendation would be to update the general population non-cancer risk assessment to add an evaluation of cumulative risks from exposures to chemicals. While the rural selection as the default in the IOAC model may be conservative for fugitive emissions, it may have underestimated ambient air concentrations from stacks. In other words, point sources. The magnitude of this effect of the urban setting is dependent on the selected meteorology station and the distance between the source and the receptor. A recommendation would be is to acknowledge underestimation for urban areas. Some specific comments. The facility sources are based on TRI information, which can sometimes be uncertain. Facility location should be reviewed or some statement made in the document to state that they were reviewed to ensure that they are correct. The default input parameters like stack height of 10 meters may not reflect actual facility parameters, and flaring is not considered in TRI in all cases. This should be discussed. From the user's guide for the integrated indoor-outdoor air calculator, it appears that the meteorological data are from 2011 to 2015 and don't match with the TRI data used from 2016 to 2021. The time frame of meteorological data should be discussed in this section. A consideration on air mod that might be discussed, why it is not used if the inputs are part of IOAC. The IOAC model estimates ambient air concentrations at predefined distances beginning with 100 meters from the facility. There can be instances where residents are located at the fence line or nearer than 100 meters. This type of uncertainty would cause an underestimation of risk and contradict statements in the text about the conservative nature of the evaluation. A recommendation would be to add a table that identifies data used in the exposure assessment and analysis with an indication in the table of the data, an indication of if the data would likely overestimate or underestimate the result. Such a table will help to understand the degree of uncertainty. Quantitative justification for use of the 2016 to 2021 TRI year interval should be provided. This interval is a concern because it includes COVID years where facilities may have operated differently. In other words, upsets under or over normal. Also, the recent annual trends of 1,3-butadiene should be evaluated before using a select number of years. For example, in the case of one ambient air monitor within 743 meters of TPC in Houston, Texas, there's a statistically significant increasing 1,3-butadiene concentration trend between 2016 and 2024. This one location was evaluated and found it a concern. EPA should assess recent trends at the facilities to ensure that the model input can be expected to be stable going forward. Both the use of COVID years when operations may have been lower and the assumption that the input years are reflective of future concentrations could underestimate the risk. This type of uncertainty would cause an underestimation of risk and contradict statements in the text about the conservative nature of the evaluation. And that's it for that part of the charge question 2.
Great, thank you. So are there Other additions from the associates, Dr. Hopkins?
I think that Dr. Jenkins captured everything. I think that going forward, there has been a lot of discussion about the uncertainty associated with the input with TRI and the upset emissions, and I think that that's something that we might want to consider adding just from the comments today.
Yes, thank you. Dr. McKenzie?
Yes, I think Ms. Jenkins really did a nice job of summarizing all these comments. Thank you. I would also like to add, kind of at the conclusion of the general population exposure assessment, EPA refers to, they feel that this is a robust assessment, and it's my feeling or my thoughts for the non-cancer risk. I wouldn't make that conclusion. I don't think it's a robust assessment, given that the model they used didn't include the aggregate exposures, co-exposures, or address pests.
Yeah, thank you for that comment. I certainly agree. I can't speak for others. Dr. Santos Bourgois.
No, I have nothing to add. Dr. Jenkins really did a splendid exercise of integrating everything. Thank you very much.
All right. So are there comments from other committee members on this charge question? So Dr. Fairbrother.
Yeah, this is a comment that maybe is a little more general, but Dr. Jenkins brought it up, so it made me think about it, which is EPA selects data from certain years for certain uses, some of which include the COVID years and some of which don't. But it seems to differ depending upon what the data set is that they're aggregating and going to use it for. And just a general suggestion is an explanation of why did they select those particular years. Like, did they want a 5-year run of data and the latest data available were in 2022? Or did they need a 10-year run? Or, you need to justify why only 5 years? Why not 10 years? Why not all the data? So just kind of in general, I think that is certainly going to affect the outcome of these kinds of modeling.
Yes, that's a good question. And maybe EPA has an answer for us at some point today. Dr. Merced Nieves.
Hi, I just wanted to add to Dr. McKenzie and Dr. Cobb's comment. I agree that it's not a robust assessment if we don't include the cumulative risk or the pest community. So I just wanted to voice that I would like to review that part and when we're writing and include myself as one of the people that agrees that that shouldn't be an assessment made as a robust assessment if we're not including these things.
Thank you. Dr. Apte.
Yeah, hi, this is Uday Apte. Is this the place where I could comment on PSS more in depth, or that belongs to a different charge question?
On what?
On PES.
I think we're going to have to discuss it sometime. We may as well discuss it.
Okay. I'll just say what I want to say, and then we'll see whether it fits here or not. I think I did raise this earlier. Because the metabolism of 1,3-butadiene is quite heavily dependent on CYP2A1, and that step of metabolizing it to the epoxide actually plays a heavy role in its mechanistic its mode of action. I think it's important for EPA to consider potential susceptible populations from the standpoint of CYP2A1 induction. This goes towards the idea that 40% of the U.S. population is now obese or overweight, and added to that, there is alcohol use disorder, and then there is an overlap of obesity and alcohol use disorder, now recognized as MET-ALD, metabolic ALD, alcoholic liver disease. And these people have a substantially higher hepatic CYP2E1 as well as other places, CYP2E1 expression and activity, and they will have significantly more ability to metabolize 1,3-butadiene. And given the preponderance of this and the number of people that there are, there should be some sort of consideration for these metabolic differences that might happen in these exposures. This also goes to fence line communities. We've talked about fence line communities in the past quite a bit, and most times, or more times than often, these communities are they have a heavier burden of obesity and other problems just because of the socioeconomics that is involved, food deserts and all. They might have significantly higher population than normal of people with higher CYP2E1 activity. And so they might be having a higher burden of metabolites. And so that, of course, is not, I don't know if it's measured anywhere, but that is something that needs to be considered, I think, in this analysis. Thank you.
Yes, thank you. And some of that may be best in the human health hazard, but there should be a reference to that in this section for sure. Okay, other comments from the committee? So I actually have a couple, and I think some of it has been captured somewhat, but I think it specifically should go here and possibly in the human health hazard. We can ferret that out as we're writing, but the lack of consideration of formaldehyde and acrolein are significant shortcomings in this assessment. These are toxic transformation products. Under any other circumstance, toxic transformation products would be assessed. And it just dawned on me as Ms. Jenkins was making her presentation that TCEQ here in Texas has information about butadiene being a precursor to ozone, which is also a toxic. So there's ample evidence that there are toxic transformation products that are not being considered. And to the last public commenters information, the formaldehyde assessment that EPA did previously did not include sources from which formaldehyde was a toxic transformation product. So we have differing places where there's a hole in the assessments that EPA is doing. And I think that needs to be part of the dialogue. And Ms. Jenkins, I'm sorry I did not get you that information ahead of time. I have other comments, but I see additional people, so I'm going to yield the floor to Dr. Santos-Burgoa.
Thank you, George, for bringing this up. And maybe this is the time to ask. I have to confess, I am very confused. I am very confused about the scope of the risk assessment and what should we consider. Reading through the document, reading through all that, and from what was mentioned at the very beginning, it was told to us that we have to do a risk assessment under strict TSCA authority. It has been explained later that TSCA does mandate to use to consider aggregate exposures. So are we going to have this in the scope of our evaluation, aggregate exposures? And then are we going to consider cumulative exposures either to other chemicals or to, now we're discussing transformation products. If we want to do state-of-the-art assessment, risk assessment, yes, we should consider aggregate and cumulative exposures. But I don't know that is not the spirit of the risk assessment that we have in our hands, and I think that we need to make either a decision or a recommendation about this, how we want to move forward. I believe that a lot of our comments would change if we have clarity on this exact point.
So your comment is well taken, and I think it's up to us to determine what our recommendation is to the EPA. They have chosen not to look at transformation products, and it's up to us to decide how we recommend that they proceed.
Okay, so we should, I propose that we should discuss this as a specific point for our committee and make a recommendation. I think this is important because this will be state of the art.
Yes. And some of that might get more into the human health hazard assessment, but we can look through that, but it definitely touches on this point as well. Dr. Chason.
Thank you. I will just speak briefly to the issue about the aggregate exposure. There are several committee members that have not been present in past years for my constant conversation about this, as well as the past. And I don't want to. Well, I'm encouraged that other people are taking up the call. Let me put it that way, because in fact, none of the risk assessments from the past couple of years have shown aggregate assessment. It appears to me that the scientists do not have in their hands a model that is capable and has all of the attributes for aggregate exposure and aggregate risk assessment that has been laid out in great detail in many very formal meetings by the Science Advisory Panel and others over the past 20 years. The models don't exist, so unfortunately these scientists just don't have the tool. Now, that doesn't, we can't forgive EPA for not having those kinds of tools in the hands of the scientists that need to make these assessments. But clearly, there's no way to have a coherent, you can't just add all these exposures up. You need to, and by the way, they're also not using any probabilistic models, which is clearly not state of the art. Now, having said that, I really I want to remind our panel members that that's not, quote, the fault of the people who have to write these documents, but it is certainly an egregious omission by EPA, in my point of view, to not have really competent models in the hands of the people who have to make these very important decisions for our country. So I agree with Dr. Apte, this can't go unmentioned. I also wanted to make a point about our vision of where these fence line communities are. Over the past 15 years or so, we've done a lot of work in very densely populated urban areas such as Brooklyn. And within the fence line community, in that case, is the building next door or across the street, because there are small industries which use a variety of heat processing tools to form plastics into everything from replacements in car parts to plastic bags and things like that. And they're just regular buildings there. And so that's one of the reasons why I keep asking the questions about the possibility of release from the polymers over time or under heated conditions, such as Dr. Meyer pointed out, because that fence line community is walking down the street in front of the building. So these are important questions, and I do think that the vision, if you will, around some of this, it's our responsibility to keep pointing that out with hopes that EPA will give these scientists the tools that they need. Thank you.
Yes, thank you for that comment. And I'll point out that, we've done a lot of work on this committee with phthalates. And phthalates are plasticizers that are in plastics, not just like butadiene, but in a similar fashion. And there's lots of discussion of off-gassing and how these chemicals leave the polymer and get into the consumer or into the environment. So, and that's a much less volatile compound than butadiene. So take that into consideration as well. I think the agency should do that. Dr. Fairbrother.
Yeah, listening to the conversation, I have two comments. The first one is that we keep bringing up things like, should we look at aggregate exposures? What about different types of populations? What about breakdown products? What about? And I think part of the problem with the risk assessment is there's not a problem formulation. So EPA didn't lay out really the risk questions that they're addressing very clearly to say, and any kind of constraints around that they may be constrained by what TSCA has them doing or not doing, or what should be in, what should be out. So EPA could obviate a lot of this kind of conversation by doing a good problem formulation at the beginning of the risk assessment. And then the other point that was brought up, which was one that I was going to ask the modelers, is that we seem to just be doing some deterministic modeling of these air models, which probably is okay for the screening model. But when we get to the conversation about the HEM model, it seems that we should be talking about more probabilistic type distribution approaches to inputs and outputs of that model. So just kind of putting that out as a reminder to bring that up at the next question discussion.
Good points. Thank you. Dr. Fenner-Christ.
Yeah, I want to comment on both Dr. Chasen's and Fairbrother's comments. There's long been decades-long tension about what the assessments that the TSCA program does will include. And if you recall, in some of the early generations of risk evaluations, it was said very bluntly that we aren't going to consider any other exposures that we can't regulate under TSCA. That if it's a drinking water problem, it's the Office of Waters issue to deal with. If it's a groundwater problem, it's the Office of Waters to deal with. If it's an air program issue, it's the air program's regulatory responsibility. If it's a consumer product, it goes over to CPSC. If we don't regulate it, we don't consider it. And so that tension has existed for a very long time until fairly recently, when aggregate has come up. And of course, except for phthalates, you've mentioned, there's a cumulative risk assessment that the program is doing for the 6, because one doesn't qualify, for 6 of the 7 phthalates. So that's quite outside their usual scope of work. So I think this aggregate conversation will go on a long time, and yes, we may have something to say about it, but we'll see what the policy is now within the program about considering and taking into account aggregate.
Right. Thank you. Dr. Eastman.
Yeah, I just thought I'd weigh in. When you get into the aggregate and the cumulative, exposure, co-exposures to other chemicals that cause leukemia. This actually gets to be, I think, really complicated. So the formaldehyde is pretty clear cut because it's a photolysis product from 1,3-butadiene. It's also exposure to formaldehyde. You have butadiene, you have benzene potentially in these environments as well. Maybe ethylene oxide. And then you can get into situations at high elevation, you have higher exposure to radiation, ionizing radiation, which is these are all leukemia inducing agents. So it seems like at some point there's going to have to be a cutoff to say we're limiting this at some point. And whether you say, well, we'll limit butadiene and formaldehyde or butadiene, formaldehyde, and acrolein, I'm not sure. But as I think about this, can get very complicated. The same thing can happen with CYP2E1 induction. So you have the obesity issues, you have diabetes issues, you have alcohol consumption, because CYP2E1 is induced by ethanol, and probably other things. So there's a lot of complexity when you start to get into the specific metabolic pathways and co-exposures related to these diseases. I just thought I'd mention it.
Thank you. Dr. McKenzie.
So it's my understanding, and from what our last public commenter talked about, the TSCA regulations, as currently amended, EPA is to look at aggregate exposures from all sources, and specifically be considering different pest communities. And there was a wide array of pest communities to consider. So I do think that should be in our charge. And I believe they've also specifically mentioned co-exposures as well in the amendments to TSCA.
Thank you for that comment. So are there other comments from the committee? Dr. Heiger-Bernays.
Yeah, so I'm wondering if this is a place, not to push it down the road, but is this a place where these kinds of questions get raised with regard to that sort of question 6, right? Because every time we go one way, we end up, adding more and more and more. And as I think it was Dr. Fairbrother who raised, there isn't a clear map. There isn't a sort of, these are the boundaries. These are where we are going. This is where we're not going. And maybe clarification, we can certainly recommend, but a recommendation could be for clarity,
Yes.
here's what needs to happen.
You're exactly right. You're exactly right. And that's where a lot of the clarity comments will fall back to you and I forget who the other discussant was, Dr.
Mary
Fox.
Fox.
Yeah.
Yeah.
Okay. Other comments from the committee. So I actually have one that I think it fits best here. It's possible it would be later in the exposure scenario, but I want to talk a little bit about some exposure dynamics that I think the committee needs to consider and the EPA needs to consider. And that's the 1,3-butadiene concentration maps and how they're developed and the downwind distances that are being considered in the assessments. So back when we were doing the, pardon me, my phone is ringing. I thought I muted that. Part of the things that we reviewed for the air quality assessments in the past were topics where we had, I think it was 10 kilometers of downwind measurement. And that was what we were recommending that the agency work on, and that's what they were working on. And now it seems to have been truncated to 1,000 meters based largely on the fact that the EPA doesn't expect there to be long-term persistence of 1,3-butadiene. However, that is a photochemically induced reaction or hydroxyl radical or some photooxidant induced process. And what I want to show you here, I've got some graphics. These are unpublished data, I might say. And Ms. Jenkins, don't panic when you see these. These are, I think, TCEQ related projects that are coming out of our department. They've been submitted in reports, but they have not been published. And I'm going to see if I can share my screen now. Share this. Now, can you folks see a graphic?
No.
Not yet. No.
Oh, I didn't
Okay,
push
it's
enough
coming.
buttons.
It's coming.
Can you see
There it
this
is.
graphic?
Yes.
Yeah.
So there are some gaps in these data, but what I want to point to is, I hope you can see my cursor on these 3 data points. If you drop down, that's midnight. So this highest excursion of 1,3-butadiene at this site, the magnitude isn't necessarily the point. The point, because this may or may not be close to a site. The point is that at night is when we're seeing these high excursions here. Well, this is not at night. This is in the mid-afternoon, But we're seeing high excursions at night when these 1,3-butadiene, there's nothing around to oxidize it, and there's no light to induce the oxidation. Similarly, in a different time frame, if we look here, this is in the afternoon. This is in the afternoon, but look, it spans into the night, even into the midnight hours. Similarly, from 8 until midnight or 8 until 10 p.m. here, and from midnight till 8 a.m. here. The point being, these large discharges of 1,3-butadiene are occurring at night. They're not occurring during the daytime when the photochemistry would deplete them. So the transformation processes that EPA is considering as the depletion mechanism are not in place when these large events occur. And so that's really the point that we need to consider. I've made these documents available to Ms. Munir, and thank you for entertaining this topic. Ms. McKenzie.
So in addition to there not being the photooxidation at night, in places that are not on the coast in our valleys, like we have here in Denver, we've seen similar things with benzene when we have basically still conditions and no mixing at night, or very little mixing. So a calm atmosphere and inversions that trap things near the surface.
Yes, certainly. Dr. Fenner-Chris.
My question was, are those samplings that you track there near facilities?
They're in the greater Houston area. I got these hurriedly while we were in session today.
So you don't exactly
maybe Ms. Jenkins knows where the Lynchburg Ferry site is and the San Jacinto Battleground site. I'm pretty sure I know where the San Jacinto Battleground site is, and it's in the close to the complex.
Channel View area, upper.
Yeah, that'll be close to the petrochemical complexes.
Yeah. Well, I was going to suggest maybe you're seeing the peaks because that's flaring, which generally happens in the dark when people aren't aware.
Yes, or when they're in their homes for the entire time.
They're not paying attention to what's going on outside, so the flares are planned for that.
Dr. Johnson.
Yeah, thanks, Dr. Cobb. That was interesting. I wasn't able to catch how long those peaks last. What are they just generally on average?
Well, some of them are as long as 4 to 6 hours. Some of them are as short. I can reshare the screen perhaps. I don't want to belabor this too long. But if you look here, this peak is starting up here, and it's lasting, I can't tell how many hours that is. It's probably lasting, that's a 4-hour interval here. So it looks like it's lasting 3 hours here. And then this one looks to be lasting maybe 5. And these are lasting, it's hard to say on the down, well, 2 hours here, 2 to 3 hours here. So that's a time frame.
So, I mean, assuming that those concentrations are at the breathing level, we're looking at pulsed acute.
Correct.
Thanks.
And the point isn't necessarily the height of the peak, it's the timing and the assumptions of degradation occurring so rapidly. That's maybe not a good assumption.
I was going to say, just to add, all those data are publicly available on the TCEQ's website. So those look like they're auto GC data, which is not captured or not assessed, right? These are continuous monitors. So
yeah, and some of those are mobile labs with the PTRMS. Maybe not PTRMS, but one of the mass spectrometry techniques. You're correct. I see Dr. Lowett has appeared. Do you want to make a comment?
Yeah, I was actually wondering, because I was looking at the charge questions, and so, we've been conversing here in the room and are a little bit concerned that some of the comments that we're hearing on little Roman numeral I as separated from little Roman numeral II, because the HIM modeling in and of itself covers a lot of the aggregate issues and explicitly considers some of the pests and specifically some demographic groups. And so a lot of the critiques that we're hearing in little I are actually part of our HIM modeling, and that we see all the model results in totality, not piecing them apart. So some of the comments we're hopeful can be maybe measured a bit as we look at the HIM model, how we've run the HIM model, what the results show, and give us some input on how to improve that. I guess my other two little things are that I don't know if it was said in the presentations yesterday, I can't remember, but we're under court order to complete 1,3-butadiene final by the end of the calendar year. So as we're in April right now, let's say approximately June, we would get this report that really only leaves us 2 or 3 months to make any edits, do our response to comments, and do our internal work we have to do. It's 6 months in the regulatory space is almost nothing. It goes in the snap of a finger. So we would really encourage the panel to think maybe on 2 levels, like we've talked about in some other meetings, that we're under court order to complete this. And some of the things that some of the panel members are asking for can certainly just not plausibly be done in the time that we're talking. So we just want to recognize that and recognize to the panel that some of these ideas we've heard before and we'll hear again, that we are in good faith working on some of those, but they're not always implementable as fast as you like. So really good example of that is back in the fall, we presented to a consultation to the Science Advisory Board, a draft of an approach that we had put together last year on how to look at co-exposure using AirMod and a couple of other models put together. And so we are thinking in this space how to do things together. But as you've seen for both formaldehyde and the 1,3-butadiene, we're not at this moment putting them together from a risk point of view. And I certainly don't know how we would do that in the time frame we're under the court order for doing that. But we are making in good faith a lot of steps towards implementing the kinds of things that we've been hearing from all of you. I just wanted to make that point because I wasn't sure if all of you knew that we were under court order on this one. So I'll be quiet and you know, may come back at the end of the little Roman numeral 2 in case maybe some of these critiques haven't been maybe dampened a bit, if that's okay.
So, yeah, and I agree. We will try always to provide near-term recommendations, intermediate term, and long-term. And sometimes I fully understand that EPA can't implement some things for this assessment, but it may cascade into others in the future. And so I do think one thing about some of the questions that are being raised that will probably require EPA to limit the use of things like central tendencies because the other exposures are not considered. So you're going to need to continue to use very conservative estimates and very protective estimates of exposures. But that's my perspective, and there's others on the committee that are going to have to speak to that when we get to human health. All right. I think perhaps we're ready to move to the next charge question. And that again is, if we can get that into the record.
This is Kit Lee with EPA. I'll be reading charge question 2A. II. Please comment on EPA's approach and methodology with human exposure modeling of ambient air concentrations as presented in section 2.23 of the draft population exposure for 1,3-butadiene, which is based on both discrete distances and census blocks to inform cancer risk evaluation, which are described in sections 5.342 and 5.343 of the draft risk evaluation for 1,3-butadiene. Please comment on the strengths and limitations of determining exposure and risk at radial distances. Please comment on the strengths and limitations of determining risk at census blocks. Please comment on EPA's conclusion that refined modeling of ambient air concentrations was necessary to inform cancer risk evaluation.
Thank you for getting that into the record for us. And now Ms. Jenkins will lead our discussion.
Thank you. We'll be fine. So we kind of have it combined with the other sub-3 subparts 1, 2, and 3 into this. So is that going to be okay, or?
So should all three questions be read, 1, 2, and 3 at this time, since she has a summary response for 1, 2, and 3, or not?
Yeah, is that what you're saying?
Well, I'm looking through here. I mean, I guess I do have separate for 1, 2, and 3. Well, let's keep it like this, and then we'll do separate. You know,
okay.
The sub 1, 2, and 3. I'm sorry.
Okay. You're fine.
So let's see. Pros of the HEM model. There's a strong advantage of HEM from its transparency and more understandable methodology. This is a model that aggregates sources of exposure reported to TRI, although it's not a complete aggregate estimate. It can start considering the basic exposure over which the plant emissions are contributing. Having generalized assumptions might make it rigid in some aspects, and some might consider it conservative. For screening, this HEM model may be a better approach. It uses more local meteorological data. limitations of the model. TRI sources are the only basis of the modeling, and both HEM and IOAC produce similar results. Aggregate exposures from other sources are not included. The HEM, there's inability to identify potentially exposed or susceptible subpopulations or pests. It doesn't consider the releases of co-chemicals like we just discussed. The HEM model as applied by EPA has several limitations, the inability to identify pests and consider releases of co-chemicals. Because of those limitations, the model may have underestimated cancer risk to pests and didn't provide an adequate screening assessment of cancer risk as required by the TSCA amended by the Wattenberg Act. HEM captures the exposures at the different sites and therefore considers either a single or multiple facilities that might generate emissions of 1,3-butadiene, which is an advantage over the IOAC. There might be a consideration about variability across time, given the relative homogeneity and stability of these facilities. This might not be an important factor to consider. HEM uses AirMod for dispersion modeling, and so does IOAC. Might consider adding the advantage of IOAC when the goal is to estimate population exposure and not focus on regulating one facility.
Ms. Jenkins, I think you've frozen. Oh, it looks like we've lost her.
Okay.
Allie, or did we lose Ms. Jenkins?
I see her frozen as well.
Not sure how to proceed here, as she is our lead discussant for all of these questions.
Let me see if she had emailed the summary response to you and I, and then we can just continue where she left off. And we can also get in touch with her. Or if there's an associate discussant that happens to have her summary response available, they can come online and read it.
Do any of the associates, Dr. Hopkins, McKenzie, or Santos Bourgeois, want to try to lead us through this?
Another option is that we can move on to the next charge question and return to this one.
She's the next 4.
Might have to go to charge question number 5E.
So are there none of the associate discussants that can work through this for us?
I can read where she was reading from the summary.
Yeah, if you
I
can,
might not have some of the nuances she was going to add to it, though. Okay,
well, and perhaps if you do that over the evening or tomorrow, y'all can compare notes, and if there was something that was missing, it can get read into the record later. Is that okay?
Okay.
Yeah. I think that sounds good.
That's great. Thank you for stepping up.
Okay.
Thank you.
And so I'll just start. I wasn't quite sure where she stopped, but I'll just start with HEM captures the exposures at different sites and therefore considers either a single or multiple facilities that might generate emissions of 1,3-butadiene, an advantage over the IIOAC. There might be a consideration about variability across time, given the relative homogeneity and stability of these plants, this might not be an important factor to consider. HEM uses AirMod for dispersion modeling, and so does IIOAC. And what is the advantage of IIOAC when the goal is to estimate population exposure and not focus on regulating one facility? Under TSCA, EPA is required to evaluate risks posed by aggregate exposures. Aggregate exposures means the combined exposures of an individual experiences. This is very similar to what was in 2I. So I think I'll just, it's the same comment, it's just here under HEM. And then the recommendation is to clarify how aggregate exposures from multiple facilities were addressed and update with a method that can aggregate 1,3-butadiene emissions from other industrial and non-industrial sources of 1,3-butadiene. And an example of this method to do this is in Part 5 of the September 2024 draft proposed approach for consideration of chemical co-exposures. Under Section 6B of the Lautenberg Act, EPA is required to perform risk evaluations to determine whether chemicals present unreasonable risks to pests. And much of this comment was also read in under 2I, so it's pretty much repeated here. And the recommendation is to update the general population risk assessment for cancer to include an analysis to identify overburdened communities and other pests. As for 2I, workers were not considered as a pest, but this particularly applies to workers that live in the fence line communities. The recommendation is to consider workers as a potentially exposed susceptible subpopulation. Similar comments to considering as in 2I, considering the degradation products of 1,3-butadiene, formaldehyde, and acrolein in the risk assessment. And just pointing out the health risks from the co-exposures to formaldehyde and 1,3-butadiene is a particular concern because they're both leukeminogens. And additionally, exposures to benzene, another leukeminogen, should be considered. Co-exposure to benzene is likely in the geographical area with the highest cancer risks identified on Figure 5-1 of the draft risk evaluation because of co-located refineries. So there's a recommendation is to update the general population cancer risk assessment with an evaluation of cumulative risks from exposures to co-chemicals. Some specific comments, it would be helpful to overlay the locations of the points of release to Figures 5-1 of the draft risk assessment, risk evaluation. And then just bringing forward EDF's comment that they made yesterday. They noted that in the draft HEM NEI 2017 and 2020 preliminary exposure and risk analysis spreadsheet, EPA appears to have switched columns G and H, so that's stack height and exit gas temperature. And so we recommend that EPA check these spreadsheets. And then coming down to comment on the strengths and limitations of determining exposure and risk at radial distances. Radial distances are a good approach to estimate the dispersion of the substance, and the HEM model provides more detailed information than the IIOAC. So it's providing more intervals all the way up to 50,000 meters. While including the air mod, it considers the meteorological and the surface of the air being covered. Given the insistence of the assessors on using the IIOAC as a screening approach, the information from HEM is forced to use only 100 to 1,000 and 1,000 meters. The risk assessment deserves the full use of the potential from HEM. Radial distances are not based on actual residential locations and can include parts of a facility which would be considered on-site. 2, please comment on strengths and limitations of determining risk at census blocks. The 2020 census data was used in this analysis. The census was found to undercount children more than any other age group and undercount certain demographic groups, for example, Blacks and Hispanics. Fence line communities are likely undercounted. These limitations were not addressed. The combination of air modeling with census blocks identification of population gives this granularity of population that is needed for risk characterization. In the model provided to us, data was provided for us within a 50-kilometer radius, and I identified variables within that data that were not explicitly mentioned in the risk assessment document. Most importantly, the poverty, linguistic isolation, and schooling data. This is essential for the PES assessment. It was interesting for me to identify that within the 50-kilometer radii from any facility, we had more than 100 million US residents. Unadjusted estimates for other exposure factors are included in the model estimates, useful in considering the difference of risk between different socioeconomic demographic groups. Basing model on census blocks assumes that people live in one census block for their entire lifetime, and whether that is realistic or not, it induces uncertainty. It is mentioned in the limitations the fact that there are no considerations on photodegradation, certainty, a factor for 1,3-butadiene. That is not considered as well in the IOAC. However, I believe the input data for AirMod will record this as it happens and is identified within the monitors. 3, please comment on EPA's conclusion that refined modeling of ambient air concentrations was necessary to inform cancer risk evaluation. Agree that more refined modeling was needed to inform cancer risk evaluation, although the basis of the HEM model is also TRA data, and support even further refined modeling. However, ground truthing with ambient air monitoring data is necessary with any modeling approach. EPA's conclusion that refined modeling of ambient air concentration was necessary to inform the cancer risk evaluation is both appropriate and necessary. The strength of the HEM model is its ability to identify where chemicals are released, aggregate both stack and fugitive emissions, and apply regional meteorological and local topographic information for each source within a census block. EPA's conclusion is correct that refined modeling was needed. This is being provided by the HEM model. However, contrary to EPA, the IOAC is not a good approach for screening, and I would not support exclusions based on it. Therefore, a tiered approach seems not to be appropriate. The general approach should be to use the HEM, and as a second step, if needed, for other purpose, not for this risk assessment, is required to investigate a specific facility. The IOAC may be considered. And I think that's all of them. Yes.
All right. Thank you for getting us through that, Dr.
Yes, thank
McKenzie.
you. I'm so sorry. My internet went out and then came back on, so I appreciate it.
So first of all, it's always unfortunate when that happens, but it happened to me yesterday. So I understand completely. I hope that captured your comments, Ms. Jenkins, and we talked right when you were offline that perhaps you and Dr. McKenzie can compare what she read into the record and what you had, and if there's anything missing, provide that at a later time, maybe tomorrow or the next day. That's okay.
Yes.
And other comments, or Ms. Jenkins, if you were sure that there are things that you had in your document that would not have been in Dr. McKenzie's, we could certainly go through that now.
Which, how far did you get? Just through the first three? Those three? Mhm.
Just through question 2. Yes. Yes.
But I believe there was a charge question summary that went over 1, 2, and 3. Well, Dr. McKenzie, did you also read the little brief summary on 3 or?
No,
Okay.
I just read 2A Roman numeral 2. So, and then there were 3 specific things EPA wanted us to address within that, and that's what the 1, 2, 3 were.
Yeah,
Okay,
but you did
understood.
those 1, 2, 3.
1, 2, 3. Okay, all right. That clarifies things.
Yeah.
Thank you.
Arabic 1, 2, 3, not Roman 1, 2, 3. Okay. Okay, let's go to the associates real quick. Dr. Hopkins.
No, I don't have anything to add.
Okay. Dr. Santos Bourvois.
I think that she did an excellent job in putting everything together. It was a long one.
Okay. And then Ms. Jenkins, just to make sure, was there anything you know that you had in your comments that you don't think Dr. McKenzie
I don't think so, but we can check later.
Yeah, y'all can circle back, and we've got all week. We can, even if it happens on Friday, we can still get it in the record. It's okay. All right, now we're ready for charge question 2, Roman numeral 2A, Roman numeral 3.
Is nobody going to comment on this from the remaining of the committee?
Oh, I'm sorry, I forgot to ask. Are there comments from the rest of the committee? My mistake. Are there comments from the rest of the committee? Okay, if not, then we can move to charge question.
I guess I have one question. Do we also open it up to the agency to ask if they have any comments or feedback or not? Oh, you're on mute, Dr. Cobb.
I was going to wait till we got through all of these or got to the end of the day, but we can certainly circle back. Surely, are there questions or clarifying questions from EPA about these comments?
I think, Dr. Cobb, we're thinking the same as you, to listen to the Roman numeral 3 and 4, and then decide if we have a clarification.
Okay, that sounds great, and then we can proceed.
Thank you.
Hi, this is Kit Lee with EPA. Charge question 2A, III. Please comment on the strengths and limitations of model inputs. For example, the facility release information reported to the toxic release inventory, such as stack height, fugitive areas, days and hours of operation, as described in sections 222, 223, 31, and 32, as well as Appendix B of the draft general population exposures for 1,3-butadiene.
All right, thank you. And Ms. Jenkins is our lead discussant again.
I hate to ask this, but could I take like 5 minutes just to get it open again, because I lost it in my internet outage? So, or maybe go on to another question and come back to that.
So you've lost your
Well, I have to pull it up, so I don't want to just keep you waiting while I do that. So
I tell you what, why don't we just take a quick 5-minute break and let you do that?
Okay.
Yeah,
I appreciate
I think
it.
I think that's the best course of action, because otherwise we're just going to get all jumbled up.
Okay, thank you.
Yeah.
I'll be back in 5 minutes. Okay.
Okay, that sounds good. Okay, so can we put a timer on for 5 minutes or? Thank you. Okay, awesome. See you guys back in 5.
All right, welcome back, everybody, from the short break. And I see Ms. Jenkins is back up, perhaps ready to lead us through this charge question 2A sub 3.
I will start. So the reviewers had concerns with relying on TRI data as model inputs. The use of facility release information from the TRI for assessing exposure should be noted as a limitation. The data are self-reported and only estimates. Facilities rarely quantitatively measure their emissions. The violation records of the facilities assessed in this analysis should be evaluated by EPA to be included in the understanding of the uncertainty. For example, the EPA's enforcement and compliance history online indicates that the one facility the reviewer investigated, TPC facility in Houston, has high priority Clean Air Act violations over the past 12 quarters. Poor compliance history may indicate the facility lacks a good understanding of their emissions. EPA is aware of the need to improve the emissions data critical for performing air quality and risk analyses, as evidenced by the proposed updates to the air emissions reporting requirements. One commenter suggests that the draft general population exposure to 1,3-butadiene includes in section 1 a couple of schemes on the pathways of distribution of butadiene in the environment. There's a pathway not identified, and that refers to injection wells that have been used for discarding butadiene. The draft environmental media document indicates the tight control on injection wells that make it unlikely that butadiene could be released. It's important that given the lack of solar irradiation, the stability of the monomer, that it could exist for a long time in injection wells. This source can be added to the Superfund areas where butadiene could have been identified at least once. There's a facility in California, the Del Amo facility, which is a styrene monomer production, butadiene monomer production, and styrene butadiene plant that opened in 43 and closed in 71 and is now on the national priorities list. Maybe another site at Fort Detrick in Maryland. The draft environmental release and occupational exposure assessment indicates that 1,3-butadiene is also generated as a byproduct from the incomplete combustion of fuel. EPA did not assess environmental releases or occupational exposures resulting from 1,3-butadiene formed as a byproduct. EPA believes it is more appropriate to evaluate the potential risks arising from the product within the scope of the risk evaluation for fuel from which the 1,3-butadiene is produced, rather than the 1,3-butadiene risk evaluation. This statement is not clear, but could be clarified for not following the full aggregate assessment. It asks the reader to look at or wait for an assessment of fuel emissions. It's important that if we have a population already exposed to ambient butadiene and point emissions from manufacturing, that these will add exposure. The population risk should be considered in a complete assessment. There's other sources such as propane combustion known to generate higher amounts of butadiene than natural gas. It is estimated that 11 million people are exposed to it indoors, where sunlight transformation is much lower. The conditions of use considered for the modeling miss several areas that might be of interest. The reviewer provides a couple of, one epidemiology study and another, or maybe they're both epidemiology studies, where they are a description of processes in styrene butadiene rubber production. These were emitted in the tables for utilities and pilot plants. Both can have higher releases for their processes, and the specific nature of flexibility required in the work of pilot plants for the development of specialty rubbers. It is not clear if the latter are considered in the table when referring to specialty rubbers. So the commenter wonders why those two references were not provided, so we can provide those two, or why those references were not included in the assessment, and we can provide those two references. The consideration of continuous processing and assumptions of average release during the year, given that TRI is an annual reporting system, this should be looked under the possibility that not all facilities and not all processes are continuous. And in several occasions, there are batch processes. And so maybe adding a statement about continuous versus batch processes and how those relate to TRI. EPA describes 3 imputation methods: deterministic, probabilistic, and a combination of both. This is reasonable and recommend continuing to ensure the method of determination keeps or is being well recorded in the document. The assumptions for assigning days of work for several posts seem reasonable and are well informed. In section 2.3.3 on TRI, EPA mentions that due to reporting limitations, some sites that manufacture, process, or use 1,3-butadiene may not report to TRI and are therefore not included in EPA's assessment. An explanation should be provided for this, as it is hard to assess the importance and magnitude of these exclusions. EPA describes that NEI emissions data is categorized into point source data, area or non-point source data, on-road mobile source data, and non-road mobile source data. EPA included only point source data categories in the assessment of environmental releases in this risk evaluation. It is therefore possible to consider aggregate estimation. This reviewer recommends considering that to look at the real impact of additional exposure from plant emissions. The strength of the TRI model inputs is that the inputs are publicly available and transparent. There are several limitations of relying solely on TRI data, which outweigh the strengths. These limitations include using yearly averages for non-cancer risk, exclusion of small emitters, reliance on industry self-reporting, and exclusion of other inputs necessary to evaluate aggregated risk and co-exposures for pests. The model input of exposure based on emissions averaged over a year underestimates acute and intermediate exposures that could occur over the course of days to weeks. Acute and intermediate exposures could occur during accidental releases resulting from equipment malfunction, operator errors, spills, severe weather. 1,3-butadiene releases from severe weather and unexpected shutdowns have occurred, and the 2016 TSCA amendments direct EPA to consider conditions of use that are unintended but can be anticipated to occur. The POD, TRI reporting relies on facility compliance with release reporting and facility knowledge of all releases, particularly an issue for fugitive emissions and misses releases that are below reporting requirements. A recommendation is to update the general population risk assessment with an evaluation of industry compliance for reporting to TRI, records for reporting releases to the TRI, and it is not clear how reporting compliance was evaluated, and that modeled 1,3-butadiene ambient air concentrations align with measured ambient air concentrations at the fence line. And that concludes our comments. Thank you.
Thank you. Let's go to the associate discussants, Dr. Hopkins.
Thank you. I thought Allison did Dr. Jenkins did a good job of summarizing. I think I would just want to emphasize that we are, you know, taking note, I think, that as reviewers ourselves, in addition to the commenters that we had today and yesterday, are very concerned about the uncertainty with the emissions data and the sole use of that. And also, I think that there's this common theme of understanding the uncertainty in ways which we can accommodate with modeling, and how we could incorporate the actual monitoring data more specifically into the evaluation, so that the understanding of what we are relying on is evaluated in a more robust way. So I just, I think that that's all in the comments that Dr. Jenkins just read, but I just want to emphasize that this is something that we're hearing from the public commenters, and it's something that I think that we're all picking up on. So we want to make sure that we follow through on that one.
Yes, point taken. Dr. McKenzie?
Yeah, thank you, Ms. Jenkins, for reading all that in. I know it's all difficult to read sometimes. I just wanted to emphasize that this averaging emissions over a year, so just having an average annual emission for particularly for the non-cancer risks from TRI really is missing these acute and intermediate exposures. And given that we're looking at developmental and reproductive outcomes, it really is important to include those shorter term exposures that might be impacting the fetus.
Thank you. That's a great comment. Any other, Dr. Santos Bourgois? I'm sorry, I lost track.
Nothing to add. Thank you.
Now, Dr. Hopkins has her hand raised.
Yes, sorry. I wanted to make sure to add that it was brought out in the comments that we definitely need to have a mechanism to incorporate those emissions that are not routinely reported to TRI, because we understand exactly that it's really going to change the picture. I think it's incomplete without it, because there are so many of these startup shutdown and upset events. We have to have a mechanism to include that. Thank you.
Yeah, that's a great comment. And even though it doesn't affect necessarily these very large operators, if you have a small community where someone has got a small operation that falls below a TRI reporting limit, you can still have people exposed and the environment exposed as well. But I think this particular assessment, that's not as important as some of the others. So are there comments from other committee members? Okay. See no comments from other committee members. I think we can get to the wait, Dr. Ruth.
Yeah, I just wanted to comment to add my agreement to include acute and intermediate exposures that account for fetal effects, and to incorporate emissions that aren't included in the TRI. So I'll send over my comments. Thanks.
Yes. Thank you. Other comments? Okay, we can move to the last part of this charge question, Roman numeral 4.
Hi, this is Kit Lee with EPA. Charge question 2A, Roman numeral 4. To characterize 1,3-butadiene concentrations in ambient air, both monitoring and modeling data were evaluated, as described in sections 3.12 of the draft environmental media concentrations for 1,3-butadiene and sections 2.31 of the draft general population exposures for 1,3-butadiene. Please comment on how both modeling and monitoring data can be used in a comprehensive evidence integration to inform characterization of ambient air concentrations.
Thank you for getting that into the record for us. And Ms. Jenkins, we'll return to you for leading this discussion.
This one is going to be even draftier, but I did have a couple of points that I wanted to bring up first regarding that high measured data, which I sent to Ali a question about the AMTIC data in the appendix, where there was a column with like a standardized value in micrograms per cubic meter, which is the one listed as the high measured 24-hour value. And then also I just remembered this, but the data, at least I only looked at Texas data, but it was only through March 31st of 2021. It doesn't capture the whole year of 2021. So that should be noted, in the document, either that or include all of the data for 2021. So those are my first 2 points. And I think I have gone over a lot about the monitoring data available in Texas. And I think it's really important, especially when we're comparing modeled data to monitored data from across the US that is not including the large number of non-detect values, that it's really important for communication purposes not to do that, because the document reads that there's a general population risk from butadiene based on modeling and monitoring data, and it really should be clarified so that the public can understand the risks. So some of our comments. Because the TRI and NEI data are self-reported, they should not be assumed to be accurate and are likely underreporting. There are facilities with monitors nearby. Concentration should be modeled to that distance and then compared to the measured concentrations. Concentration differences from upwind and downwind of the facility could be used to quantify an estimate of the concentration from other sources. These should be used to provide a validation of models. In the case of the Milby monitor, and this one is in the city of Houston, but it's the Milby Park monitor, which is about 753 meters from the TPC facility. The modeled concentration should be similar at the 100 meters to 1,000 meter community IOAC estimate. Statements as to agreement or of concentration within one order of magnitude are made. It would be helpful to justify why this degree of difference is acceptable. Next comment. EPA has done intensive work on integrating different sources of information into its modeling for human exposure. We should acknowledge that the ideal would be to have a good distribution by census blocks of the general population personal exposure models obtained by direct personal exposures for a long period, and that these could be related to either the point fixed sources, mobile sources, or indoor sources of emission releases. EPA may discard information from peer-reviewed papers, like in the case of the general population personal exposures, because they are scarce or do not cover the expectations. Several of these papers are included in the draft media concentrations document. Agreed that these cannot be used for actual modeling, but could be useful papers that could be used to validate, confirm, or increase our trust in the data that is input into the models. I would suggest getting these data in the case of general exposure or occupational exposures on emissions from facilities where diverse sources exist. On the integration done by EPA throughout the documents, it's been concerning the lack of use of the AMTIC data that includes directly measured concentrations in air. The sources of data are well standardized monitoring sites with publicly available data, transparent in their methods, quality control, and data management. The spreadsheet provided by EPA further provides transparency on how the data can be managed. EPA identifies two limitations in this data set. The first one, that it does not represent annualized data that are not averaged and not directly comparable to the model data. On this argument, I would underline that the model data should be able to predict well what is being measured or a good fit, and not having annualized averages does not mean that these cannot be attained or estimated by different techniques as described in the technical report on HAPS in the 2020 EPA report on the environment. Results are included and provide some links for references on where that information can be found. And the last part. In section 6.1 of the draft environmental media concentrations for butadiene, the agency states that the AMTIC monitoring data cannot be directly compared to data modeled because the AMTIC data has not been annualized and represents a total aggregate concentration of from all 1,3-butadiene sources contributing to ambient air concentrations. EPA then concludes that the AMTIC data cannot be used to characterize exposures exclusively from TSCA COUs. However, no evidence is provided that annualized predicted ambient air concentrations from models based on TRI emission reporting reflect true emissions. It appears that the EPA has not verified the modeled ambient air concentrations from either model with measured concentrations. Without validation, it is not possible to evaluate how well the model concentrations predict actual contributions of 1,3-butadiene to ambient air concentration. Additionally, there appears to be no evaluation of industry compliance with TRI reporting. Recommend that EPA prioritize verification of modeled predictions with measurements and conduct an evaluation of industry compliance with TRI reporting. Under TSCA, EPA OPPT is required to perform risk evaluations consistent with best practices using the best available science. Best practice for risk assessment is to calculate non-cancer and cancer risk with total aggregate exposures from all sources that are representative of true world conditions. Under Section 6 of TSCA and the amended TSCA, EPA must consider the additive effect of the chemical under the COU in aggregate exposure when conducting a risk assessment. Note that small emitters of 1,3-butadiene may not be required to report to TRI. EPA recognizes its obligation to consider background exposures in its risk evaluation framework rule. Monitoring data more closely approximates true real-world exposures than modeled exposures based on TRI emissions reporting. There is evidence that the modeled exposures likely underestimate true real-world exposures, particularly for fence line communities. The technology review for the fence line monitoring supporting the new hazardous organic NESHAP found that the model ratio for 1,3-butadiene ambient air concentrations for 8 facilities ranged from 4.5 to 51.5. A recent study observed similar ratios of 1.3 to 69, and that using measured concentrations was more likely to identify locations with exceedances of health risk thresholds. Based on this evidence, use of modeled 1,3-butadiene ambient air concentrations may significantly underestimate non-cancer and cancer risk for the general population. Recommend that EPA update both the non-cancer and cancer risk assessment for the general population by prioritizing use of monitoring data that represents true real-world exposures in the general population, and add an assessment of for pests. And that concludes our comments on that charge question. Thank you.
Thank you for getting that into the record for us and providing that good summary. Do we have comments from any of the associate discussants? And we have Dr. Hopkins again.
Yes. Yes, I just wanted to restate something that we've been talking about earlier, which is these events that happen, the startup and shutdown events, and various upsets. At least in the city of Houston, and also working and understanding that they are not required to be reported to the TRI. So they are missed by the TRI unless they pass a specific threshold. So again, this is something that we want to make sure that we can bring out. And then I think that the model, and I mean, you know, the emphasis on bringing in the modeled, the monitoring data and the temporal aspect of it. We're just highlighting that again here, that's an important concept. In the situation where we are worried about the TRI and we know of things that are not being reported to the TRI, and we know that not all sources need to or required to report to the TRI, that's the emphasis of why we need the monitoring data involved. And this, you know, whether it's a separate model and we're comparing models, we're doing some kind of stochastic thing, that would be the reasoning.
Thank you. Dr. McKenzie?
Once again, thank you, Ms. Jenkins. Great job reading in those comments. And I would just like to also point out that in our public comments yesterday and today, we are written, and then in some of them oral comments, we have several stakeholders, or a couple stakeholders, really recommending that the monitoring data be used. And one of them was the ACC, and the other one was the Environmental Defense Fund. So.
Right. Thank you for that comment. Clarification. Dr. Santos Bourgois?
I think everything has been said.
Okay. Thank you. Other committee members? Any comments from other committee members? Okay. At this point, we'll circle back to EPA to see if there are any questions about the comments that have been made.
So we've done a room change. Can you hear me?
Yes.
Okay, great.
Coming through loud and clear.
You probably didn't realize this, Dr. Cobb, but we, those of us in DC got kicked out of our room. They actually turned the video off on us and everything. So we had to run down the elevator with our cell phones on to keep listening.
A mad scramble. Well, if we need to clarify anything or catch up, we'll be happy to do that.
Well, our North Carolina team was on the whole time, and I think we caught it through our phone. So I actually think we're okay, but we're being resilient here in DC today as best as we can.
Appreciate that.
So we appreciate all those comments, and I, just speaking for myself, I thought that response to the last part of the last question, for at least me, was the most clear and tangible with respect of some of the other comments we've heard over the last couple of hours. We've heard, here's the themes. I'm just speaking for myself and my colleague. I would encourage my Karen Eisenreich and Kathy Dionisio to help me out. So I've heard a couple of themes. There's the theme of aggregate, of how we have or have not considered exposures from multiple sources, understanding that there are certainly challenges in doing that I think this panel has recognized, both in the modeling approaches, but also the data availability. And the other challenge we have with aggregate is that as we follow the National Academy of Sciences, Science and Decisions recommendations, a risk assessment is a decision support tool, and our assessments are built to be risk management tools. And so to some extent, our focus on TSCA conditions of use, because we are in the position to manage those if we find unreasonable risk, is part of the sort of underlying decisions there. But we certainly have heard a theme around aggregate today. We've also heard a theme around pests. And to some extent, maybe some clarity from the panel, either now or in the morning, around what you mean by that. Are there specific groups that you're perceiving that we did not account for? I'm actually starting to wonder if maybe our narrative did not do a good job of explaining how our assessment is expected to be protective of the full population, and maybe we need to do a better job of explaining that. But it would be, we've heard quite a bit about the SIP2, the SIP induction, but are other pests that you've identified that maybe we didn't, or that I'm also wondering if there's information maybe deep in some of the TSDs or the appendices that need to be brought forward that demonstrate that we have in fact looked at a variety of life stages and other pest factors. So the third theme that I've heard is around this sort of use of the term underestimating risk. I'd really like to understand what's meant by that. If there's a connected to the first two themes, that there's a concern that because we haven't done aggregate in a way that this panel would like, that you believe we're underestimating, or is it that because we haven't been clear about how our assessment is protective of the full population, that there's a concern that we're underestimating? Or is it a third thing that has to do with our inputs? So I would ask Karen and Kathy if they had anything to add. But first, did we get the themes right? And is there additional specific things that you can help us understand that we can do quickly, realizing that we're under this court order deadline and we can't go find a new model? We can't, move to probabilistic. We don't have a PBBK model. So we have some limitations.
So before we go to additional clarifications from the agency, let me give this back to the lead and associate discussants to try to answer the questions that you've posed, Dr. Lowe. So Ms. Jenkins or Dr. McKenzie, others? Oh, Dr. Bourgois.
Yes, maybe I can address a couple of these concerns. On the issue of pests, I don't see how socioeconomic differences were considered. I don't see where they are mentioned, but I don't see where in the assessment this was included. And in terms of the underestimating of the risk, I think yes, it might have more to do with the inputs and from my perspective, the risk parameters that or the benchmarks and the that you use to estimate the population risk. So maybe that is a concern that we are going to discuss when we discuss hazards.
Okay, and Ms. Jenkins? Do you have any response to Dr. Lowe?
I not really, except I think with the modeling results, we had many concerns with them being too maybe crude, I guess, and really wanted some ground truthing. of the modeling results with longer term air monitoring data to see if it's even, without that, it's really hard to know if it's underestimating or overestimating risk. And so I think by incorporating a comparison, that would help.
Yes. Other responses from the discussants? Yeah, Dr. McKenzie.
Yeah, so I think that so coming back to the aggregate exposures, if you're not looking at all the sources, you're not even looking at all the industrial sources in an aggregate exposures, then that would lead to an underestimation of risk. And I think some of these things that we've mentioned are kind of rolling together and just compounding the estimation of risk. And then for the pest communities, we've done a little bit with fence line communities, but there's a lot missing there. So there are other things that they're being exposed to, and particularly with similar health outcomes, they're more likely to then have health outcomes with the additional 1,3-butadiene exposures. And then finally, when you take an averaged annual concentration of 1,3-butadiene, that really just misses all the nuance that's in the data, and likely what I'm trying to say here is it just averages out any increased risk that might be there. Your ability to see them.
Yeah, and this George Cobb speaking, that perhaps goes to the need for acute risk evaluation as well, when you're experiencing fluctuations in peak concentration. Dr. Rubin.
Yeah, Dr. Rubin, I just wanted to add to the list of themes too that the topic of degradation products was discussed, especially in the context of considering groups of exposures.
Yeah, and that's a big point. And I did a back of the envelope calculation, and depending on the way you look at this, you can get between 38% up to well over 100% of the butadiene, excuse me, the threshold formaldehyde toxicity that EPA has put forth in their formaldehyde risk assessment from butadiene in the atmosphere. So that's a big hole, and if it's not assessed, then it speaks to the need to have added conservatism in any other assumptions that are made in the assessment. Ms. Jenkins, I see your picture, but I don't see your hand. But I'm gonna acknowledge you.
Thank you. Just another point about the air monitoring data, in that it's not only looking just at 1,3-butadiene, but a number of other VOCs. The canister, I don't remember the numbers off the top of my head, but the canister is looking at 80 plus VOCs in the AutoGC data. It's also looking at other VOCs as well, maybe even more, I think. So I think we will often look at monitoring data and take a lot of, using EPA guidance and other guidance on locating monitors where people are exposed and looking at evaluating those concentrations. And by doing that, we are seeing the presence or absence of many VOCs.
Yes, exactly. Dr. McKenzie.
And just going back to understanding under court order to have this risk assessment finalized here this year. And so you're limited in what you can do in that time. I think at the very least, the uncertainty and confidence in risk assessment sections could be rewritten to acknowledge these limitations and their impact on the risk assessment. I'm worried, based on previous risk assessments and how long they lasted before any updates, it is concerning that this final risk assessment will probably be the risk assessment for another 10 to 20 years.
Are there other comments?
Or in perpetuity.
Yes. I have one comment, and maybe Ms. Jenkins knows the answer to this, or others on the committee, or even from EPA, is that when we're looking at monitoring data versus modeling data, how well do we understand when the modeling data are upwind, downwind, or something in between for the measured estimates? And I guess I'll ask Ms. Jenkins at first, and maybe the agency, if there's not an clear understanding of that.
Yes, I'm not the person to really, we do take upwind and downwind samples in some situations, but really we're concerned of what people are exposed to, regardless of, we do more in-depth analyses when we're trying to find sources of chemicals, but, we look at monitoring data for each monitor, assuming that, there's people being exposed to ambient air in the vicinity of that monitor. So
the monitoring station is near the human population, regardless of whether it's upwind or downwind. Is that what you're
yes
saying?
And then if you can do further analyses to determine sources and using wind direction and things like that. So, but all those things come into play, I think, in monitor placement as well, right? You want to, where you locate your stationary monitors. And that's not including also, yes, the monitors that are in vehicles that we also utilize, and I think lots of other people utilize mobile monitors.
Right. So I think that kind of answers my question, but that is one of the, not disconnects, but one of the intricacies in trying to match modeled data to measured data. So are there other comments from the committee? I don't see any. I'm going to go back to EPA to see if there's anything you'd like to add to the discussion we were just having, or if you'd like to ask more clarifying questions.
Yeah, thank you, Dr. Cobb. This is Kathy Denisio, EPA. I think I might have two clarifying questions. So the first is for Dr. Jenkins, and it's back to this question that Anna started with, this question of, underestimating risks and that language that we're hearing. And I'm just trying to understand, because I think something that Dr. Jenkins just said was important to clarify for me. So I'm wondering if the question really that's being discussed is more about the precision of our exposure estimates, because I heard a comment about, our modeling results are too crude and we need to ground truth them to monitoring. And, I think there's a difference between arguing that our exposure estimates are precise, right, which we would want them ground truth to the monitoring data, versus that they're crude but protective, conservative enough to be a screening level approach. So I'm hoping you can clarify, because you said something about what we don't know if they're underestimating or overestimating. That clarity on that answer will really help us to understand how best to improve the analysis. Does that make sense?
Yes, I think that probably some of the other people that commented on some of the other issues that you're referring to can weigh in on this as well. I think it was just difficult to the way that the modeled data was compared to the monitoring data, it was difficult to really come to any, firm conclusion on that, because we were looking at long-term model data compared to a 24-hour, an average of 24-hour concentrations from across the whole US with all the non-detects removed. And looking at one high 24-hour sample, it was just difficult to make, any conclusions from that. So that's where my concern was, and I'll let the other discussants weigh in on their feelings about that. Does that help?
Does. I think what would be, it does help, but I think would be most helpful if I can put in a plug for, and you don't have to give this answer right now, but for the group is some recommendations in the response to the written charge question about how we can do it better. It is, I mean, that's, why we put the charge, that's why we put that portion of the charge question focused on, how do we do a better job of using when we do have both monitoring and modeling data. So any recommendations you or others have would be greatly appreciated in that response.
And I think, part of it was working, like I said before, where there are so many different regulations. I mean, I've worked for the state for many, many years, and I still feel like I don't know all the different regulatory programs. And so, I can speak to a small part of it, but, I think it would benefit everybody to have an understanding of all the different regulations that apply to these types of facilities, at the beginning, or, something that we can read so that we all know about that. But I can also provide, links to our data and our database and our evaluations that we do every year, including betadine that we do for all the regions in the state. So I'm happy to do that. And I can
please do
that
that
as part of the comment.
Absolutely. Please do.
Thank you.
So, and just to circle back on a little bit of that, that data, not call-in necessarily, but requests for states to provide that kind of information and the specific regulatory agencies in the states was something the SAC's been recommending since like the third or fourth chemical that we reviewed. Is, it would serve everybody well if the agency specifically reached out to states and said, hey, please send us anything that you've got about this topic. Texas would probably have a lot because of the agency size. Texas, California, maybe New York, state of Washington had a bunch of information on some recent assessment. So are there other discussants on this? Dr. Hopkins, Dr. McKenzie, Dr. Santos Bagua, that would like to provide any insights here?
I am okay. I don't have anything to add.
Okay. I see Mr. Wright has his hand raised.
Yeah, on the subject of reaching out, are we also talking about other federal agencies like OSHA? And are we talking about toxicity in general or other hazards of 1,3-butadiene?
Well, right now we're technically talking about exposure, but I mean that in the spirit of what we're talking about, yeah, I think looking through all of the different federal agencies, but I think a bunch of OSHA information was in this one, but
yes, it is.
That's a general comment as well.
Yeah. But for example, the EPA RNP program, OSHA's process safety management standard, things like that.
Yes. Okay. Are there other clarifying questions from EPA?
I don't, so looking around the room and our North Carolina colleagues, I don't think we have any additional clarifications. We really appreciate that dialogue and the additional conversation about those topics, because there's tangible, workable, things are what we really need right now. But just for myself, putting my hat on, taking off my scientist hat and putting on my science advisor hat, as representative of the office, I would just ask you to, when you start writing the report and writing your, just pieces or improving the pieces, understand from a, statutory point of view, when our assessments are so uncertain that they fall in the low uncertainty category, our risk managers will have a very difficult time mitigating those risks and moving them forward as called unreasonable risk. And so there's a level of uncertainty.
We lost you, Dr. Lowett.
We lost you on the audio, Dr. Lowett. We can't hear you, Dr. Lowett.
Allie, maybe they can't hear us.
So,
I'll get in communication with them.
uncertainty that we can. Allie?
Yeah, we lost
Okay,
you
now
there
we
for a
can.
minute.
Yeah, but we can hear you now. We can hear you now.
Okay.
Okay, so we.
You would just put on your your policy advisor hat.
Yeah.
Oh, okay, then
So-
I'll start from putting on my science policy, science advisor hat.
So we
I'll
did
talk
hear.
to the microphone. I'll move the microphone closer to me. Is that better?
Yes.
So if I think about it from my science advisor hat, and I think about the interconnectivity of the risk assessment and the unreasonable risk determination, which I know is outside of your purview, and we're very careful to keep you outside of the policy realm. I just need you to be cognizant in your writing that if we, as was recommended by one of the panelists, I can't remember which one, to think about piling on more uncertainties. You need to understand that if the uncertainties and strengths issues around the assessment becomes so uncertain, it will also become not unreasonable. And so risks that might be managed, even if not perfect, we won't be managing those risks because the results are so uncertain. So I would ask you to be cognizant in your report that we're talking about improvements to the assessment, additional things that we can do, as opposed to this assessment is so uncertain. I've heard a couple of panelists actually say something to the effect of, it's not a robust assessment, it's too uncertain. I would need you to understand when we start using words like that, it makes the assessment so uncertain that those risks will no longer be unreasonable from a policy standpoint. So as we think about as you think about your comments in your writing, the things that you're asking, that you've talked to us about, are we talking about making our assessment more precise? Are we improving the narrative and the characterization? Because we still, even after today, are pretty confident in our assessment. We recognize that there are things that we have not done and we cannot do. But given the tools and the information we have right now, we're pretty confident in moving those risks to our risk managers. We know there's things we can do, and there may be some things that change. Not everything in the draft becomes the same in the final. But I just want you to understand, if we pile on so many uncertainties, the unreasonable risk determination changes substantively.
Okay, we've heard that, and I think the committee has kind of spoken to that in the past, saying that it's not scientifically defensible to to have that policy decision, but that's right at the cusp of science and policy, and we are not necessarily here to debate that. So let's see if there are any closing thoughts from our committee. If not, I think we can adjourn for the day and pick back up on 5E tomorrow. Okay, I'm going to turn it over to Ms. Munir to close us out for the day.
Thank you, Dr. Cobb. So I want to thank everybody for attending and participating in today's SAC meeting, day 2. Once again, we had some great public oral comments and great discussions in response to the public oral comments. I want to thank everybody for going over the charge questions and for providing discussion deliberations to a lot of the responses to the charge questions. That is all from me for now. I'll turn it back over to Dr. Cobb.
Thank you. And we'll stand adjourned for the day and pick back up tomorrow at, I believe it is 10 a.m. Eastern time. And we'll start with charge question 5E. Thank you, everyone.
Thank you. Have a good evening. Goodbye.
So I'm